And finally, ladies and gentlemen, React Global is the biggest online summit for React community on the web in 2021. Welcome, welcome, welcome. I'm so happy. 15,000 registrations. Can you imagine that? I'm so happy to welcome you here. I'm Nedin, by the way. I'm CEO and founder of Geekle. And our mission is to find the most innovative use cases for developers and deliver to you people. And this summit is gathered by our community manager, Anna. Welcome, Anna. Get in. How are you?
Hi, I'm fine. Thank you so much.
How do you feel? Well, what's emotions? What is it?
I'm a little bit nervous because we have so many people here. We have so many attendees. We have so many speakers, and we are responsible for them. So yeah, I'm a little bit nervous.
We feel responsible for all innovations in the world, also for engineers. Yeah. By the way, people write in the chat, where are you from? What country? What city? Or maybe what room you're looking us from? And it will be super exciting for us because we're here for you. So Anna, what is gonna be at this event? What we're gonna expect here?
So it will be quite big event. We will have 2 days. Today days for junior developers, and tomorrow we are expecting to have senior developers with us. Also, we have 29 speakers.
29 speakers
to share the most unique knowledge. Their use cases, everything they got, they would like to share with you.
How did you manage to get that much content for our audience?
It was quite interesting task because we have so big React community and a lot of people are willing to share, and it's really hard to choose the best and to ask them to give that information for you.
Yeah, kind of that. And thank you very much to our program committee people. Thanks for helping us to choose what actually worth to talk about. Yeah, thank you.
You helped me a lot. You saved me. Honestly, you just saved me.
Awesome. And we also have 12 community partners. Am I right?
Yes, they were sharing information about our event everywhere, between different communities, different social media. So thank you for that as well.
Thanks, guys. And sponsors time.
Yeah, we have 5 sponsors, and guys, thank you so much. You are helping us to deliver the best content.
Yeah, it is. Thanks for this support, and also thank you very much for everyone who paid at least $1 for these tickets. People, you are actually who support us and help us to grow this project. Thank you very much. And also, by the way, how long did you work on that event?
Mostly 4 months.
4 months. Our team was working on it. Yeah, thanks. So 15,000 people are waiting for this content, for these use cases. And let's know more. Do we have to say something like more thanks or something, or we can go straight to the point?
I think that now I'll tell you more about our activities. You will know how to get a lot of amazing prize. I'm telling you, I'd like to get some of them.
Yeah, go on.
So I'll tell you about that, and then you will see that content.
Yeah, so the floor is yours, and so let's do it.
Yeah, thank you. Yes, it's time to tell you how you can win all amazing prizes that we prepared for you. We prepared quite a lot. So, you can win 1 Apple Watch from our amazing sponsor Intellias, and you can watch 1 Macbook that we prepared for you. What you have to do? For receiving your Apple Watch, you just have to be very active, wait for our special activity for you, answer for questions, and you can be one of those people who can win. Also, to win 1 MacBook, you just have to follow next steps. Just subscribe here, please. We are working so hard for you. Also, give us like because we are doing the streaming for you. Find us on Instagram, React Fellows. Subscribe. Find a post regarding MacBook, like, comment, and you can be one of that people who can win 1 MacBook for you. But there is one small condition. We need to reach 1,000 likes here, on our streaming. I think it's quite easy. And we prepare some other prizes for you. 5 tickets for tomorrow, for Senior Day. Also, 5 tickets for our next React Global Online Summit. 5 annual subscription to all our events in 2022, and 10 free licenses from JetBrains. I think it's quite a lot for you. So guys, please be active. Check all our notifications that we will have here. It will be run in line. Just check it there. And I hope you can get one of your prize.
Hello, everyone. Nick here. So I'm just gonna say hi to everyone because I'm gonna be also helping Anna with this event. And just a couple of words to all our attendees. Like, make sure you check out the agenda. That's if you are watching from YouTube or LinkedIn, just look in the description. If you are watching on our platform, just click in top right corner somewhere here, and there's the menu. There's also a schedule link, and also just couple last words before we start and give the stage to our first moderator. So please check out one of our speakers who is going to present today. Prepared a free workshop about crash course into the Jamstack with Next.js and Storyblock. I'm gonna just put this link in the chat right here. So make sure to check this out. So one chat and the other one. And there's also another workshop from also speaker who will be presenting today from Josh Goldberg. It's converting a React app to TypeScript. So I'm also thanking this to the chat. And yeah, so like we are starting right now, and I have our very first moderator for today. Hey there. Hey, Matthias.
Hey everyone, how are you? Thanks, Nick.
Yeah, so without any further ado, I'm going to leave the stage to you. Good luck.
Okay, thanks. Thank you very much. Hi everyone, I'm really happy to be here with you today. Unfortunately online and not for real, but I guess it will happen soon. I hope so. At least. So happy to see you, everyone. Happy to see you are coming from a lot of places, a lot of different cities. I see people coming from Antarctica, coming from South Africa, coming from Mordor. Okay, it should be really hot right there. I'm streaming from France today. I'm saying this session for all the matinee. So because it's matinee here. So I'm really happy to be with you. We're gonna have a lot of great talks, a lot of great speakers together today. So be comfortable, install yourself, grab a big cup of tea or a big cup of coffee if you want. And let me introduce our first speaker to the stream. So hello, Alexandru. Oh, I guess we can't hear you. Maybe you were muted at some point or something like that. Okay, let's try to fix it in a quick. Nick, I let you do that. And in the meantime, so we're gonna have a lot of great talk today with different topic. Today is the junior track. Tomorrow will be the senior one. We've got many talks regarding introduction to different topics like augmented reality or localization and so on. So I'd be glad to host everyone here. Don't forget to just comment and interact with the chat. If you have any question for our great speakers, let me know on the platform, and I'd be really happy to ask them during the QA sessions. Hope everything will be okay after that. And for the rest, well, during the fix with Nick, let me just maybe. Oh, Alexandru, you're back.
Hello, can you hear me now?
Yeah, that's perfect. Hi,
Okay,
happy to meet
perfect.
you.
I'm lucky today.
Yeah, but technology, it's always the same thing. So, you're a web developer at Adobe, that's it?
Yes, and to be honest, I don't want to waste our time talking about me. I
Okay,
can say that I'm Alex and I like JavaScript, and that's all you need to know.
okay, that's great. So, I leave the stage, so let's talk about augmented reality for the web. So, the stage is yours.
Perfect. I will share my screen in a moment.
Yeah,
Okay, let me know if you can see the presentation.
yeah, awesome.
Okay. Um, to be honest, I have prepared this presentation some weeks ago, but because I'm unlucky, last week Facebook announced their changing name to Meta and the new Metaverse. So I decided to create a new presentation, and I want to launch you a challenge. In the new Metaverse, Facebook decided to be bold and try to anticipate how our life will change with augmented reality and virtual reality. They think AR and VR will impact the way we socialize, the way we learn, the way we play games. So what we are gonna do in the next minutes is that we are gonna watch two videos about gaming and education in the new metaverse, and by the end of the presentation, I want us to be able to answer one question: how far are we from the new metaverse? What's possible? What's not yet possible? What's gonna remain a fairy tale forever? So, without any more introduction, I will go to the first video about gaming in the new metaverse. And you will not hear the sound because I want to talk during the videos, but I will try to explain you and challenge you with questions. So, in the new metaverse, the way we play games will be very different. Here is an example with an AR chess game between two people who are not even in the same location. And everything, the board, the pieces, is computer generated. We even have filters for the face. And another example for the ping pong game, where again the people are not in the same location, and their game is different from the one that we are used to. And a question would be, how far uh, are we from something like that? I will not answer the question now, and I will move to the way Facebook or Meta thinks education will look like in the near future. So, for example, let's say that we want to learn something new about the planets and astronomy. Nowadays, we can use the internet or books, but in the future, we will be able to see planets and to have in front of our eyes um, an entire world, after all. We will be able to touch elements and to move them and to rotate, to travel between planets um, in this way. And this is a world based on AR and VR. For example, if someone wants to learn about the ancient Rome, they will be able to take a walk through the city and interact with people who lived thousands of years before. And I'm not gonna say this is impossible, but at the first look, it seemed for me to be a sci-fi movie, something very far away in the future. Well, in order for us to decide what's possible and what's not, we first need to understand the current state of technology. And I know what I'm gonna present in the next minutes will be less interesting than the universe Meta created, but it's important for us to understand where we are and where we want to go. You will hear in this presentation a lot the term extended reality. And extended reality is a bigger collection for virtual reality, augmented reality, and merged or mixed reality. Well, you all are probably very familiar with the virtual reality. It's the one where you have a headset and you are teleported in a completely digital world. Everything around you is generated on the computer. So you can be in Minecraft or you can be on a jungle, and everything is generated by the computer. On the other hand, we have the augmented reality, which happens in the real world. You are still in your living room or in the kitchen, and everything is normal except the fact that we also display some augmented elements, some computer generated objects, and this can happen using your phone, the smartphone we all have nowadays. Or if you want a hands-free experience, you can use some glasses which are created to the especially for augmented reality and are very similar to our normal glasses. And somewhere in between virtual reality and augmented reality is merged reality or mixed reality. Well, the distinction is harder to make, but merged reality is when you control two worlds at the same time. So, for example, you obviously control the real world, but if you want to see how a new lamp will look on your desk, you will be able to place on your desk a computer generated lamp from Amazon, let's say, and this will interact with the real world. So we detect the surface of the table, we can move something on the table, we have collision and things like that. Merged reality is probably harder to put in a category, but at least you should know the difference between virtual and augmented reality. Now, there are different types of augmented reality. The first one we are going to talk about is the AR based on markers. On the right side of the screen, you can see a marker, which is basically just a black box with something inside. And this something can be a text, can be a symbol, can be anything at all. And when the AR application will see this marker, will know to render something that we want. In this example is a cube, but it can be the new keyboard from Amazon or anything else you want to display on the screen. Now, the markers doesn't even have to be the standard one, you can create your own markers. And this is not hard. It's basically a simple drag and drop process. What does it mean? It means that you will need a picture, for example, your company logo or something you want to be your marker. You will upload it on a website which uses artificial intelligence on the back, and it will create for you a pet file which if you see is a file that we humans can't really understand, a lot of different numbers, but these numbers will describe the image to the AR application. And finally, in code is only one line or two lines of HTML to tell the application to use the pet file that was generated for you. Okay, and you will say, but why do I need to create my own markers? Well, because of that. Let's say that you are a fan of Pokemon and you want to display your Pokemons using your Pokeball logo. You can do that. And despite the fact that the website uses artificial intelligence to generate it for us, and there is an entire discussion about that, you don't need to know anything. You just need to drag and drop your image and you have your marker. Okay, but how is it related to the metaverse that we had at the beginning? Well, let's go back to the metaverse, to the first video. And you seen two people playing chess. Well, here is an example of that, of two people playing chess with a marker-based AR. We have a physical table, but at the same time, the chess pieces, the pawn, the bishop, the queen, the king, are not actually there, are not real, but the AR application will recognize different markers and will display the AR pieces. So how close is this to what we seen in the first video? I would say is somewhere in between. We still don't have holograms. We still can't play with someone from the other side of the world. And we need markers. So it's something in between. Now, another type of augmented reality is the one with image recognition. Maybe you don't want to use markers anymore and you want to use real images. You can see on the right side of the screen, we have the picture of T-Rex and the 3D model that we want to display. The process to make this image recognizable is very similar to the marker process. You need to use an application created for that to load the image, and the AI will generate for you 3 files which will be used by the AR application to understand how and when should display our 3D object. And despite the fact that this is really cool, from my point of view, this is a game changer because the applications for the image recognition AR are unlimited. You saw in the second video learning about planets and being able to see the planets in 3D. Well, we have a biology book, and based on image recognition, when we recognize the human skull, we can display our 3D model, and the students are able to see every single bone of the human skull with additional information. And this is possible thanks to image recognition and augmented reality. The second example will be with the human eye. It's the same process. And if you ask me, on this side, we are close to what we saw in the meta video. I mean, we just need glasses or a phone, and we are able to interact with medicine or astronomy or everything else in a way that simply changes everything. Okay, I will move to the next type of AR, which is the location-based AR. And the example is one that we use every day, is about Google Maps. So you can see that we have our normal everyday street. People are amazed by that, and I hope you are too. And while we walk on the street, we simply see the information on our phone. We know when we need to turn right, and we will also be able to find more about the restaurants or the hotels or everything we want with reviews. Um, they even created a virtual guide for us if you are alone and want to travel to a new city. And this location based AR doesn't really have anything special. It uses the same thing that Google Maps does, our GPS, accelerator, and so on. The next and the final type of AR is the one with portals, because in the second part of the meta proposal, we had the opportunity to visit the ancient Rome. And as a good news, you are able to do that right now. We only need 360 image, and we can create portals. So from your own home, you can take a walk in the Minecraft or ancient Rome or a jungle. And this is not only something to be a wow effect, to be something amazing. But let's say that you are a hotel and you want to promote your rooms, or that you are a real estate agency and you want to sell an apartment. Now, the clients will be able to visit an apartment simply by going through the door and taking a walk inside. And you will wonder, okay, but how difficult is this for me to do if I want, let's say, tomorrow to create this? Well, you will need a 360 image, which can be created with your smartphone. You don't need any special equipment for that. And after you have the image, one simple search on Google show us that in 5 minutes you can create the portal effect, and you can do that with a lot of technologies. You can do that with JavaScript and React, or for mobile you can use React Native, or you can use Java if you want. You can use C Sharp. You can use absolutely anything, and in 5 minutes you can create your own portal experience. Now, this is possible because we have frameworks to help us, but it's true that the artificial intelligence behind of it is something that someone really had to work a lot for. The sky is the limit, or at least kind of. The last application I want to show you is a coloring book created by Disney, and you will see that this is a very good example of mixed reality. A child will color an elephant, and at the same time we can see the elephant from the AR application, and is coloring at the same time and is rotating when we rotate the physical piece of paper. So this is mixed reality, and this basically means that you control two worlds at the same time. One is real and one is augmented. Now, I will move to the coding time because I think we only have about 10 minutes left. But before starting to get our hands dirty, please don't forget to write your questions in the chat, and I will try at the end to answer as many questions as possible. And I want to make a confession and to tell you that the title of the presentation is a clickbait. Yeah, let me be clear. The title of the presentation is a clickbait. Why? Because this is a React conference, and of course we are going to talk about React. But augmented reality is not dependent on a framework. We can create augmented reality with React, but we can create augmented reality with Angular or with Vue.js or with jQuery or with your vanilla JavaScript. And what happens, I hope you can see the laser point. What happens is that the foundation is created by 3JS, which is a 3D library, and will let us to create 3D cubes or other geometrical forms, or to display 3D objects like the new chair from IKEA. And there is also AR.js, which knows to do the marker-based AR, the location-based AR, and the image recognition AR. And on top of that, you will be able to use your favorite framework. So you will need to use React 3 Fiber in order to use 3JS with React. And also for AR.js, there is another React 3 AR.js npm package, which is still in development, because this whole AR VR world is creating in front of us right now. So some things are and will still be in deployment in development. Now, I have some examples of using 3JS, and I want us to start from the very beginning with 3JS, and then to learn to use ARJS, and then to learn to use React. But because we don't have a lot of time, I will start by showing you the final result. And then we will discuss as much as possible in the time we have about the code. So the final application that I created for this presentation is not something amazing, to be honest. It's just an example of using 3JS, the 3D library, with ARJS to display a 3D object. So when I tap on the screen, I have in my living room the 3D object that I wanted to display. And you will see that it is floating in the air. That's because I didn't use a marker to position my object. And because I'm a bad programmer, I actually tapped twice on the screen. So we have two instances of the same 3D object. And because it's a React conference, and I promised you Hello World React, this is an example created with React, where again in my living room, I display a cuboid and a piece of text. And when I click or I tap the screen, the color of the cuboid is changing to another random color. Okay, and now I will change my share screen from the PowerPoint presentation to the code. And let me just quickly do that. So I stopped the share screen. And I want us to start with the React example because I don't know how much time we will have for anything else. But for the React example, you will see it's not complicated at all. Okay, the second screen. Please write in the chat if you can see the VS Code. And what's happening here? I will assume that you already know React, but if you don't, it's not a problem. This is the junior track, so it's perfectly fine for you not to be able to know everything about React. But our code is really simple. What we do is that we import React tree, which is the uh, let's say the React version of 3JS, and we have React tree XR extended reality and another React tree helper library. What we do is that we display two elements. The first one is the cuboid, which has a color. The default color is blue, and we have a function that will generate a new color for us. So every time I touch the cuboid, um, it will change the color. The function to generate a random color is not important for us. It's something you can do with JavaScript. But as you can see, our entire application is only 52 lines of code with spaces. The text component, again, is very simple. We define the font size, the color, and the text to display. And also the box component is not something that comes out of the box. It's a component that I created. And that will use something from 3JS called a mess. A mess basically is an object which is defined by a geometrical form and a material. The material will give us the color, and the geometrical form will tell us if it's a pyramid or a cube or a cuboid or anything else we want to display. And this is React 3 code, but behind of that we have a 3JS code. So I will move from VS Code to the first example of using 3JS. And the moderators, please let me know when we are out of time, because I don't want to make this too long. The hello world of our 3D library 3JS is displaying a 3D cube. This is the very basic thing that you can do. And if we check the 3JS documentation, you will see that it's possible of doing a lot more than displaying a 3D cube. But for the 3D world, this is our hello world example. And it's not complicated at all. First of all, you can ignore the HTML and CSS part. It's only one line of HTML. So what we do is that we import the 3JS library, and we tell 3JS to use WebGL, which is the engine which is responsible of painting everything on the screen. This is very standard line of code. And we need to define three things. The first one is the camera. The second one is the scene. And the third one is our cube. In order for us to define the camera, we have a built-in function in 3JS, which is called the perspective camera. And you can think of it like an eye, or maybe even like filming a movie studio, where you have the camera which will try to capture everything. You can find all the parameters in the documentation. It's not that important, but this will tell us how far can we see, how close is the camera. We can move the camera far away from the object and so on. We also define the scene, which is basically our background. And it's not something complicated again. We have the default scene from 3JS, and we just say, okay, I want my scene to have a light blue background. It can have any background that you want, and you can play with the properties from 3JS. And in order for us to define the cube, you need to tell it, okay, 3JS, I want to create a mesh, and I want this to have the geometry of a box, which is basically a cube with a specific width, height, and depth. So if we are gonna change these properties, this will not be a cube anymore, but let me make it a little bit more balanced. So as you can see, this is very wide and not very high, and also the rotation is happening a lot. And finally, we have something called the request animation frame, which is part of JavaScript, and it will execute a function for every frame of our application. It's like in games where you have frames per second, FFC, and we'll execute the render function, which will modify the rotate property of our object, and we'll rotate it. This is the very basic example. Very quickly, the second example was about loading a 3D object. We have this 3D object that I download from internet, so it's not something that I created. But you can create your 3D objects using special programs like Blender or Maya or 3D Max or other 3D 3D softwares. What we do is that we need to load 3JS and the orbital controls, which will let us to rotate the everything and to move far and closer to our object. And also two loaders from 3JS, which knows how to load a 3D object and the material for it. Basically, the 3D object, I think you can see it here. This is our 3D object, and it is without any texture. Is the basic object, and in order for it to looks with the colors and everything we want, we need to apply the materials for it. So the code is similar to what we had before. We define the camera, we define the orbitals, which are imported. We define the scene, which in this case has a black background. And this is how we create the floor. Basically, we use the texture loader to load the squares and to apply them to a plane. A plane is basically this surface similar to a floor. And for the 3D object, what we do is that we use the material loader and the object loader. We load the obj file, which is the 3D object, and the MTL file, which is the material file, and finally we add it to the scene. So this is how we load the 3D object. And okay, I
Hey, Alexandru.
understand
Yeah,
that
yeah.
I'm
I
running
just
out of time.
yeah, we're running a little bit out of time, so I just want to interrupt you because we have a lot of questions. It was
It's
really
perfect.
great. Thank you very much for that. To be really honest, you got me with this coloring book with a live version of the elephant. It was really amazing. I just wanted to ask you a few questions just before letting you go to the platform to ask for the rest of the question
Yeah, no problem.
from the audience. But with the recent change of Facebook that you mentioned, with the move to the metaverse, and because Facebook is still a lot involved in the React community, do you think we could have at some point a way to embed more deeply in React all the ER and VR things? Would it be probably burn in React by design?
Well, I don't really think so, because everything that will happen first of all in JavaScript, but it will probably be adapted so we can use it with React.
Okay, nice. That sounds very interesting and very awesome. So just one question more. What are the best resources that you can find to start with the ER and VR stuff when you know really nothing to it, like probably me, and you want to start with it? What are the best resources to start with?
Well, you have a lot of options. First of all, you need to think if you want to develop AR for browser or for mobile applications. Because if you want to use it for browser, you can learn 3JS and you can start from here. Their website is very good. But if you want to work with mobile, and if, for example, you like or know React, you can use React Native for mobile. And one very good library for React Native is Vero AR, which is a platform which will let you create AR for Android on for iOS.
Okay, awesome. Thank you very much. Thanks for the presentation. It was really great. If you have time to just answer the question on the platform, it will be really cool for the rest of the audience. And enjoy your day. And thanks for being here with us today.
Thank you very much, and
Thanks.
good luck with the next presentations.
Thank you very much. Bye, Alexandru.
Bye.
Hey everyone, I hope you enjoyed it. It was really awesome, and this is a bright future, really changing, really different than what we could expect from the past right now, from the web and the rest of the different platforms that we have. But it's really exciting. So I hope you had some great inputs from Alexandru to start with the 3D stuff and ER and VR things in the web and in React especially. Let's jump to the next one. The next talk will be by Eben and Nedin. To be honest, the talk was recorded, so the talk will run.
A short announcement. Yeah, right, Metis? We'll have
Yeah,
a
I
very
can
short
hear you,
announcement
Nick.
from Anna. Yeah, we'll have a short announcement from Anna, and then we'll start with the talk. Okay.
Okay, awesome.
Hi, it's time for short announcement. This time, I'll tell you more about MediaGems.com. This is an educational platform. You can learn how media works in their web apps by different use cases, different texts. There are code sandbox tutorials like how to create lazy loading videos in React, how to build e-commerce app with React, etc. Please share your feedback here via this form.
Okay, thanks Anna for this short announcement. So let's go for the talk of a minute there. It will be about for the framework and using Framer motion to do some kind of animation in React apps. So let's start with it, and we go with a QA session right after that. Thanks.
Hey everyone, how's it going? And how's the conference been so far? Really good, right? Well, it's about to get even more interesting. My name is Ebenezer Don. I'm a developer advocate at JetBrains for web and JavaScript. Today I want to talk about animating React apps with Framer motion, with animations. Yeah, I know a lot of people think that animations are supposed to be really complex to implement, only for experts, but things have gotten a lot easier lately, especially with Framer motion. I'm going to show you how to take your app from this right now to this. So we're going to be using this as an example. We have the different transitions, the animation going on with the ripple effect and all that. This application, this website, against this one, you see that they have exactly the same content, but this one looks so much better. It looks lively, dynamic, like the website is talking to me. And that's what I want to achieve with this one right here. And we're going to be doing that with Framer. I'll also show you how to use CSS animation to do something like what we have for the circle, the ripple effect. I'll tell you when to use Framer, when not to use Framer, when it's better to just use plain CSS, and you see how to implement that. Production ready animation. Yeah, this is Framer motion. So you can check out their website, framer.com/motion. And what's Framer? A production ready motion library for React. So Framer helps ease React animations by a lot, components, transitioning, normal element animations, and all that. You can check out the documentation. I'm not going to be able to explain everything in this talk. So yeah, I would love it if you could come over to the documentation and look at what we have or what Framer has for animations, the different examples, come over to transitions, look at the different examples, implementations, and all that. You can also click on the examples link, and then we can see all the different examples right there. Play with them, change stuff, and see what that looks like. But right now we have this application and we want to animate this. Okay, cool. But why animate applications in the first place? Why animate your web apps? Well, it helps a lot with user experience. So as a user, I come over to this app. Okay, I can't stay here for more than 5 seconds because that's all. You plan it. Excuse me. And I've seen everything I need to see. So I'm out of your site. But when I come over to this one that's animated and I click on home, you see that, oh wow, first of all, this is the first thing I see when I open up this person's web app. Oh, it means there's probably going to be a lot happening in Let's Get Started. So I want to see more. I click on this button and wow, nice user experience. It's easy on the eyes and all that. I can just love this web app. And what else does it do? It draws attention to something. So you can use animation to draw attention to something like this ripple effect on the circle right now. When we come to home, first of all, we see the first thing that shows up is small changes can make a big impact on our planet. So our attention is drawn to this text, and then we have the other text appear and the let's get started button. We click here and wow, your planet. First of all, that's coming from the top right. Oh, amazing. So I should see this first. And oh, I can now look at all this other stuff. So it draws attention to something. And it also helps improve engagement. So this is similar to the user experience. With this right now, I can click on stuff. Wow, nice, let's get started. So I saw this animation first of all, so maybe there's something happening in the let's get started page. I click on that, and amazing, your planet is moving. So I can try to move it and see that that's possible. So I can stay on this side for a much longer time than I would with this one that's just static, that's just there. With this one, I can stay here for a much longer time. What's the limit? What are different things I can do with this site? I can start observing these circles. It increases engagement. I can go back to the home page just to see the animation again. Come to the Let's Get Started page just to see the animation again. So that's there, and generally it looks good. So if you're still looking for a reason to animate your app, it looks good. That's enough reason. So yeah, animate your apps because they look good. In this talk, we're going to be working with this code base right now. So for this application, you can see that this is the localhost URL. There's also the live URL, which you can check out right now. So here you go. This is the link to the code base, github.com/ebenezerdon/react_animations. When you come over to the code base, you see the code for our application. Now we have two major branches that I want you to take note of. The master branch. The master branch is what we have in this live URL, so this live app with the animation. And then there's also the starter code base branch without the animation. So in case you want to give this a shot yourself, you want to try it out yourself, you can use the starter code base. You're just going to have this without the animation. You have the design, but no animation. And to do that, you can come over to the branch selection button and click on the starter code base. And you have that. You can then clone it and try it out. If you want to try it out right now, you can do that. Let's go back to the slide so you see the URL. I'm going to pause for 1 second. And yeah, so github.com/ebenezerdon/react_animations and link to the hosted app. You can check it out right now. Animate react.netlify.app. All right. We've seen that it's really good to animate an app. It has a lot of advantages. That said, be careful though, because while it can be an advantage for our website, it can come with so much advantages, it can help with user experience, it can also be a disadvantage when you do it too much, when you don't do it properly. So it can be really distracting. Let's use this slide as an example. See that other pages in our slides, they're animated. Why animate your web app? The text comes from the bottom to the top. It looks good, and then the exit animation. But when we come over to this page, this is that everything changes. So distract much is blinking, and while that is happening, drive user away is coming from the top right. Slow side down is falling, like maybe raindrops or something. So it can be really distracting when this happens. So look at that. With this, user can get confused. What's going on in this application? There's so much happening. So you can then drive your user away. So it can be really distracting. It can drive them away. Something that was supposed to be an advantage becomes a disadvantage. It can also slow down your site. Let's come back to this application where we have these animations right now. And you see that we have this ripple effect. I can decide to do more than just this ripple effect and say, instead of the ripple effect, let this button start bouncing. And then we have the green button bouncing around the page, and the yellow button is also bouncing, the blue button bouncing, and this other, I think the pink button is bouncing, and buttons are just bouncing up and down the page, just because we can do it and we decide to do it. And same thing with your plan. If we come over to this Let's Get Started page, it comes from the top right to the center. But we can do a lot more than that. We can say, not just top right to the center, but come here and then go over to the top left and the bottom left and the center, and then maybe do some zigzag move and then finally get to the center. We can do all that. But why? That's really not necessary. So in that case, in that situation, instead of it to be an advantage, it becomes a disadvantage, because as a user, I'm wondering, what's this person doing? What's happening on this side? I can't understand anything here. And it's going to drive them away. And then secondly, to achieve that, you need a lot more code than you would have used initially with this animation we're doing right now. You want to add extra effects, extra positions, extra animations. You need a lot more code. And that's makes your code base, your code base is going to take longer to build. So your own developer experience it's going to affect you badly in terms of developer experience. And then for your users, it's going to make your website slow. Going to make your website slow, so slow to load. And then when there's a lot happening at the same time, interactivity is also going to be really slow. So you have to be careful. It's going to distract you, drive user away, slow down site if you don't do it well. So try to do it properly and avoid things like this flashing text. Flashing text, this the one used for the distract much text. It can be very unfriendly to a lot of people's eyes. So try to avoid flashing text in your web apps. All right, we've said a lot of things. It's time we went into the code base to see how this actually works. Okay, this is my code base right here. I'm in WebStorm and I have the SRC directory and the components folder. So just to walk you through the code base, the app.js file contains the different routes. So we have two routes, the home route with the slash for the base URL and then slash get started for the get started route. And when we come over to components, we can see the home component and then the get started component. And that's really it. So you don't need to bother yourself about this app.js file. What you need when it comes to the animation is either of the components, so home or get started. And if we want to use Frima, the first thing we want to do is install Frima. So we come over to a terminal and then npm install Frima motion. I'm going to type that out so that it's more visible. So npm install Frima motion, and look at that. So npm or yarn install Frima motion, yarn add Frima motion, and you have Frima motion installed. Now with Frima motion installed, you can then go ahead and what do we want to do right now? You can then go ahead and import Frima motion. So let's do this on line 3. Import motion from Frima motion. That's what we want to do. So right here on line 3. Now we have the div tags, the p tag, the button tag with our regular HTML JSX. Frima motion also has its own tags, like it has div tags, has p tags, has button tags too. So let's say we want to animate this div component. We can take the div tag from motion. So instead of just the regular div tag, we have motion.div tag. Now this div tag is still going to have all the attributes that is available to the normal div tag. That's also going to be available to this div tag, but we're also going to have more. In this case, we cannot animate this div. And okay, to try that right now, let's say motion.div class name home. I want to break this down so that it's easier to understand. In class name home, we now have the animate property. So this animate prop, and for the animate prop, we can now decide this is where we want to start animating stuff. So let's say for opacity, we have an array and then 0 and 1. So what we're saying right now is take opacity from 0. Like the initial opacity should be 0. That's why this is an array. So initial opacity should be 0 and then take it to 1. So opacity, like your normal CSS styling, where you have opacity 0 means it's not visible, and then 1 very visible. There's 0 0.1, 0 0.5, 0.9 and 1. So from 0 to 1. Now, when you open the tag with motion.div, remember to always close it with motion.div. I didn't do that because WebStorm does that automatically for me. So when we save this and we go back to our web page to try it out, let's go to the local host and home. Look at that. You see that 0, 1. We can also make this more obvious if we come to the next line and we have a transition prop. And inside here, we want to say duration. This is how long we want this animation to happen. So duration for 3 seconds. Now back to our web page and we reload. Look at that. For 3 seconds, it's animating. And we have an array. So let's remove the, okay. Before I remove this, I also want to show you the delay prop. So this is delay. I want this to delay for like maybe 2 seconds. So 2 seconds before you start animating. So let's reload. Look at that. 2 seconds, then animate. So that's the delay. You see other props when you go over to the Frima motion documentation. I can take you through everything right now. So class name, animate, and 0, 1. We can say, okay, start from not visible, go to very visible. That's 1. And then go back to not visible and then go back to very visible. go back to our web page and do this. Look at that. You see that? Yeah, so that's what these are for. We're going to see that in a sec. We'll see more of that and how we were able to animate these, the one on the live URL, how we were able to achieve this. All right, so that's really it. I'm going to take you to the master branch right now where we have I need to change this back to div, where we have the code base, the live URL code base, the working animation code base. So this had a class. Okay, and same thing with that one. Remove line 3 so that we can go back to the master branch. And yeah, we're here. Now this is the master branch. This is still the home component. Now for home, first of all, we start by importing motion from Framer motion on line 2. And then our motion dot. So in this case, we don't animate the whole home component. Want to animate the individual elements like this. Want to animate the individual elements, so not the whole component itself. That's why we have div, the regular div. And then for the small changes can make a big impact on the planet, this one, we now have motion.p. So normally it will be a p tag, right? But we want to animate it, so motion.p. And then animate opacity from 0 to 1. Why? So this is position. Y is the vertical position, so we want to position it vertically, Y. And then for the horizontal position, we use X. So Y vertical, X horizontal. And so for Y now, we're saying 100 from the top, 100 from the top, and then 0. So that's what we have right here. So 100 from the top, 100 from the top, and 0. Now, that's why when we do this, we have 100 from the top, 100 from the top, and 0. We can just say go from 100 to 0 and we reload. See that it just starts from 100 to 0. It just goes from 100 to 0. But we want it to stay at 100 for a while and then go to 0. We can use this now to get really creative and say, oh, from 100 go to minus 500 and then go to 0 and then go to 500 and then go to 0. So okay, go to 0. Let's save this and try again now. So look at that. So you can use this to do a lot of things. Yeah, you can get really creative. So that's it. But right now we want 100, 100, and 0. So for transition, we have ease for ease out. This is how we want the transition to happen. There's ease out. There's also ease in. Yeah, there's ease in. There's ease in out. Then you can see this, the documentation. If we come over to transition right here, and let's search for ease out. So look at the different transitions. Linear, ease in, ease out, circle in, circle out. Yeah, I like staying with what works most of the time for me is just the regular ease. What's that? That's the ease out, yeah, because it starts from slow and then quick. So let's say it wants to transition from bottom to down, does like this and then like that. Something like that. So but you can try out all the other transitions, see what you'd love best. Duration 1, so let this all happen in 1 second. Now motion.p, class name, subtext, we have the style in the CSS file, and animates opacity from 0 to 1, Y 150 from the top, and 0. Transition is out, delay 0.6. For button, right here now we have this initial prop. This is kind of different from what we have here. Opacity from 0 to 1. Initial, now we're saying stay here first of all. This is your initial position, and then you animate to something else. So that means that we can come here and say instead of 0 and 1, just have 1. And same thing for Y. Instead of 140, 0, just have 0. So from 180 to 0. Now we're saying initial should be 0 and then animate to 1. So 0 is not visible right here. Initial should be 0, not visible, and then animate to 1. For Y, initial 180 animates to 0. And when we come back here, you see that. So that's it for initial and animate. It's good to use this initial position instead of the array most of the time if you're working with just 2 positions, or even more than that, because initial, you're ensuring that it's not going to start from the default CSS styling. So maybe you want it to go from 0 to 1 for opacity, but if you don't use initial, sometimes it can be at 1 first of all, which is the default CSS styling for that particular element. And then it happens like a flash. So immediately it's at 1, just goes back to 0, and then it does the animation. When you say initial has to be 0, you're saying you have to be 0. Don't use the default CSS styling. Be 0 and then go to 1. All right, so for transition, is out, delay 0.7, duration 0.7. So that's 0.7 seconds. And that's it. Okay, that is for the home page. This one's for the button, right? Yeah. Now let's go back to the get started page. Now this is the getting started page, and class name get started. Now I want to animate the H1 tag. So this is the H1 tag right here. Your planet. Now this and ampersand NBSP ampersand NBSP, that's just for space. That represents space. I did not want to start using extra CSS styling to position this, so I just use the space. So we have space after your plan and then space before your planet. So if it looks too wide, you can remove it and use your styling to arrange your planet. Now this is the H1 tag and class name title. Okay, initial X100. So remember I told you X is for horizontal movement, so horizontal position. X100, from 100 let's go to 0. For Y, from -100 let's go to 0. That's why you have the slanted movement from the top right to the center, because we are animating both the horizontal position and the vertical position. Now let's reload. You see that, excuse me. And animate, so initial animate X0 and Y0. Now for transition, is out, duration 1.3 seconds. Now drag through. This is why we're able to drag your planet. You can do that for any of all the other elements. So for this one, for the button, set drag to trend. You'll be able to drag it. So that's how we're able to drag it. So what I use that to interact with these, drag it themselves, is set drag to true. And drag constraints, we are ensuring that even after we drag it, it comes back to where it is. So let's remove the drag constraints right now and go back to the browser. Look at this. See that there's no constraint, so we can just drag it anywhere and it stays there. And it can even leave a page. Your planet text is gone. We really cannot get it back. Okay, so let's add the drag constraint. And with the drag constraint, we are saying, okay, I have to reload. Now you have to come back to your position. So that's it. And drag elastic one. This is how elastic we want it to be. So if we say no, don't be elastic, it's more difficult to drag it. See that? More difficult to drag it. It can't really go far. So, but drag elastic as 1, and see that it's now elastic, and we can drag it far. While hover, cursor pointer. So on hover, when I hover on this, your planet, see that change the cursor to pointer, just so that the user knows that they can click on this, they can move it around and all that. So while hover, cursor pointer, you can do this with CSS and cursor pointer, or add a drop shadow or change the color. You can do all that. Make it more obvious that this can be dragged around, that this is draggable. Okay, so that's for while hover. But with framer motion, you can easily do that with the while hover prop. So while hover, cursor pointer, and we have your planet. That's it. We did not animate home. You can try that out for yourself. Try to animate this home button. And now for the ripple effect, this is where I decided. Now you consider, is it easier to do this with the external library or with your inbuilt CSS code, your normal regular CSS code? You also make this decision when working with normal JavaScript libraries, every other kind of JavaScript library. Is it easier to do this with an external library or with the inbuilt, with the JavaScript API and my regular JavaScript code? In this case, it was easier to achieve this ripple effect with my CSS. And I also want to show you, I also want to use the opportunity to show you how you can do some of these things with your regular CSS. And so right now I have 2 circles for each of them. I have one circle, which is the normal circle, and then I have the ripple effect. So I want to do that separately. I want to have circle for circle 1, and then the ripple circle, the one that gets wide and then closes back. For that circle 1, and then C1 ripple, C2 ripple, C3 ripple. Now let's come to the app.css file. And this is how I did the animation. This is all I did for the animation. So it's named Ripple Animation. So add keyframes to create the animation, and you give it a name, right? You can give this any name. And then at 0%, scale to 1.5. At 70% to 2.5, at 100% back to 0. So like this: 1.5, 2.5, 0, 1.5, 2.5, 0. And that's why you have this. So 1.5, 2.5, then back to 0, 1.5, 2.5, back to 0. Now look at this. We have opacity at 0, right here. That's why we have this effect. It looks like a ripple. If we did not have opacity 0, if opacity stayed at 1 and stayed at 1. Now let's reload this. So look at that. Look at that. But we want it to look like a ripple. And so while it's going, fade out, and then back to opacity at 1, then fade out. So that's why we have this. You see that? All right, your planet, and then home. Is there any other thing? That's how we achieve this ripple animation. And right here on line 80, this is the .ripple class for each of them. The ripple have the .ripple class, and then app.scss. We are now saying animation name is the ripple animation, which we created here on line 86. And animation duration 1.5 seconds. So this is how long we want this animation to take place. In 1.5 seconds, do that. Just like the animation duration we use with Frame Motion. And we have animation iteration count. So how many times do you want this to happen? Do you want it to happen just once? Do you want this to happen just once and that's it? Do you want it to happen twice? Do you want it to happen 5 times? Or you want it to happen infinitely? I hope that's a word. So I want it to happen forever. Like it should keep happening. That's why we have infinite right here for animation iteration count. So infinite just keeps happening. And then we use the ripple class inside the get started page. So D for the circle, then for the ripple, circle, ripple, circle, ripple, circle, and ripple. Oh, that's it. That is for animating with Frame Motion, with CSS too. You have to know when to use an external library, when to use your regular CSS. For the component transition, it's a lot easier to do that with Frame Motion. It'll be very difficult to achieve that with your regular CSS. Still possible though. And right now I want to use the easier option for any of my decisions, and Frame Motion for these ones. You see how understandable it is too. So the names are understandable: initial, animate, transition, drag constraints, and all that. And that's it for animating with Frame Motion. Remember, back to our slides, this is the link to the code base. So you want to try this out, check out the starter code base branch, the master branch too. The link to the hosted app, so you can see the hosted app, try it out yourself, move things around. So github.com/ebenezer/react animations, link to the hosted app, animate react.netlify.app. And that's it. Okay, how do we end? Yeah, let's keep in touch. So don't just go. Check my channel out. I couldn't explain everything in detail because this is the talk. I'm kind of rushing so that I'll be able to cover more than I would have if I didn't rush. But you can see a more detailed tutorial in my YouTube channel. I have a tutorial on Frame Motion, so you can check it out. youtube.com/EbenezerDon. So go see what that's like there and maybe subscribe. Check me out on LinkedIn, so you can follow me on LinkedIn or send me a message if you want to reach out to me. You can do that on LinkedIn. Follow me on GitHub. Reach out to me on Twitter. That's my social media handles. And that's it. Okay, so I guess I'll see you next time, right? Yep, bye.
It is yours
Oh,
off. Yeah.
yeah, I was muted. So, hey, technology, So, yeah, what a great talk. Thank you for everything. I guess we have a bit there with us. I'm not sure. So, like in Nedza, okay, Nick, do we have a minute there with us? Okay. Hi, how are you?
Hey, I'm doing great.
Okay,
Can
cool.
you hear
It
me?
was really, really awesome, really cool talk. Thank you very much for that. I'm a big fan of animation, so yeah, we could mess everything with animation if we want, but yeah, it was really, really, really impressive. So thank you
Thank
very much
you.
for that.
Thank
Um,
you too.
we've got time for a few questions, so let's jump in it. I will start with one of mine. As you know, I'm working at DevRiot. We're working on design system solutions and so on. So
Yeah.
in our design system, we are exporting our design tokens, and those tokens can contain many kind of definition like variables you could use in your final application. And we try to put in the design system, in the design tokens, the references to the different animations that we want to use, the
Yeah.
time of animation, the easing function, and so on. What is the best way for you to get those resources from outside of your application, like external tokens, and how to import them in your application to use them with Framer?
Um, I don't know if I've done that personally. I know of making repetitions in my own code base, within my own code base, like using an object for the animation properties, and
Hmm.
maybe I can have an external file for, I can reuse a certain kind of animation property or a set of animation properties between different components. I have an external file, maybe as an object, and then I use that as I use that in components. So I use that in the different components as props. So I just import that. So maybe you can do that for external libraries too. We import the different properties we want, or you want to fetch the properties from outside of that place, and then you just put them inside of your Freeman motion div or button as a prop. And it's usually something like there's this prop, there's a React prop property, something like that, that you can use to put external objects as components using the spread operator.
Okay,
I don't know if I
okay,
explained
nice.
that okay.
Okay, really, really cool. And so, what about performances with Framer Motion? I mean, if we have a large number of nodes in the DOM, like, I don't know, hundreds of nodes, that we want to have a nice animation in them, like in a list or something like that, how does Framer handle the performances?
Um, that question is not clear. How Freeman
Um,
handles it?
Yeah, I mean, when you are working with a lot of nodes in your DOM, and you want to animate a lot of nodes in this DOM, how does Framer is able to keep the performances up when you want to animate your content in your web page?
Mm, I don't know exactly Freeman works under the hood.
Yeah.
So yeah, I won't be able to answer that.
Okay. Does Framer is using CSS animation in the back, or
It's
how?
probably a mixture, but more of JavaScript. Yeah.
Okay. Okay. So is it possible to have some kind of responsive animations? Something like if I want to enable an animation on the
Yeah.
desktop but not on mobile, how could I do that with Framer?
I've attempted that with Freema before, and it usually ends up with me having two different buttons for the different screen sizes. I have one that displays in large screen, and I have another one that displays in a smaller screen. And yeah, either that or I end up using CSS to define the responsiveness. But Freema Motion doesn't handle responsiveness that well. You have to use either separate buttons, or then you find a way to have an animation that works for um, both big screen and then smaller screens.
Okay, so better to have separated components to handle the different situations. Okay, and are we able to animate custom components? Because you show us that we use the motion P or so on, but if we have custom elements that we want to animate to, how could we do that with Framer? Is it available?
What kind of custom elements? Is it custom components? You'll have to
Yeah.
wrap. So you have to wrap the components inside a motion.div. So you want to animate your own custom element or custom component. Just wrap it inside one of Framer's elements, motion.div, and then just put your component inside there, and that's going to animate your component.
Okay. Okay. Nice. And maybe one or two questions more. Yeah, we've got a lot of time. That's fun. What about simple animation? Because we had, I do love this question. Simple animations can be done with pure CSS, maybe with a few of JavaScript. So why choosing Framer than just using regular CSS or JavaScript?
Yeah, so definitely if it's a simple animation, please use CSS. I also said that in the talk. But sometimes it can get really complex and then you find yourself writing too much code if you want to handle things like component transition. I like what I said, it's better to just choose the easy option for whichever decision you're making. So you have to know when to use a library and when to use the CSS. If it's not worth it for you, just use CSS animation, and that's usually faster. If CSS animation works for you, that's faster and easier. But then if you're doing like component transitions, other complex stuff like dragging the elements around and all that, it's better to then go for the external library like Motion.
Okay, that's nice. And maybe one more. Does the animation have any impacts on accessibility, or do you use them to improve the accessibility at some point?
Improve. I don't think it matters much because it's really just there in the application. So if you're talking about building with Next.js static sites or React, I don't think it matters much for accessibility. Most times, what we do with animation is usually something like fades in. It's not visible at first and then becomes visible. So it's usually on first entrance to the site that you get to see most of the animations. So after that, then accessibility is fine. Maybe at first, if you take it, like I explained, it's better not to do too much. Just go with the simplest option for your animation so that you're not, trying to disturb people's eyes with flashing text and all that. The responsibility still falls on you as a developer to know how you're going to handle this stuff. And then don't leave an element not visible for a long time. If you're not too fading, make it fast so that people can start seeing what's on your site. Because if it's not available, sometimes it can be there, but then it's not visible and then the keyboard can still access it. That becomes a problem. So you have to, the responsibility still falls on you as a developer to know how to handle this stuff, make it simple, make it easy on the eyes and all that.
Okay, so keep it simple.
Yeah.
Yeah, okay, cool. Just the last one. Could we start or stop the animation with a function like I enable with a click on a button and stop them after that?
CSS is a good one for that. First of all, if we want to do something like that, first of all, I start thinking of CSS animations, button click and then add a class name. But we can also do button click and then add a property to the motion.div elements or motion.button elements. So yeah, that's also possible.
Okay, that's cool. Okay, thank you very much for your time. Thank you for this amazing talk and to be with us today. I hope you will enjoy the rest of the conference and the whole day. So thank you and enjoy the rest. Bye-bye.
Thank you very much for having me.
Okay, thanks everyone. Thanks for staying with us for the rest of the conference and the rest of the day. We're gonna have a quick announcement from Anna, I guess, and then we will switch to the next talk with Maxence Lefebvre.
I don't think it will be Anna, but yeah, let's have an announcement.
And now we want to say thank you to our sponsors, NeuroLegend. NeuroLegend's API and security testing scanner enables you to implement security testing across all your development pipelines. And what's so cool about this product? It's built for developers. It produces no false positives. Easy to use and fast to integrate with your CI/CD. Test your application's APIs with SOAP, REST, GraphQL on every build. Also, no manual validation of security findings are necessary. Developers-friendly remediation guidelines. Start fixing security issues early and often. Start scanning today. Sign up for your free enhanced security testing account and enter NeuroLegion's Nintendo Switch giveaway. register here. There's a link in the chat.
And that changed a lot between the two sessions, I guess. So thank you for still being with us for this awesome React Day at Geekle. So the next talk will be with Maxence. So hey Maxence, what's up?
Hey Mats, how are you?
I'm fine. And you?
I'm fine. It's
Okay.
difficult to go right after Ebenezer. It was a really great talk. So,
It's not always that easy, but your one will be really cool. I'm pretty sure of that. So you're a senior developer at Sphere,
yes.
and we're gonna talk about localization. This is a really nice, and a really hard topic. I guess we will have a lot of things to get from you. So the stage is yours. Take it and enjoy it.
Thank you very much. I hope you're going to enjoy it too. So, hello everyone. I am Maxence Lefebvre. I will be your speaker during this talk about continuous localization. Outside weather is sunny and 6 degrees Celsius. And the end of the talk is in 30 to 40 minutes. So as you can hear, I'm French, so I'm sorry in advance for my accent. You can also follow my talk directly through the bit.ly link that I've provided. And we can start. So who am I? As you said, Matt, I am Maxence Lefebvre. I'm a senior software developer. I have been on this line of work for 8 years, and I've built a lot of applications, and mostly multilingual application. For example, I have web apps running in oil refineries all around the world. I was quite lucky because I was able to have my team for 3 or 4 years, and we built a continuous localization solution among those years, step by step. So first, what's the issue? What is the issue? Sorry. The issue is that not everyone speaks the same language. This is a quote from Sherlock Holmes, the greatest detective of all time. I can't see your face right now, but I can guess that it looks like this. Falsely surprised. And the other side of the problem is that we have common concepts, but we don't present them the same way across countries. For example, for dates, in Europe, it's mostly gonna be day, month, year. In Japan, year, month, day. And in USA, month, day, year. But it's the same for currencies, museum units, etc. So let's roleplay a little. Let's say we are a startup. As a startup, we don't have a lot of money, but we want a lot of money. So we are going to need to be able to reach maximum of users across multiple countries. Sorry. That's right. I don't want to miss the China market with 2 billion potential customers, but I also want to open countries like Romania or Turkey, etc. Adding or updating languages should be easy. It should be brief, even after several months, years of development, because I don't want to waste money opening new countries when my application is already running, is already working. And let's go back to the issue. And the issue for us as developers is that there is no standard way of managing internationalization, in React, but also in Angular, in Vue, etc. And disclaimer, this talk isn't about presenting a standard or proposing one. I am not that conceited, but it's mostly to present a step-by-step implementation of how to industrialize your internationalization workflow. So first step, let's say we are Monday morning, 9 a.m. My backlog is groomed. I take the user story internationalization. And I'm going to implement it like that. So first, very naively, define a local map of messages, then define a React context in order to hold the current local value. On this context, I'm going to define a provider which uses which holds the current local value in its state. Sorry. Now that I have a provider, I can define a consumer. So my first consumer will be a message component, and this message component is going to consume my context and look up in my locals map the translated message for this local and this ID. I can also define another consumer, which allows me to select my local. So the user can select either ENUS for English of United States or FRFR for French from France. And then I can put it all together, sorry, in my app with my local provider and my two consumers in my application. So now you have an application with a select and a toSpan, which allows me to display either Hello World or Bonjour Monde in French or in English. So it looks great. It's like 100 lines of code. It's 10 a.m. I have finished implementing it. I have written my test. I have done my code review. It's mostly deployed, and it's taken me 1 hour. But the question, is it really done? Was it really that easy? So if we are going to take a step back, for my developer experience, implementation difficulty was really easy. It was up and running very fast. It was 100 lines of code. It was really, really easy. But to add a new language, I have to do it by hand. And in a few months, in a few years, it's going to be quite painful to add new languages on the fly. Now that I want to update languages, and it's a true story, after a few months of development, I had one coworker who took 2 days per sprint in order to sync translations files by hand. So removing dead keys, updating each language file in order to make sure I haven't forgotten one in one language, etc., etc. 2 days per sprint. So it's quite painful, and it's really not a motivating job. I cannot handle complex messages. I can only put placeholders and do some replace in order to inject variables in my messages, but I cannot handle complex variables. I cannot handle plurals, I cannot handle genders, etc., etc. And also, so I can't see if you can raise your hand, but raise your hand in front of your screen if you already did this workflow. It's the end of the sprint. I'm exporting my JSON files into spreadsheets, sending these spreadsheets to my translators, waiting a few days or a few weeks for them to translate the messages, receiving back from mail, converting the spreadsheets to JSON, and importing it in my code base, commit push. It's a really painful workflow, and it's not really the greatest solution. And for translators, it's not a great experience either. Either they need to know JSON format, or they have to do the conversion from the spreadsheets ourselves, and they don't have a message syntax convention. So to handle plurals, they can do, for example, a key.singular, a key.plural, which is not a great solution. In order to handle genders, .male, .female, .other, etc., etc. It's not great. So how can we tackle this pain point, this one in particular? But first, sorry, do you know your plural rules? you really know your plural rules? Because in French, singular is for numbers that are lesser than 2, and plural is for all the rest. So it means that .5 and 1.5 are singular. But in English, singular is only for n equals 1. So .5 and 1.5 are plural. So if there is already a little discrepancy in my code, if I am going to handle the dot singular and dot plural key with a if block or a switch case block, it's not going to be good. But moreover, because I know that you are international today, there isn't only French and English, because in Czech, there are 4 plural forms. One for n equals 1, sorry. Few for n is 2, 3, or 4. Many for non-integer numbers. And the rest is plural. But that's not all, because there isn't only Czech too. There is also Arabic with 6 plural forms. 0 for n equals 0, 1 for n equals 1, 2 for n equals 2, few for n is between 3 and 10 modulo 100, many for n is between 11 and 99 modulo 100, and the rest. So the rest are numbers between 100 and 102, 100, 200 and 202, etc., etc. It wasn't easy, and I'm trying not to cry right now, but in Russian is really, really, really difficult. There is a plural rule for integers that ends with 1, but not with 11. Another for integers that ends with 2, 3, or 4, but not with 12, 13, or 14. Another one for all integers that ends with 0, 5, 6, 7, 8, 9, or 11, 12, 13, 14, and the rest. And there is one thing that I'm sure of, is that as a tech leader, I don't want to code this. I don't want to test this. I don't want to have bugs because of plural forms, because that doesn't look like a job for a developer. That looks like a job for a translator. So how can we do? Do you think you can? Do you think you know how can we do better? Because the solution is simple. We are using a library. So I'm presenting to you ICU message syntax. Sorry. It's defined in the ICU library. ICU is for International Components of Unicode. And you are going to translate your strings with this format, with variables inside curly braces or mustaches. And those mustaches define formatters. But first, a little disclaimer. ICU is only available in C, C++, and Java, but it has been implemented in a lot of languages, and thankfully JavaScript too. So I was saying we have formatters. So formatters take 3 parameters. The first one is the input data. So for example, count. The second one is an optional type because the type of the input data won't be inferred. So if I have a number, I have to tell my engine that it is a number. And finally, the third argument is format. It tells the engine how to render the input. So for example, with count, number, and %. So as I said, the input type is not inferred. So if I'm only writing count in curly braces, it's only going to output me 2 string of my number. If I'm using count number, sorry, it's going to use a local defined formatter. So for example, in French, the thousand separator is a space and the decimal separator is a comma, whereas in English, the thousand separator is a comma, but the thousand separator is a dot. So thankfully, I don't have to handle those differences in my code. And the same with percent. And I'm lucky because you have number, but you also have date. We also have time. And we also have select. So select is going to be a real lifesaver. It works like a switch block. So for example, on the English example, I want to write that the owner is walking its dog. So I can translate the string with the gender of the owner. So for example, if the owner is male, I can write he's walking his dog. If the owner is female, she's walking her dog. And for other genders, they are walking their dog. Okay. In French, the possessive pronoun does not depend of the gender of the owner, but of the gender of the subject. So I can only translate my sentence subject. Okay, it's secret drill in my university. I'm sorry. For plural, it's going to be a structure like select. So I can say I have this many dog with I have count number and count plural one dog or over dogs. So I can handle my plural forms quite easily in my formatter in the format argument. And this is the way I can handle the many plural forms of other languages like Czech. So plural formats have multiple keywords, 0, 1, 2, few, many, over, which I presented earlier, but also equals number. But beware because equals 0 is not the same as 0, and equals 1 is not the same as 1. The keyword is local specific. For example, 1 in French is n lesser than 2, and in English, n equals 1. And it's not the same as equals 1, which is going to be cross-local. You have the same structure with select ordinal for first, second, third, fourth, or premier, deuxième in French. The same keywords as in plural, but they do not have the same meaning. So I've given you the link to the CLDR of Unicode with all the rules in all locals that I see you is using behind the curtain. Sorry. So now that I know that I have ICU, how can I use it in JavaScript? You are quite lucky because you have the Intel built-in. So I can format numbers, I can format dates, I can find out which plural forms is the right one for my number. The same in all locals. And I can also use type ordinal in order to have my ordinal form for my number. And let's do a flashback to our first solution and add ICU support. It's going to be really, really simple. All I need to do is to install and import React-Intel. We've used React-i18 Next, but we had a lot of issues with plural forms with it. So we went back to React-Intel, which is really, really great to handle this kind of pain points. That's why. So I'm adding Intel provider. I'm using a formatted message instead of my message consumer I defined previously. And voila, I have a React-Intel support and ICU support in my solution. So now I can handle plural messages. I can pass the value as a prop of my formatted message. I can handle numbers. I can format dates, but I can also do rich text formatting because now you have a web application, but maybe I want to use the same translated messages in my mobile app. So I'm defining tags in my translated message. And with React-Intel, I can specify how to handle those tags as a render function. So for example, I mapped the B tag in my translated string into an HTML B tag. I mapped the A tag in my translated message to a link, and I can also add attributes, etc. And in this HTML tag. So translating the string is still the responsibility of my translator, but handling href, target, and rel is still my developer responsibility and not the translator's. So let's take a step back. The implementation difficulty is still the same. As you can see, I only have to install a package and use a provider and the formatted message component, and I'm ready to go. But now I can handle variables in messages thanks to ICU message syntax. But it's a trade-off because now my translators need to know this message syntax. By experience, my translators all have worked with Java and C++ application, so they already knew ICU message syntax, and they weren't lost when I started to send them my JSON files. But I'm still sending JSON files. How can I do better? Because that's not local or translation file format. Sorry. Get text. Get text. What's get text? It's first a convention for naming directories files, but it is also a set of tools to extract messages from C code and to manage translation files. Those translation files have different file formats, PO and POT, POT being a PO template. And from this PO template, I can create new translation files, PO files, and I can update existing PO files from my PO template. The workflow behind getText is to first declare your messages in your source files, then extract those messages in POT file, and from this POT file, update or create your already existing PO translation files. Now that I have translated them, I can import them back in my application and display them. Sorry. So PO file looks like that. So first you have some headers. We have one which tells that this translation file is translated in French. It also reminds us of the plural forms of this language. Then I have my messages and their translations. Each messages have comments. So a first one for the developer comment, another one with the source location of this message, and then the original string that I want to translate, here free at, and the translation here libéré gratos. So for French people, it's a South Park joke. You have also a message context, because in English, free can mean free someone from prison, for example, from jail, but it can also mean that it is a free product which has no cost. You can also say that the translator can also say that this translation isn't really great, that he has some doubts. So it's called a fuzzy message. For example, here he's translating I'm hungry in bonjour, which is hello. So another translator can find quickly those fuzzy messages and do a review of the first one. And you can also have obsolete messages. Sorry. You have 5 minutes left. So I was saying that getText gives us a set of tools. So you have a command named message init, which allows us to create a translation file from a POT. All translations will be empty at first, but you can also update an already existing PO file from a POT file. So it's going to remove dead keys and adding new keys. The pros and cons of getText is that it's going to be really easy to synchronize translation files. And since it's quite old, there are a lot of external tools that are compatible with the PO format. For example, PO Edit, with integrations with DeepL, Google Translate, etc. But the cons, the first one is that native plural support does not handle decimals. But it's not our issue because we are not going to use getText plural support, but Intel plural support. The message extraction only works for C source files, so we're going to have to implement something. And in our case, there are no node implementation of getText, so you have to install the getText binaries, and you are going to need to divert the use of some features, so we are not going to be as powerful as expected. So now that I know that getText is a solution, how can I implement it? So let's go back to the workflow. I'm going to declare my messages in my sources, then extract them in a .json file, convert it in a POT file, use message init and message merge in order to synchronize my PO files, send those PO files to my translators, still by mail, sorry. And once they are back, I can convert them back to JSON to display them in my application. So the first step is going to declare my messages. Thankfully, there is a Babel macro inside the React-Intel, which does nothing in production code, but tells Babel to add some metadata to the IST while transpiling. So I'm going to define my messages like that. They need to have a unique ID because we are going to divert message context in order to hold them. And default message in the app default local in order to make sure the PO file, we have something to translate for my translators. Now I can extract the messages. I'm going to use the library extract-react-intel-messages. I'm going to run extract Intel on my source files in order to make sure I'm not running this on all my code base. I'm going to optimize by suffixing my declaration by messages.js or messages.jsx. Then I'm going to transform the output and write my messages.json file, which is going to look like this. Now that I have my messages.json, I can transform it to a POT file using react-intel-po. And the last line is in order to use message context to hold the ID in order to do the transformation in the other way. My message.pot looks like this, and as you can see, my IDs are found in the message context part of my messages. I can create or update my fr.po file, which is going to look like this. And once it's translated, I'm going to import the PO file in my code base and add this webpack loader named react-intel-po-loader, which allows us to load those PO files as JSON in my code base. So now that I have tooled my code base in order to handle PO files, I only need to import them in my code base, and voila, I I now have a set of tools in order to synchronize my PO files, my language, and my local files. So the downside is that I still need to sync my PO files manually. I had to divert the use of message context. I needed to write some custom scripts, and as you could have seen, the string locations are wrong. It's not a big deal. I can take another step further by synchronizing my PO files at each commit. So you use Yoski and the git hook pre-commit in order to make sure that each time you commit your code, you're going to extract messages and update your PO file in the code base. Okay, I only have 5 minutes left. As a developer experience, the implementation difficulty is a little harder, but not a big deal. You only needed to install some libraries and bootstrap some scripts. But now to add or update languages, I have 2 commands for all languages, and my files are always synced. I am not wasted 2 days per sprint in order to make sure my languages files are up to date. But I still have to send the PO files to my translator and wait for the response in order to have my translations back in my code base. For the translator, this is a step further too, because now that he has PO files, he can use PO edit or other softwares in order to translate my code base. But we can go a little further, because my talk was about continuous localization, and I've forgotten to talk about it. I'm going to use Weblate. There are other softwares like Crowdin or Phrase.com. But Weblate is an open source web application that you can deploy on Kubernetes, OpenShift, etc. As a startup in my roleplay, I don't want to pay another pricing, so I'm going to use open source. And Weblate is able to open pull requests on GitHub and GitLab and to synchronize with my repository. I have a dashboard which is going to please my project manager. I can see the status of each language in order to see what is translated, what isn't translated yet, what is fuzzy, what needs a review from another translator. The pros are it's free on premise, and it's really easy to deploy it on Kubernetes. It has integration with GitHub, GitLab, and Bitbucket. You have your advancement dashboard for your product manager and your project manager. And it's open source, and the maintainer is really, really responsive. When we wanted to deploy it on OpenShift, both OpenShift maintainer and Weblate maintainer went way out of their way in order to help us deploy it. So it was kind of great. The cons is that pull requests are not available on all VCS. The web UI is open source, and there are no SSO available for your own employees. I'm not going to take much longer. So I've won another pain point. Now my translations aren't a sync with my translators. Each time I commit push and merge my pull requests, it's going to synchronize with Weblate. The translators can now directly translate the messages from a web UI. And once it's translated, it's going to open pull request back to my code base. And so now my translations are following the versioning of my code base. And I think it's really, really great. For the translators experience, now they have a web application. They don't need to install software. They only need to have their account on your Weblate or Crowdin or Phrase application, and they can start translating right away. Okay, so before finishing, For now, in my application, in my steps, I was downloading all locals for all languages, but you can use the import function in order to dynamically import them and load the longs on the fly when your application bootstraps, for example. And also, don't forget to set the attribute long on your HTML element. It's really, really necessary for visually impaired user and their screen readers. So don't forget this, please. So little comparison. The first solution had a very simple implementation, but I had a lot of pain points that were hidden from first sight and that we discovered after a few months or after a few years. And finishing with continuous localization, I've tackled all those pain points for my DX. And for my TX, they don't need to use JSON files, but now they have a web application. And they have a common message syntax, which is used in other languages, which can help us under plural forms, genders, etc. So as a conclusion, I hope my accent wasn't too much in the way. I hope also that you learned a lot, and see you next time.
Wow. Thank you very much for this talk. It was really impressive. It was really, really, really cool. Thank you so much for sharing with us all this content. I have a few questions, but probably the best one is, I see we're not ready to get rid of get text right now.
No.
It's here for a while, and it will stay for a while. But why preferring using the ENTL standard API rather than existing internalization solution that already exists in React for a while?
So we are using React-Intel, which uses a Format.js under the hood, which uses also Intel API under the hood. It's more of so the Intel API helps you do ICU in pure JavaScript in Node.js, but be careful because in Node 12 it was bundled with only a few locals. So you have to start with Node 14 in order to have the full ICU bundled in Node.js. And Intel is available for Node, React, Angular, etc. It's available everywhere, so you can have cross-platform easier.
Okay, cool. And something that I often face is when I work with localization in some application is I sometimes have component mixed with my string, like having a link in my message string in my content. So how are we ready to handle that in this kind of situation? We often split string, but it's not that easy for translators to have the context. So what is the best solution for you?
So the React-Intel solution really works for me because as you can see, you are going to put placeholders in your translated strings. So for example, the translators is going to tell me that we need to inject a link in line 46. And then in my code, with chunks, I can replace this placeholder, this A tag, with a real HTML tag. I can control it because in mobile, it's going to be another component that is going to render this A tag. And also, I can make sure I don't have XSS attacks available from my translators by rendering HTML directly. An evil translator could attack me quite easily.
Yeah, right. Indeed. Okay, really nice. So thank you very much for this talk. Thank you very much for your time. It was really awesome. And it was a pleasure to have you with us today. So enjoy the rest of the conference. It was really, really nice. Thank you very much. Bye-bye.
Okay, thank you very much, everyone. See you. Goodbye.
Okay, thanks everyone. So I hope you're now more involved and more interested in how we could embed locales and how to embed localization in our final apps with React or without React. So let's have a quick break and see you later in 10 minutes, I guess, Nick, something like that.
Yeah, it's a 10-minute break. I just wanted to add, so there are some audience watching us on LinkedIn, but because LinkedIn have this silly limit of 4-hour live stream, I'm gonna end it right now, and I'm invite everyone who are watching us on LinkedIn, just join us on YouTube. I just sent the link in the chat, so go look for it and go and join us on YouTube because we will have 12-hour long live stream today. Okay, so yeah, I'm gonna roll out a quick video and then we'll have a break. Yeah, so enjoy, take yourself a cup of coffee or something. Yeah, see you soon.
Good idea.
Hi everyone. Are you a developer that works with images or videos in your web app? Did you know there's a global community on Discord to network with other developers that shares knowledge and best practices when it comes to working with media? Come join us and chat. In our Discord, you can find interesting stuff such as developer events others are participating in, resources and tips, career advice, best practices, tools and plugins, paid opportunities, content sharing, or even hanging out and sharing your pet photos and talking about video games while getting to know other developers. We will be raffling out weekly prizes for being an active community member. Join the server by going to this URL. See you there.
Уяви, як
Hi again, it's time for short announcement. Let me introduce our sponsor Intellias, one of the biggest Ukrainian IT companies with more than 2,000 professionals on board. The company values a humane attitude towards all of its specialists, which helped Intellias become the best IT employer according to Forbes and Dow in 2020. When combined together profound expertise, talented engineers, and dedication, Intellias creates unique software solutions that change the world.
Okay, hi everyone. Welcome back to this new edition of React Global Summit by Geekle. I'm still here. I will still emceeing this session on this matinee. So it's really cool to have you all. We're still we're still on for this new session, and we've got a fantastic new setup of great speakers talking about advanced use of images and so on with React. So let's start right now with a new speaker. Ragul is coming from Condé Nast, and he will talk to us about how to use data visualization in React by itself. So let's see his talk. It's a recorded one, and let's meet him just after for the live QA session. Thanks.
Hello everyone. So my name is Ragul, and in this talk we will decode how we brought the initial load time of one of our data visualization components from 28 seconds to around 1 second. Impressive, right? But first, a little bit about myself. So I am a software engineer at Condé Nast, and I've been working at Condé Nast for nearly 2 years now. Condé Nast, for those of you who might not know, is a publishing company with a global presence that houses many cool brands like Vogue, New Yorker, GQ, Wired, and so on. Our team, which is the data visualization team, gets to work with all these brands and develop super cool and engaging data visualization and web experiences for them. And to build these uber cool visualizations, we make use of React and D3. D3, for those of you who might not know, is a library that helps us build data visualization with a fine grained control. So, moving back to the topic, our case study. So our team has worked on brought many cool visualizations to life. One of them being our internal year-end storytelling visualization. So one of the components that actually went into that was the deep look section that you're currently looking at. So it's a custom cluster chart which has a large number of data points to be displayed. We will be going through the major versions of this component, the how we built the version, the metrics, what were the performance issues that came up in each version, and how we address them in the next version. Some key things to note before we go into the case study. So if you have no knowledge about D3, it's completely fine. You don't need any knowledge of D3 to follow along this talk. And one more thing to note was to pinpoint the issue in the each version, we debug the app in each version using React DevTools and Chrome DevTools. To make sure it's easier to follow along in this talk, only the performance metrics from the Lighthouse tests have been included in the slide so that it's easier to follow along for the rest of you. So about the case study. So our goal was to build a cluster chart that animates between three views, as you saw in the previous slide, category 1, 2, and 3. So the viz would contain circles, which would either group itself in clusters or position itself as a line chart, depending on the view it is in. When switching between these three views, the circle should animate gracefully between the positions. We would be rendering the visualization using SVG with the help of D3 to figure out the position and size of the circles. So let's start off with the version 1. So the version 1 of our component was the very first iteration of what a component would look like with the data. Main goal here was to find out how the viz would look like with the data we had. In the example that I'm showing you, like for the case study, I've only enabled the set deep loop component alone, and as you can see in the demo, now you can see that we've started loading the website, but it's still loading. As you can see the video controls down here, and we are like 10 seconds in and the viz is still not rendered, but just the category 1, 2, 3 have been rendered, and it's still going. And yeah, so as you can see, the website, the component actually takes a really long time to load. So under the hood, this is what it looks like. So we have a viz component that has like 3 categories as an individual component, which gets conditionally rendered using the chart type that we set using these buttons. And under each category that we have here, like each viz that we show, this is what it looks like. So you can see here it's a functional component, and then a lot of data processing is being done on the body of the functional component, and nothing to go inside, but then the nodes is the data that we are looking for. So it has all the circle properties and the values that we need to render it. So we'll be using that to render it using React. So moving on to the metrics. So we'll be talking about 2 metrics for each version. So the first one is the first contentful paint, which is also known as FCP, which is a measure of when the browser starts to render the website on the browser. Second is time to interactive, which is a measure of how much time it takes for the website to become fully interactive. That is, the user can start interacting with the website. For a version 1, if you see, FCP was around 7.5 seconds and the TTI was around 15.2 seconds, which is definitely not good for any website. So why did this happen? To start off, the bottlenecks and issues. So since this was just to explore the data, the 3 views, that is the category 1, 2, and 3, were structured into separate components. So when switching between the components and views, we actually switched the components, but we needed to animate the circles between the views. So we needed to bring them together in the next version. That was the first issue that we noticed. Second one was, it was a really huge data set and it was unfiltered. So we had about like 25,000 data points, which means we also had like 25,000 nodes to be rendered on the DOM. Rendering such huge number of nodes would not be good for browser on any medium or low end devices, and even in some high end devices it might cause some issues, because the goal was to animate the circles between the views, and animating them is much harder with those many nodes. Third one we noticed was, so a little look into the React dev tools told us like each of the 3 components were re-rendering and recalculating the data a lot of times unnecessarily. What is the culprit? So the code that calculated the position for the circles was doing its calculations on the body of the functional component that we saw, the component 1, 2, and 3. So the fact that the computations were actually a bit time consuming was not also helping. So that was where the major issue was. Fourth point that we noticed was like switching between the views also takes a long time, because when we switch to a new view, that is like, let's say category 2 also does similar categorizations that category 1 did. So hence the delay. So now we knew what we had to do. We go into the version 2. The main goal of this version was to build an interactable visualization that overcomes the issues and bottlenecks of the previous version. So what we did in this version was, first we addressed the animation issue that might come up. So we merged all 3 views into a single component called deep look. So and then the second thing that we did was we split the data, that is 25,000 nodes data points, based on months, and put that up as a filter. This greatly reduced the number of circles from like 25,000 to approximately 2,000 per month. Third thing we did was we wrapped all the computation inside functions and called them only inside use effects, so that recalculations will decrease. We also stored the data in states using useState, used a lazy state initialization for better initial load. And then the fourth thing we did was we calculated all 3 views, the data for all 3 views were calculated inside the deep look component itself. So the switching was instant. We also got started on animation by animating the properties of X, Y, and opacity of the circle element using CSS transitions. And this gave us this. So you can see the loading has started, and now we have a single component with like 3 views and 1 month filter. So keep track of the video's timestamp to understand how long it takes to load the page. I'll be keeping moving the mouse so that the controls are visible till the web page finishes loading. We wait patiently for it to finish loading, and here we are. So now if I click on any one of the 3 views, it's still loading. Hold on. So now when I click on any of the 3 views, it instantly animates with the transition. Now I try to load, let's say I try to load February's data, and we have to wait for a while. And we have the February data loaded now. And now the transitions are working as expected. So what did this give us? So this gave us this. Just a second. So numbers wise, it looks like this. So the FCP is around 11.3 seconds and the DTI is around 18.2 seconds. What? How did it get worse? Actually, what happened was it was actually expected. In the earlier version, we computed the position and did the processing for one view alone in one component. But here we were doing the calculations for all 3 views in a single component, and hence the increase in FCP and TTI. Because of this delay caused by the computation, it would take around like 5 to 10 seconds every time we switch between the months, which was not a good user experience. Because for a given month, it would calculate the positions for all 3 views in one go. When the month changes, it actually recalculates the position for all 3 views for that particular month and then renders it. Another thing that we noticed was the third point. So we were actually using a really simple transition all to animate the circles. Somehow the animation would be slow in some low-end devices and mobile devices, and in some the animation was really choppy. Animating 2000 nodes on a resource demanding website might be part of the problem, but then it needed more inspection. So knowing what to optimize, we went on to the next version, version 3. So the goal of version 3 was to come out with a good end product that closely resembles an MVP sort of. So what we did in this version was, firstly, we looked into the data and took a decision to remove months filter and just showed top 1000 data points for the whole visualization. This decision was made because of 2 major points. One, this was not a dashboard, so it just made more sense from a data visualization aspect to let the users explore top end data points alone with peace. Second point, this also helped us boost the performance of the app. Animating just 1000 nodes instead of more than 2000 nodes was definitely helpful in decreasing the load on the browser. Second point, in version 2, so each time the user switched between months, we used to calculate the positions for the circles and used it to render the circles. Even if the user switched from, let's say, January to February and then back to January, we would still be calculating the position for 3 views again. Like, we see that the January has happened twice, but then we should be calculating it only once, right? So in this version, the data for all 3 views are computed once and memoized using use memo. So when the user actually switches from category 1 to category 2 and then back to category 1, there will be no computation performed. So you can see here all the first 3 categories are memoized, and then we just use a single data and just change it when the chart type changes. Third point, before we dive into why the animation was slow and janky in the last version, let us have a quick overview of how browsers actually renders any website. So the browser rendering pipeline. So to display a website, the browser does the following steps: style, layout, paint, and then compose it. These are the 4 steps it follows. So if you look at style, the browser calculates which styles to apply to which elements. The layout step involves the browser calculating where each element goes and how much space it occupies. The paint step involves the browser filling out the pixels on the screen with colors, borders, images, etc. across many layers. And then for the composite step, the browser gets the layers from the paint step, combines them into one layer, and then draws them onto the screen. This is called the browser's rendering pipeline. So each CSS property goes through these steps to get displayed as what we see on the browser as a website. But then not all properties go through all steps. So let us take an example. Let's consider width, CSS property, that is width. So width changes the space of an element it occupies. So it affects the layout of a website, which is step 2, which makes the browser recalculate paint and composite steps, which are step 3 and 4. So 2, 3 and 4 step gets recalculated. So if we animate width, browser has to recalculate 2, 3, 4. That is 3 steps it has to recalculate. Consider opacity, which is also a CSS property. So when we apply opacity to an element, the browser actually creates a separate layer for that element. So when we animate opacity, only the composite step gets triggered because only that layer will get affected, and hence the 4th layer alone needs to be recalculated. Which means animating opacity is actually less work for the browser than animating width. So we found out that transform is also another similar property that only affects the composite step. So we actually refactored our entire animation to work only on transitions of opacity and transform. So you can have a look here. We do the we set the transform translate using x and y coordinates, and then we set the opacity, and then those alone get transitioned using the transition property. Another thing to note was we looked into JavaScript library animations like React Spring, but then realized that we were already doing some heavy duty calculation on the main JavaScript thread and did not want it to overload with JS animation. Since CSS animations are handled on a separate thread by the browser, it was the best option. So how did this look? So here we go. We've started loading the component. So it's somewhat here, and then right off the bat, you can see that we didn't have to wait as long as we had to in version 1. And we can also see that this super smooth animation of the circles when we switch the view. So yes, numbers wise, it looks like this. FCP is 8.3 seconds and TTI is 9.3 seconds. From 20 plus seconds to under 10 seconds is really nice boost, but then it's nearly not nice enough for a good user experience. A bit more digging into the dev tools, and we got this. Very obviously, the main issue was still the time it was taking for the initial data calculations for the 3 views, like the category 1, 2, and 3. Those are still the most time consuming calculations that need to be looked into. Second part, so this was one of the many components that was going to be up in our website. So it comes up as the penultimate section, but then we most definitely can't have this section alone clogging up the main JavaScript thread for 10 seconds, because it would make the website unusable for the first 10 seconds, which is not a good user experience. So once again, we knew what we needed to do to optimize it. We just needed to find out how. Moving on to version 4. It was time to bring out the magic sauce. Before I talk about what we did, here's a look at the metrics. First content to FCP is around 0.8 seconds and TTI is around approximately 2 seconds. The user sees the content in under 1 second and the user can interact with the website in under 2 seconds. You must be wondering, oh, seriously? Well, let me just show it to you instead of telling you. So here's the demo. So you start loading the website right here, and instantly you can see the categories and the labels appearing, and then a few seconds later the circles animate, and clicking on each view changes the dots respectively, and we have a really good component at our hand. But how did we achieve this? So yeah, starting off with the most easiest part. So we removed unused code, data files, and reduced the image sizes using compression techniques. And then we also broke down our package.json, removed unwanted dependencies, and reduced the overall bundle size. So a lot of tree shaking and the standard stuff. That was one. And then second one was as you might have figured out, our major problem was that we were calculating the data for the three views in a sequential manner in the main JavaScript thread, which was blocking the rendering of our web page. To solve that, we would have to render initial dummy circles, perform recalculation somewhere else other than the main thread, get the data, and use it to render the updated positions. That's where web workers come in. So, web workers are actually a simple means for websites to run scripts in the background threads. The way it works is you create a new worker thread, perform your calculations there in that thread, get the data, and pass it on to the main thread. And then the main thread uses it to render the data. So in code, like how it looks is to spawn like 3 worker threads for our 3 views calculation, like data calculation for the 3 views. We made use of a package called workerize loader. So what it does is you create a worker instance here, and then you pass the data to that worker thread, and then let it compute, and then add an event listener to that worker thread, like get the data back from the worker thread, and then set it as a state, and then use it to render your component. So this was one. And then the second major optimization that we did was lazy loading the deep look component. So deep look component was one of the last sections on the website, as I told you. So it didn't actually make sense for it to load at first along with the rest of the website. So yeah, when the website loads, you actually just need to show the header section to the user, and maybe the first section to the user, and the remaining sections can like slowly load in the background. This would reduce the initial bundle size that the user would load, which would ultimately result in faster load times for the user. So this was made possible by splitting the code using lazy loading and suspense, which are the features of React. So how this works is, in our app, as you can see in the first image, you can see that the browser is making a request for 2 big chunk files, main.chunk.js and 0.chunk.js, which take about like 50 milliseconds each to get served on a local host on a fast internet speed. In the second image, you can actually see that after we've split up the code for the deep look is actually located in 1.chunk.js. So as you can see, the time here, main.chunk.js takes 17 ms, and then 0.chunk.js takes 29 ms. But then the deep look, it gets like called after a while, and then it takes separately 37 milliseconds, which happens in the background. So in real-time scenario, when the project is deployed on the internet, it would like make a huge impact. It also helps us display content faster in devices that are connected to slower networks. Implementation wise is pretty simple. So there are 2 parts to this setup. One is the lazy that we import from React, and the other one is the suspense component that we also import from React. So React.lazy helps us separate certain components into separate chunks during build time. It's a simple import that it gets a simple function that has to have a default import. Second component is a suspense component. So we wrap our lazily loaded components inside suspense. The suspense components helps us show some fallback content also while we wait for the lazy component to load. So one thing that can definitely happen in this setup is the browser might request for the main chunk, but before loading the one.chunk.js, that is the deep look component, there might be some network issues and it might break our app. So to prevent that, we brought in error boundary to handle such scenarios so that we have a graceful fallback for when such errors happen. So this was the version that went live and worked very nicely with other components of the website. All these optimizations are fine. But was there something that we could have done more beyond version 4? So what about Canvas API? So yeah, what if using Canvas API will drastically maybe decrease the number of DOM nodes that we have rendered on the website, but then we would also have to rely on JavaScript to make the circles animate. So there is a possibility that doing so might give us extra performance boost, but I'm not sure. So that is one part that can be and should be explored further. So what have we learned? To sum it up, so to reduce wasted re-renders and avoid unnecessary recalculations is the first step in to optimize any React app. And then if you want really high performance CSS animations, then animate only transform and opacity. One major thing that you should not do is you should not block the main JavaScript thread by super heavy computational functions or stuff like that. Use web workers if you have anything like that, and then lazily load components that aren't immediately required by the user so that the user has better user experience in loading the website. But also remember this. So do not prematurely optimize your React app. So get your website up and running, run tests on it, find out bottlenecks, and then fix them. Fixing problems even before they come up has always given rise to more problems. So never prematurely optimize. Second thing is there is one major thing to keep in mind. So use memo, React memo, or standard optimization stuff like that are not the solution to every slow React app. So there is no universal solution for performance issues in general. So each project is unique on its own. So you have to run test, analyze, find the bottlenecks, and then fix them. Have a look at like Brooks, who managed to bring his app render time from like 13.4 ms to 3.6 ms by just restructuring his code and doing nothing of the sorts of like memoizing or something like that. So just restructuring will give you such a huge performance boost. So that's definitely the debugging part and the analyzing part that helped him achieve this. So go through that, do that first, and then start optimizing. So yeah, and that's it. I hope this talk helped you get a deeper look into what goes into optimizing in React app. See you all at the question and answers.
Wow, I don't know for you, but to me, it was a really impressive talk. So let's go for a Q&A session with Ragul. Hey, Ragul, how are you?
Hello, hi, I'm fine. How are you?
I'm fine. I'm fine too. Thank you. Thank you for being here. Thank you for this wonderful talk. It was really impressive. It reminds me a project I had 6 or 7 years ago. We made a project with some kind of color rendering process in a bag, and we wanted to do that all in the browser, and we were stuck with this project. It was just a nightmare. And finally, we moved at the end to the web workers to do all the color channels computation, then coloring the bags and the different part of the bags right in the canvas and API. It was just a blast, and it was 7 years ago. So I'm happy to see that everything is improving a lot in this ecosystem right now. We have a lot of questions, so that's really nice. First one that I do love it. Do you consider to use WebAssembly for any kind of background calculation? Because we're using web workers to improve it, but is there a way to use WASM too?
Yep. So it's actually a really good question. So I knew that WebAssembly existed and that it was a really good alternative that we could go for. But then before I go into WebAssembly, so the main reason we didn't try out Canvas API that we had in plan, like as I told you, it actually decreases the number of nodes that are present in the DOM. So it would help a use case. The main reason we didn't go that is we were on a short time frame. Deadlines were approaching. Plus, Canvas API was something that none of us in our team had actually explored. So we didn't want to take the extra bullet. We didn't want to like explore into the unknown, and if we get stuck into something unknown, it would be a really big headache. So we just stuck to what we know, and we tried to optimize it as best as we could in that given. So then.
Okay, yeah, sounds good. That's fine. And we talked about the rendering process of the browser and the different step in the browser. So we've got a question about how to tell what browser step is big perform for a particular action.
So yeah, the best place to find that out would be when you like open your browser, you have the inspect elements in your Chrome or any other browser, right? So there will be a performance section in that place. So if you actually record your trace for that website, you will have a like detailed explanation. It would be super detailed. If you're actually starting it out at fresh, you'll feel a bit overwhelmed. But then maybe start with really simple HTML pages and see how the like each rendering stuff works, so that you get an idea, and then you can maybe come on into the React apps so that you'll understand where you can optimize and how you can optimize. A better, easier place to start would be the React dev tools that you get in your browser. Then you can maybe go on to the performance section, so that you can have a deeper understanding of how it works.
Okay, cool. Yeah, to stay with this topic, do you recommend to any junior dev to understand the broader rendering process to improve their interface rendering? Is it mandatory to understand it before trying to develop some kind of new interfaces?
It actually it would actually help a lot if you actually knew how the browser was rendering, because like if you know what happens behind the scenes, you know what kind of code you will write and how it will actually get rendered. So you'll have an idea of like the code that you're writing is actually efficient or not. You'll have a rough idea even before you try to analyze. So yeah, it would help, but then it's not a main requirement before you start developing any website. You can start developing and then record it and then also go into the optimization. You have to eventually learn somehow, right? If you're a junior developer, it's not a like given that you need to understand the browser rendering process before you even learn React. So yeah, it's a like learning stage, so you just need to learn it eventually.
Okay, that sounds good. I remember that, a few years ago, I saw a talk about how the rendering process works in the browser, and I was just blasted about it, saying, wow, this is awesome. And I understood, I connected a few dots with that and saying, okay, I see how I could improve the performances at all. But it's not that easy to understand at first, yeah. We've got a question about React that is only one part of the solution. So what about D3.js optimization? Can we do something on the D3.js side?
Yep, really good question. So yeah, to just spoil the answer for everyone, yes, there are actually a bit of optimizations that you can do on the D3 side, but since this was a React global summit, so it kept the details around React. But then a quick overview of how actually we use React and D3. So we use it in a declarative manner. So people who are familiar with D3, so D3 actually has a method to actually modify the DOM nodes on its own, like D3.select, and then you just keep on changing it. But then how we do is whatever data we need from the D3, we pass the data and get the attributes alone. Like if you're rendering a circle, you'll need the radius, you'll need the color and all those things. So those attributes, size and all, so those values alone, we'll get it from D3 and then use React to render the component that we need. Because React is already super optimized to like just re-render whatever is changing alone. And unlike D3, it doesn't like completely re-renders everything. So React is actually better in that aspect. So we use D3 for the computation and React alone for the rendering process. So it's called a declarative method of using D3 and React. You can Google it out. It's available to check. If you want any source code, it's also available.
Okay, yeah, sounds a good idea, of course. This question now: have you considered using separate web workers for all different categories to calculate, compute them separately, and then bring them all at the end?
Yep. So how our app that is in production was working is we had a separate web worker for each component that we needed calculation for. So we had like three web workers doing the computation. So that's why you got the data really instantly. So yes, we did calculate them separately.
Okay, okay, that sounds like a plan, of course. And um, how do you handle a big quantity of data when you have the big calculation? Because we saw about the rendering process also loads those data, which could be a massive usage of data. So is there a way you recommend to load this data, or to lazy load this data, or to access it, to improve the loading process around all this mass usage of data?
Yep. So the idea is if you have any components in your React app that requires like such huge computation of data or something like that, just try not to like put it right on the front page, on the front section of the screen that the user has to like really see at first. Because if there is a lot of computation involved, ideally it would be the second or the third component, so that you can use some of these techniques that I just mentioned here, so that you can show the user the landing page or the header first, and then you can do the processing and everything back silently in the background, and then show them when it's ready. But then if you have like huge millions of rows of data that you need processing, do not do them on the front end side. Have them ready, like pre-computed, or do them in the backend and get the data from the backend, so that it's better. We did it in the front end because our data would not be changing, plus our development flow is structured in a way that we need the data in the app itself. We are actually not advised to have any API communications in our project, so that's why we did it in that way. But then yeah, if you have huge data, then get it from an API and then use it. That would be better.
Okay, okay, cool. So yeah, what would be the best takeaway from your talk, from your point of view, and regarding all the questions that we had? What would you recommend to any junior developer or senior developers that want to deep dive in the rendering of complex data and complex interfaces with React?
The general idea is to be curious about everything. Like, if you see something interesting, ask questions, get into it, inspect the websites. If you're developing websites, you can definitely inspect what's going on. So, yeah, be curious and just keep digging. And if you find the developer on Twitter, maybe ask him politely how it works or stuff like that. He might even share it with you. So, yeah, just be curious in general. So, that would really help, whether irregardless of whether you're senior or junior developer.
Okay, awesome. Oh, that's great. Thank you very much for being here, and thank you for this awesome talk. It was really, really fun to see it and to have you with us.
Thank you.
Thank you. Enjoy the rest of the conference. See you later. Bye bye.
Bye bye.
Wow, it was really, really impressive. Loading content in your application, your final application, isn't an easy task. And of course, as Ragul said, we need to just keep the thing simple and improve it step by step, and not try to over optimize the content at all. But yeah, it was really, really awesome. The next talk we have is with another great speaker, with Matthias. So I guess he is with us. Hey, Matthias, how are you?
Hi, Mads. I'm doing great, man. Really happy to be here today.
Yeah, it's cool to have you with us. It's really, really
Nice.
cool.
Hey folks, I'm just gonna roll out a very, very quick announcement because we have a cool giveaway coming right up, and then we start without further ado. Okay?
Okay.
Okay.
Yeah, sure.
Hey everyone, and attention please. Right now we're going to have special giveaway for our annual subscriptions to our platform, with access to all 2022 summits from Geekle. You have a chance to win one of 5 subscriptions, one of 5 annual subscriptions. And to partake in this giveaway, what you need to do, you need to take a selfie of yourself watching React Global right now. Also, then you need to post it in your social media account, Twitter, Facebook, Instagram, you name it, any kind of social media. And you need to tag us with tag @geekle.us. Also, below that photo, make a short description why you love Geekle events, what's so special about this event, for example, and we will take those comments and we'll reward 5 of the most creative ones. So good luck. You have 30 minutes for that, and also there will be a running line over here with description below. So please read it if you missed something, and good luck.
Cool, and we're back. So happy to see you here. Happy to have you for this new conference. I know that you're doing a lot of work with new topic, new trendy things with media, AR.
Yes, all the buzzwords.
Yeah. So I guess it's cool to work on it on every day, but not that always that easy to embed it in the final application in production. So I guess you've got a lot of things to talk to us about React and MediaPipe to add more power and more awesome tools in our final application. So I give you the stage. You're on it. Thanks.
Go. Okay, I will share my screen right away.
Yeah.
Wait a bit. Okay, let's see if you can see it.
Okay, perfect. So
Nice,
the stage
great.
is yours.
Thank you, Mads. Okay, so well then, hello everybody. I'm really glad that you are all here attending the event and seeing my presentation today. So I'll be talking about React and MediaPipe, so powering web applications with AI and computer vision. MediaPipe is a really nice framework. It's very recent, and we can use essentially machine learning models to video and live streaming. So it's a very nice framework, and it could be nice to use in web application as well. So I will try to explain how we can do it in this talk. So anyway, I'm Matheus Bueno. I'm from Brazil, and I am a researcher and a software engineer at Senior Sistemas. It's a very big company here in Brazil. I have plus 8 years of experience in software development. I am currently working with cloud computing and also machine learning. We do stuff with blockchain as well. And I like to mess up with web stuff. So I like to apply all these trending topics to web. And these are my social networks, my LinkedIn, my Twitter, and my GitHub. I tend to share sometimes some nice stuff that I'm doing. And you are all free to hit me up on these social networks as well, if you would. So Senior Sistemas is like a very huge company here in Brazil. It's a very well-known company. We have software solutions for a lot of segments and a lot of industry and markets and commerces and companies. I work in the R&D department, so I am a researcher in this company, and we do research to like bring innovation and try to bring this current trends and this all buzzwords topics that we have currently to our existing products. It's a very nice place to work. Particularly our R&D department is very nice and cool. I work with the best people in the world. And but yeah, and the company is slowly expanding to outside Brazil. So we are starting to expand to other countries in Latin America. But maybe you may hear more about us in the near future. Who knows? So anyway, moving on. For our talk today, I will be presenting to you the base foundations of AI and computer vision. And after that, we will see how we can use machine learning with React. And then I will talk about the MediaPipe framework. After that, I will talk how we can use it with React. So it's our main topic for today. And I will finish with some use case and some app ideas for you. So, okay, AI and computer vision. It's two words that are trending. AI, of course, you are hearing a lot about AI in these past years. It's like a topic which we can't run out of it. It's essentially everywhere now. So AI stands for artificial intelligence, and it's basically about giving I to the A. So it's like giving the what we understand about human intelligence to something artificial, which is the machine. And there is a lot of buzzwords related to this area. So the main one is machine learning, which is one that we are hearing more these years. And I will restrict this talk to just machine learning because it's more related to the topic, and it's the most studied topic in this area of artificial intelligence. So let's go. In simple terms, machine learning is you have like a machine, right? It's a PC, and you're trying to develop a model that will run a lot of predictions in some kind of data, right? So you have like this bunch of data that you will like present this to your machine, and you want the machine to learn from this data. So this is called training. This is a process that's essentially to the machine learning because it's in the name, you know. And the machine will try to make some sense of this bunch of data. So it will try to extract some kind of function out of it, and will be what our model you do, right? So when you do the training, after that, you present like new data to the machine, and the machine will try to guess what is this about. So this process is called inference, and we are hoping that our model can perform well. So we are hoping that it can make the predictions very accurate. But this is not a deterministic process. Actually, it's not like classical algorithms. So it's kind of a try and guess and try to correctly predict stuff. And sometimes our machine can like mess up. So if I present a new data, it can mess up the classification here. But that's not a big deal because we have a process called testing that we do this in the training process as well. So we are essentially trying to see how accurate our model is, and we just do refinements to try to get to like the performance that we want. So anyway, that's how the process works. And computer vision is another topic that it's like covered by artificial intelligence as well. It's kind of related to this. It's a more classical approach, and it's less costly than machine learning because machine learning is very resource heavy, and it's a very lengthy process as well to build the models. And essentially, if you want to have a really accurate model, you have to dispose a really big, large time to it. But computer vision is more fast. And with computer vision, we are trying to give the computer the ability to see, like we see as well with our eyes. So the computer understands image as a matrix of pixels values. And with that, we can like apply a bunch of math and linear algebra and some functions to do some nice stuff with images and videos. So this is a process that is more likely to the computer. But anyway, in the real world, most practical tasks, they bring a lot of burden to this classical way of doing computer vision because real images and videos are like really overloaded with information. So it has a lot of variation in light and colors. There is too much elements sometimes to process. So it's nice to try to combine the power of computer vision with machine learning to these tasks of doing stuff with images and videos. But you need to balance this the side of machine learning that is very complex and resource heavy, but on the other hand, it's like very accurate with with the light stuff that computer vision do, but in other hand, it's not so accurate. So you will have to balance the two, and maybe you can get like a real nice application for image and video. So, well, machine learning is mostly developed with Python today because it's kind of a standard to develop machine learning with. There are famous libraries such as TensorFlow that are made. They are actually made. The core part is made with C or C++. But they are extended to Python language and also R language, and that is Julia language today as well. But the most used is Python. And it is because it have a very fast learning curve, and that it's very easy to implement stuff and prototype stuff in it. But it's nice to like bring this to production and to applications that we can like present to users and maybe sell as well. So we have some options if you want to give AI power to React apps, which is the topic for the whole talk today. So the majority of applications, web applications that depends on ML models, they do like this. So for instance, we can have a front end made with React, and then we have a backend that will be written in Python, or you can even write in Node.js as well. There is some libraries that you can use in Node.js for doing machine learning. So essentially, we can send predictive requests to the backend. So we are sending some data to do the inference, and the backend loads the model. So this whole process will actually happen in the backend. It's not on the client side. So the backend will run the inference on the data given, and it will return the prediction results to frontend, like in the response maybe, and then the frontend will like be presenting the result to the user. So this is the most part of the applications that are in the internet that use machine learning do like this, you know. And for the most reasons, you will be fine with that because this cover a lot of tests that you should be doing with machine learning in web. But anyway, with React, you can use a library called TensorFlow.js, which is the same library that you can use with Node.js. So this library can do the training part to build the models. And it can also do just the part that loads the model and run the inference. It's up to you. And if you use TensorFlow.js with React.js, you actually would be processing all the stuff on the client side. So it's not in the backend side anymore. So essentially, you will be using the user's computer power. So it's the resource of the user that is running your web application that will be responsible to like use the model. So if you have like a really huge model, you have to keep that in mind that it can burden like the user experience. So, but anyway, there's a few reasons to do that in the client side. So maybe you want to present like the training process live to the user so he can see how it's going. You can do that with the backend processing part, but you maybe you have to use like something like WebSockets or something like that. And you can have some latency because of the communication part with the front end and the back end. But you can do all this training process in the front end as well, and maybe you want to the users to see it live, right? So another reason to do that is if you want to load pre-trained models directly on the application, and you can do that with TensorFlow.js. But remember that what I said before, that this will like burden the user experience because it depends on the user's computer. So the other reason, if you want to reduce the latency by the inferences, so you want to avoid the client to server communication for predictions, so you can make inference with little latency by doing just in the front end part, in the client side. And that's the part where MediaPipe comes in hand, because this last reason, it's more common to have when you have something related to live video. So if you are doing machine learning for live video, you want to reduce the lag, because you are present live in the image, so you can't have so much latency. So the user experience would be like very messed up with it. So MediaPipe is like a framework that resolves that for us. So that's where came the really cool part of it. So anyway, so Google's MediaPipe is this framework that is developed at Google. Just a moment, please. They started the development of it like, I think, 2 to 3 years ago, the first papers. And it's a very recent framework. But even though it's recent, it's actually very nice to use. It's not so hard to use, and it has a lot of already made and read things to use. So yes, it's very cool. It can run like objects and elements detection, tracking, classification, and it's really fast and very powerful built. So it's a framework for machine learning for live and streaming media, right? So there is a bunch of frameworks that this multi-framework encompass. So the most famous one are the MediaPipe hands for doing detection and tracking of hands and hands features as well. So it can track like the pinpoints of articulations. And we have also the MediaPipe pose for the whole body tracking and detection of like the body structure. And we have also the face mesh, which not only do the detection of the face, but it also detects and track like face features like the eyes, the nose, the lips. So it's really nice to use them, and they are really fast. So it's very fast to have the detections running, because they build a lot of pipeline of models, and they were very robust, because they use it like a really large data set, because Google has access to a lot of large data sets. So these models are actually very accurate and they have a really good performance. So they are really fast to use and not so heavy as well. So we can use in the client side, and it will not be so resource heavy to use. The supported platforms for using MediaPipe is basically Python. It's where the most of the examples are. You can use as well in Android and iOS with Java and Objective-C respectively. It's also possible to use with Swift and Kotlin, but you have to make some effort to make it running, because there is not so much examples with it. And last but not least, you can use it with JavaScript. The examples in the MediaPipe.dev, which is the website for the documentation of MediaPipe, they run it with vanilla JavaScript. So there is no example with modern frameworks such as React or Vue or Angular, but it's possible to do this with these frameworks as well. So yes, it covers like a really broad range of platforms. So in MediaPipe.dev, which is the official documentation site, there is the web page for JavaScript, where you can see the devices that are supported. So not all web browsers are currently supported, but the most famous ones like Chrome and Firefox, you should be okay with that. There is some issues to run in the Safari and the Chrome browsers for iOS, but as they are developing the framework, maybe this can be corrected in the future. Who knows? But in the web page for the JavaScript, there is also a relation of npm package that you can install to use. So that's where we can use it with modern frameworks way of doing stuff. So in the vanilla JavaScript, you actually will be like importing the libraries in the script tag. So you will be having to put the URL in the source parameter of the script tag. You can also do this in React as well, but it's nice to do in a more modern way. So using MediaPipe framework with React, you have to do these steps. Okay, so first you need to install the required npm package, so the framework that you want to use, and also you can install extra stuff for assist you in the task. After installing, you have to import them in your app on your component. It's very straightforward to import them, but you need to first know what will be the components that you'll be using. And next, you have to get a reference to the webcam and also to the canvas. So you will be essentially capturing images from the webcam, for example, for live streaming. But you will have to like draw stuff to present the user the tracking things happening. So it's nice to have a canvas to draw all the stuff that you need. And so you will need like a reference to that. After that, you have to set up the framework on the initialization in the app or the component. So I will be explaining how you do that. Then you have to set up a callback function that is core to the framework. And this function will run for each image that you are capturing. So you are capturing frames for the webcam, for example, and we will be running this function for each of these frames. And this is for the detection and tracking results. So that's where you will be doing the magic stuff. Anyway, if you go to the npm package website of any of the MediaPipe solutions, there is not so much documentation in this web page for it. So you have only the examples for vanilla JavaScript. But if you install any of these packages, of course, you have this on your node models folder, so you can go check there the source code. And that's how like I could run this with React.js by delving into the source codes. But yes, you can check in the page that this is very recent, so you can see that the version is very low, so it's a very beta version. So it's already really robust to use, but you have to keep in mind that this is very early in development, so it's kind of unstable. It's not so recommended to using production-ready applications yet, but yeah, you can experiment with it, and maybe you are brave enough to using in products. So anyway, so there's other utilities frameworks that you can use in MediaPipe. So there is this camera you choose to doing stuff with the camera, and this is actually needed for doing the process on live streaming. Another one that's really nice is the drawing you choose, so you can draw all the stuff that you are tracking, like the hands or the face. And after you install it, so you will install like following how it's the name in the npm package. You can import them like really straightforward. So you have to know the names of the components here anyway, and you can check this on the website of MediaPipe.dev in the examples for JavaScript, or you can see like the source code as I did to know what the names that you need to put here to import. So here I am making an example with MediaPipe hands, and I'm using some components of it. There is two components that are important from drawing you choose, and I'm also using the camera you choose from MediaPipe. So after that, you have to get the reference that I said before. So you need a reference for the webcam, the canvas. So you can use in a functional way using hooks. You can use the user ref hook, and it's really basic to use it. It's like you would do with any other HTML element. So you need just to set up the reference in the text respectively. So here we'll be using the webcam, but we are actually presenting the canvas. So we'll be drawing the webcam capture part to the canvas as well with the drawing stuff that is happening. And to set up the framework, you need to do this on the startup of the component. So in a class way of doing stuff, you will be doing this with component did mount. But in the hook way, in the functional component way, you will be using the use effect hook with the empty array of components here. And the first thing you need to do is instantiate the object for the framework that you are using. So here I am instantiating hands framework. And this constructor actually receives a parameter that is a function called locate file. And this locate file receives a URL for a CDN of MediaPipe, which have all the models files that is needed. So this is something kind of hard to grasp because this URL has they tend to change this URL from time to time. So it's like you have to combine some versions that you need to write in the URL here, and you have to match with the version that you installed the package. So it's a work of trying stuff, experimenting, and until it gets right. So, but I have some examples in my GitHub for like a boilerplate code for using React, and I am always trying to update with the most recent working version, so you can be right with it. Anyway, after you initialize your framework, you need to set up the callback function. So you essentially will be calling these dot on results functions and passing the on results that you need to implement. And after that, you set up the camera of MediaPipe. So the camera, it serves to like process each frame. So you have to call this on frame function, which is asynchronous, and you send the image that is being captured by the webcam. So that's why we need the webcam reference as well. And after that, you just call camera.start to start the whole process. And the last one is the onResults callback function, which you need to implement. You can like follow the examples that are in the MediaPipe.dev documentation. And this is where the magic stuff happen, where you've been doing stuff with the things that you are detecting and tracking. But yes, you could follow all the examples that are in this web page. But for doing specific stuff, you need to like delve into and try stuff. Anyway, so let's see some use cases and some ideas to use MediaPipe. So as I said, MediaPipe is for ML inference for video. So for example, you could use face mesh like this Mark Zuckerberg GIF here. This is not using MediaPipe actually, but you could do something very similar with MediaPipe face mesh by detecting like the eyes of the person and putting like a glass with, I don't know, maybe Free.js or something like that. This other example here with hands, which I am doing something with the hands. It's a prototype that we did in Senior Systems for a system of questionnaires and surveys with hand gestures. So the user can make some gestures to make some scores to the application, and it understand it and do something with it, like save the answer to a backend and show the user what was his answer. And with pose, this is an example in the MediaPipe.dev page. This is an example by Dan which analyzes how the guy is doing some exercise, and it draws like a 3D character that is doing the same stuff that the guy is doing. So this is very possible with MediaPipe. It's some kind of application that you could do. And there is another example here that I will try just to show you. Let me just load it. Okay, it's just a video that I did with an application that I did. There's no problem if you can't hear what the audio is playing. It's just the visual part is the important part. So here I am controlling like audio stuff with my hands. So I do some gestures and I can like click in stuff in the screen. So it's a very neat way to do some UX for the user. And I can change also the track. It's really nice to do. This is very beta. I did not share this yet, but I will share this in the near future. So maybe follow me on GitHub to get it. And essentially, this is nice to study about because, we have a early talk today about augmented reality with React and with Alexander, and he says about metaverse and all the stuff that is happening with these big companies and these big players that are investing in augmented reality today. So MediaPipe could be coming handy for this kind of stuff because of its machine learning models that is very robust. So yes, I recommend everyone that likes this to experiment with it. It has like a kind of a steep learning curve because there is not so much documentation for web stuff, but you could be like okay and fine by doing stuff with it. Anyway, thank you so much. This QR code actually redirects to a link tree of mine. There is like a bunch of links to my social media, so you can hit me up there, and I will see you right next in the Q&A.
Awesome. Thank you very much, Matthias, for this talk. It was really nice to see that we've got a lot of new possibilities and new stuff to improve the final user experience in our final apps. So yeah, really, really cool to see. As you guess, we've got a few questions. So let's start with that.
Let's go.
What are the best use cases that you see in the use of MediaPipes right now? We saw a lot of beta experiments, like you show, like just manipulating interfaces just in the wild by like we saw in many movies or something like that. But is there any, I don't know, final use cases that you see where it will deeply improve the experience for the final users?
Yes, by now we have like a lot of prototype kind of applications that people are doing, like trying to experiment like with I saw other day some guy doing like sign language detection for the hands, so people could do like some gestures and the system would understand these gestures, like doing a live translation of sign language.
Yeah.
So this could be like a nice real application. But I think in a practical way, as we are seeing all this movement around augmented reality, and I think we should see more of it in our applications in the future. So first we will need to grasp how to do user experience for this, because we don't know yet how it would be like the very best way to do to change our user experience, which is based on like clicking and writing stuff in the applications, and change it to like do stuff with the hands or with the face, so we have to first grasp how we can do this for the user, have like a really good experience. But I think experimenting already with it, like you can, when you are delving in this new stuff, there is a lot of things that start to appear to you that you first you did not think that would appear. So I think just delving like for real, like I want to do something, it's a good start. Then you can like see some applications going from it. So yes.
Yeah, that's good. That sounds really good. Yeah. I thought when you are talking about detecting sign languages, we could probably do the same with the lips to have a lip reading or something like that. That would be just totally crazy. But yeah, that's really cool.
Yes, and it's really possible. It's just right by now. It's possible to do it. So
yeah, that's nice. Is there any limitation in the use of MediaPipe in React Native application? Is there any limits? Not?
Yeah. So I run all my examples, all that I have, it's with React.js. So it's not with React Native. With React Native, you have to do a lot of stuff in the native part. So you have to mess around with the Android and iOS source code that is in the React Native, because there is no official binding library for it for React Native. So it's a work of really like messing with core stuff. I saw some people doing stuff with React Native, but as I said, it needs a lot of workaround by now. But yes, it's possible. But it requires a lot of effort. After I do the stuff that I want to do with React.js, I will try to do stuff with React Natives as well. So maybe in my GitHub in the future, you can see some stuff happen. Or no. Let's see. Sometimes it's hard.
Sometimes it just doesn't work.
Yes. Yes, this is something that it can happen. But you know, it's the risk, you know. It's the risk of doing this stuff. That's why research is so cool, you know, because it's like this feel that you don't know what will happen. When it happens, like really cool. But when it's not works, it's cool anyway, because essentially you learn something for it. So anyway, it's nice.
Yeah. So that's always a good takeaway to take.
Yeah.
So yeah, that's fine. Another question, a little bit apart, but what do you think about the camera released by OpenCV and Intel recently? Does it have sense to purchase it to improve the detection? Do you have any opinion about it?
Well, actually, honestly, I don't know about this camera. I'm hearing this right now. I don't know. Maybe if it's a camera with like the sense of deafness, if it has like this function, maybe it can become in handy. But MediaPipe was built to like cover a lot of different resolutions and camera types. So it's really a really good and robust models that is run by MediaPipe. So you will be cool with like your own webcam, like it's very okay to use it. But I think a better camera with depth sense would be like improving like the distance that you can track stuff.
Yeah.
So yes, that's where you could be good.
Okay, nice. Okay, just one last question about performances. May performances be impacted by the use of any AI solution like MediaPipe? And is there a way to prevent any performances issues, like, I don't know, shutting down the use of the AI API where you are not in the good condition, like a good network or something like that?
Yes, you could do something like lazy loading for just prevent things to load from the startup. But if you are using TensorFlow.js, for example, this is very performance heavy because you will be essentially using some models that are not so performant in this way. But MediaPipe, specifically MediaPipe, they run this model with WebAssembly. So that part that we have to load that files for the models, they are like a bunch of WebAssembly files, and there is also graph files that it loads. But WebAssembly, you know, it's very performance okay because it's very core to the application. So actually, MediaPipe is concerned with it, so you don't need to be worried about. But yes, there is the common stuff that you do in your interface that you can do to like try to prevent the latency and lag. But anyway, if you run like the examples with MediaPipe, you can check live in their webpage. You can see that the lag is very little. You know, it's very fast and it's very accurate to do the stuff with the MediaPipe. So that's not so much of concern yet by now. But yes, you can do like that little stuff to like try to perform as well. Yeah.
Okay, sounds good. So thank you very much for this awesome talk, and thank you for being with us. I hope you enjoyed it. For us, it was really, really nice. So thank you so much.
Thank you so much. Actually, today is my birthday as well.
Oh,
so yes.
Awesome! Happy birthday, then.
Thank you. It's like the best way to celebrate my
Yeah,
birthday.
that's
So
cool.
yes, I am very happy to this. Thank you, Nick. Thank you. Thank you to the people in the YouTube as well. Thank you to my friends that are seeing also and the support that they give to me. And yes, okay, thank you everybody. I'm really happy to be here.
Thank you, and have a nice birthday then. See you
Thank
later.
you.
Bye
Okay,
bye.
see you. Bye bye.
So yeah, what an awesome talk. I hope you now have more insights to how to embed any AI in your final application. I guess it's time for a new announcement, and then we will meet our last speaker for this matinee.
Our awesome sponsors, Neuralegen, also prepared for us a free hands-on workshop that will happen on 9th of November. It will start 1 p.m. CET. What is Developers First DAST? This is what you will learn at this workshop. Also, how can you integrate Nextploit into your pipelines? Also, by joining Neuralegen's workshop, we're together gonna fork a repo, set up a pipeline, run security tests, and look at the results. Register now with a link below in the chat.
And we're back. So here is the last talk for this matinee. After that, we will have a break. Let me add to the stream and our last speaker, Facundo Giuliani. Hey, how are you?
Hello. How is it going?
Oh, it's fine. It's a pretty good experience this morning with a lot of great talks. So it's really awesome.
Yeah, that's true.
I'm really pleased to have you today to talk about a new topic that we didn't cover from the beginning of the session about contribution and adding some new content to our final application with headless CMS and extra content on external solution. So
Exactly.
happy to be with you today. When you're ready, the stage is yours. So just let's go when you want.
Perfect. So let me share my screen.
Let's do that.
Share. There we go. Can you see my screen now?
Yeah, perfect. The stage is yours. So let's go.
Perfect. Thank you very much. And thank you for joining the talk. I hope you enjoyed. Well, today we are talking about headless CMS, traditional CMS, the difference between them, and how to integrate a headless CMS to our React applications. First of all, I wanted to introduce myself. My name is Facundo Giuliani. I'm from Buenos Aires, Argentina. I work as a developer relations engineer at Storyblock. Today we will talk about Storyblock, the product itself. I'm also a Prisma ambassador. Prisma is an ORM that you can use to connect to the databases in your applications. I'm an Auth0 ambassador. Auth0 is a platform that you can use for authentication and authorization in your applications. And I'm a Cloudinary media developer expert. Cloudinary is a platform where we can manage video and images for our projects. The talk is not related to these three products, but if you want to talk about them, or if you want to talk about Storyblock or any other topic, you can contact me. My Twitter handle is Facundo Zurdo, and my webpage is fgiuliani.com. So let's start defining what a content management system is. It is an application used to create and manage digital content. So we will have a platform where the users, that can be content editors or any other user that is going to generate content for our web project, web application, we will have a complete platform where the user can enter to an admin interface. In this admin interface, they will be able to generate content, create content, handle entities, and, well, create what we are going to display in our website. And in this admin interface, we are offering a friendly user interface for the user to generate this content. This admin interface will connect to an integration platform that will handle not only the admin interface, but also the database where the content that is generated is stored. And not only that, the same platform will offer us a view layer to give a visual representation to the content that we are creating in the admin interface. So in the case of the content management systems, we will have this user interface that the content editors are going to use to create the content, and using the view layer, we will display this content in our websites. But after analyzing this scenario, there was an issue, or probably not an issue, but there was a thing that was not working with the new frameworks and programming languages that were appearing during the years. Because the content management system, as we saw before, is a complete platform to not only create the content, but also present it using a fixed view layer. So we are tied to a certain programming language or a certain framework to display the content that we are generating. So in the case of the most traditional CMSs, and probably the well-known one, we have WordPress, we have Drupal, we have Joomla. These platforms are great because they are content management system, that they are making the work easier, not only for content editors, but for developers. But the thing is that we are tied to the visual representation, the view layer that they are setting for the platform. So in the case of WordPress, for instance, we are tied to use the programming language PHP to give a visual representation to the content that we are creating in the admin panel. And that's something that we probably don't want to do, because if we want to use a different framework or a different programming language for our web project, we are tied to use the one that was defined by the content management system creators. So having this in mind, a new concept appeared in the last years, which is the concept of headless CMS, which is a content management system where the content repository is separated or decoupled from the presentation layer. So we can see that we have probably very similar components that we have before with the traditional CMSs, but in this case, the headless CMS itself will be the admin interface with the friendly user interface for the content editors, and instead of having an integration platform, it will offer an API that we can use to connect to consume the content that was created in the platform from any front end, from any presentation layer. So the headless CMS will manage the database where the content is stored and will expose it using an API. That can be a REST API or a GraphQL API, depending on, well, the product and what we want to use. But what is cool is that not only we can use any programming language or technology or framework to display the content that is created in web applications, but also we can consume the content that is created in the headless CMS from different channels, different types of applications, like desktop applications, mobile applications, applications created by, for smart devices like Amazon's Alexa or smart watches. We can consume the content from anywhere because we just need to connect to this API as if it were any other API or any other third-party service, instead of being tied to a certain presentation layer. So we can identify some differences between the monolithics or the traditional CMSs and the headless CMSs. These last ones are decoupled, have decoupled the front end and the back end. So we can have the back end with the application offered by the headless CMS, and use it to generate the content, but present the content in the channel or the way that we want. What it gives us is flexibility, because we can use the representation that we want for the content that we are creating. Also, we are having a great developer experience and also user experience, because we are offering for the users, I mean for our internal users, let's say for the content editors, a great application to create and generate and maintain the content. And also we are offering a great developer experience, because the developers can use the technology that they feel more comfortable with, or they can select the technology, the framework that best fits on the project that they are working. And we are also offering a great end user experience, the user that is going to use our applications, visit our website, because we can use technologies to make the performance of the application faster and better. Also, what we mentioned before, we will have omni-channel experiences, because we can deliver the content that we are creating in the content management system in different channels, not only websites or web applications. Today, I will focus on one headless CMS, which is Storyblock. Storyblock is a headless CMS that exposes an API that can be a REST API or a GraphQL API that we can use to connect and to consume the content created in the platform from our projects. But what is also offering Storyblock, or what I think are two great features that the product offers, is a visual editor, and it has a component approach. The real-time visual editor offers the content editors the possibility of seeing how the content is going to look like before it is released. So they will enter to the admin panel or the application of the headless CMS, and while they are creating the content for the projects, they will be able to see how it's going to look like without having to do any deploy or without having to change the code of the application or anything. And also Storyblock offers a component approach, which means that the content that we are creating in the platform will be divided into components, or how in Storyblock we call them blocks, that we can reuse in different pages of our website. So we can have components like a header, a hero, a grid, and reuse these schemas or these structures in different pages of our website, which is cool because we can link this concept to the concept of a React component, and we can create visual representations for these components in our application, following the style and the behavior and the logic that we want. So we will order the content that we create and generate in the same way that we order the components in the code of our application, of our React project. Let's see a quick demo on how we can create content in a headless CMS and how we can use this content in our React projects. So what we are seeing here is a blog site, a blog platform. We have a toolbar here with the links. We can see this is the home page of the blog that I created. This is a demo project. We see different parts in the page. You can probably identify some components there. We have here related posts in the home page. So we can click on these posts, for instance, and load the article page itself. I mean, the blog post itself. We can go to the blog page where we are listing all the blog articles that we have, and we can visit them. You can see that we have some global styles in our page, but we also have different pages. And these different pages have different styles that we can use and different CSS styling that we are setting for each part of the page, but also for each component, let's say. And what I wanted to show, I mean, I will show the code later, but this is a React website, a React application. And here what I have is Storyblock itself. This is the admin panel that I mentioned before, where the content editor can come and create, generate, and edit the content. This is in the left-hand side, you can see the real-time visual editor, and you can see that I'm connecting to the local host. I mean, we are seeing the same project that I'm running here locally, and we can link Storyblock application to it. So what Storyblock offers me is to see the page, and seeing the page, we can identify the blocks, the components that we are creating in the content management system, and set the information and the content for them. You can see on the right-hand side that I have some blocks here, which are of different types: a teaser, a grid, a featured post block. And I can go to them and I can see the content that they include. I mean, here I have a headline and I have an image for this teaser block. Or we can see in this grid that we have the different features, Twitter, or the mail, the phone. You can see how the blocks and the parts of the blocks are highlighted in the real-time visual editor while I'm navigating them. But also we can click on the blocks, on the components, and you can see here the green border that identifies that this is a component, and we can edit the content. But not only edit the content, we can see how the content is going to look like without affecting the content that is saved in the database and that is being used in production in a real site. So for instance, I can click this teaser and I can start editing the content here. You can see that I'm editing the text, and I can go to another block here and I can change this value too. I can put other type of text here, and we can see in real time how the content is going to look like, and we are not affecting the real instance of our application. Because here we have a button that says save. If I click, I will generate a draft version of the page that I'm working, and we will apply the changes, but that's something that I don't want to do. I mean, I just want to see how it's going to look like while I'm creating the content. When I'm sure that the content looks like I want it to look like, I can click on the save button. I can go to the page and we can add other blocks, like I can add the text type of block, and I can go here and start typing, and you can see that the new component was added here. I can reorder the blocks and see in real time how it's going to look like. I can duplicate the blocks and add a new one and start editing from the one that I just added. Related post 2, we can put, and I can do all these actions, and we are offering the content editor a great experience while creating the content. Not only to the developers to use the technology that they want, but for the content editors to see how the content is going to look like, instead of having to fill a form without seeing the visual representation of the content that they are creating. To manage all this logic in the code of our application, I will show you, this is the project that I'm running locally. This is a React application. I'm using Visual Studio Code. This is the package JSON of my project. I want to highlight here two packages that I'm using to make that work. One is the Storyblock editable package, which is the one that allows me to connect my React application to the Storyblock application and be able to edit in real time the components and see the changes. I will show you later how it's linked to the code of our application. And the other component that I want to highlight is the Storyblock.js client, which is the one that we are going to use to connect to the Storyblock API and consume the content and display it using the code of our application. I have other packages that are not fully related to the demo that I wanted to show you. And here we have the main application of our React project. In the application, what we are doing is, you can see that I only have one JavaScript file for the application. And that's because we are bringing the content and we are dynamically generating the markup for the content depending on the URL that we are visiting and depending on the page that we are consuming the content from Storyblock. So you can see here that I'm grabbing the path of the page that we are visiting, and well, if the path is the root one, we grab the home page, and if not, we bring the slug or the URL of the page that we are visiting. Here I'm setting this preview to true because this is an example, but what we are doing is creating a story. That's how we call the pages in Storyblock, because it not only can be a web page, but also it can be a story representation in a different type of application, for instance. And for this story, we're using a React hook called useStory that I will show you the code later. Depending on the slug that we are visiting, we bring all the information related to that story. If the story is still loading, we show a loading message. And if not, if it's already loaded, we use a global layout with a style that we define. This is a React component. And we are using a dynamic component and sending the block that we just brought for this particular page as a parameter. We will see the code of the dynamic component to see how dynamically we can load the content of the page without knowing which blocks or which components we are using inside the page that we are seeing. Also, we can identify a page as a block. I mean, as Storyblock offers a component approach, we can think it about a block or a component that has other components inside of it. So we are sending this dynamic component a block as a parameter. This is the general, I mean, this is all the code of the React application that I'm using in this example. I mean, this is the application that I'm running locally. So what I'm going to show you now is the hook that I'm using. Here we are using the Storyblock client, the JS client that I mentioned before, and we are instantiating it to connect to the Storyblock API. And this is the object, the client that we are going to use to bring all the information related to the pages of our website. Here we are creating the React hook that I mentioned before, which receives a slug and the preview parameter. And we are using the useState React hook to set the story for the page. And whenever we will apply a change to that story or to that page, we will see in real time the changes applied. So we have a function in it, event listeners, where we are setting a Storyblock bridge. Storyblock bridge, you can see here where we are adding it. It's a JavaScript file that is living in this URL. I mean, we are including a script, JavaScript script from this URL. We don't need to do any other thing. And we are initializing it as the Storyblock bridge, which is the JavaScript file that makes the connection between our project and Storyblock application. So we add this script to all of our pages, or all the pages that we want to edit in real time in the visual editor. And once that we initialize the bridge, here we are setting a new instance of the bridge. We are setting some event listeners or event handlers for that bridge. Whenever we change or we save the story or whenever we publish it, we are going to reload the page that we are seeing. But whenever we input a change, we will grab that event and we will set the story, which is the function that we set here for the use state hook, with the new story that we are, the one that we are getting from the input event in the visual editor. So this is the part of the code that makes the visual editor to display the content in real time, I mean the changes that we are applying, and consume that from our application. You can see that it's that easy as connecting to this Storyblock bridge and setting these event handlers. We can set the logic that we need for our projects. I mean, I'm doing this here because this is what I need to do. And when we enter to the edit mode, which means loading the page in the visual editor of Storyblock, we are using the Storyblock client, the one that we created here, and using the get method to bring the story that we are visiting now, bring all the information related to that story. Well, we can set if we want the draft version or the published version, depending on the environment that we are working on. And if we receive data, we are using the same set story function to set the data that we are bringing. This would be like the initial loading of the page of the story when we enter to the visual editor. And whenever we apply a change, we are setting the story with the new story, with the changes that we just applied. And this is being visible in real time because we are using React and client-side rendering. We are setting here a use effect also to do the same, but for we are bringing the story and we are showing, saving the changes of the story again. We add the bridge if we are in preview, because in production, we don't need to add this Storyblock JS bridge because we are not going to edit things in real time in production, and we don't need to include that file. And that will be all the code that we need to link our React application to the Storyblock application. One of the things that I mentioned before was the dynamic component here. What you can see is that I'm importing a lot of React components that I created and that they are created here in my React project. And I'm creating here a list of components linking a value to the React component. So what we are going to do is this dynamic component will consume the information related to the block that is coming from Storyblock. We mentioned before that the block can be a page or each one of the components that is inside of the page. And depending on the type of the component that we are bringing from Storyblock API, you can see here that we are seeing the component field of the block that is coming from Storyblock client, from the REST API. If it's different from undefined, we are setting, okay, let's grab the block, the type. This type should link to each to one of these values that we have here, and depending on the value, we will return a React component, and that component is the one that we return. So in this case, we can see, for instance, that we have the page component, and I will show you the page component, which is a React component with a certain HTML markup defined for it. We are using here the Storyblock editable package that I mentioned before to say that the page is going to be editable in the visual editor, that we will be able to see in real time the changes that we are applying. And the page contains a body, and the body contains a list of blocks, that are dynamic components, because we don't know which types of components are them. So using the same logic that we used here, we will be able to render all the components for the page, the body of the page. So we can have, for instance, a teaser where we have the markup and the style for the teaser, and we are setting the headline, we are setting an image, bringing for that block, for that component, the property image with the file name and the alt text, and we can set that here for the teasers that we are going to use inside the body of our page. And I want to go back to the Storyblock application because I want to show you that that is the same that we are seeing here. We have a page with a body, and the body has a teaser inside of it, and the teaser has a headline and an image with a description or an alt text and the URL of the image that we are using. So in the example of the teaser, we can use all the properties that we are setting in Storyblock Headless CMS to be used with the code that we need and the logic that we need in our project. We are not tied to any particular visual representation. I'm using here React because that's what I use and that's what the conference is about. But you can use PHP, you can use ASP.NET if you prefer. You can use another framework like Vue or Angular, Next.js, Gatsby, Python, etc. This is an API that we are connecting to and bringing all the information related to the content that we are generating in the platform. We have here the visual representation for other components like the text that we used before, the grid that also contains the columns and nested blocks that are dynamic components. We have the feature post with the list of posts that we are using in the page, and we are defining the visual representation for each one of the blocks here of the related post, showing the image of each one of the posts, the title, and etc. And everything is rendered as we define the components in our application. In this case, a React application, but it can be done with any programming language or any other framework. The real content behind this visual representation is a JSON object that you can see here, the draft JSON or the published version of the JSON. And this is what the Headless CMS is really storing and managing in the background. We have a story of name home, which is the home page that we are seeing. We have a body, and inside of the body, we have all the blocks, all the components that we are using. And we have the component, the type teaser. We have the headline property, my travel blog. We have the image with the title, the file name, which is the URL, the alt text, and etc. This is what we are consuming from the Storyblock API and using in our React application without forcing us to use any type of visual representation or CSS styling, or even if it's a web project or another type of application. You have the flexibility of creating the project that you prefer for, the application that you prefer for the project that you are managing. If you want to learn more about this, you can go to storyblock.com/headlesscmsexplain, where you can learn more about Headless CMS and the difference with traditional CMSs. You can also go to the second URL to learn more about the visual editor of Storyblock. You can visit the repository of the Storyblock editable package, the one that we are using to link with the real-time visual editor, or you can go to storyblock.com/developers to learn more about which technologies you can use to link to Storyblock. And you have guides, videos, blog posts, articles, tutorials, boilerplates that you can use to start your project linking to Storyblock. So thank you very much. I hope you enjoyed the talk. If you want to contact me again, I'm on Twitter, Facundo Zurdo, or you can use my website, which is fgiuliani.com. And again, thank you very much.
Thank you, Facundo, for your talk about CMS and headless CMS content in React application. It was great. It was great to have you here. So I've got a few questions, and I'm curious about that. So let's start with that. I see that the content is served through form of an API. I guess it's probably a GraphQL API or something like that. So is there a way to cache the content served by the CMS in our apps, especially when we're suffering network connection issues or something like that?
Sure. I mean, again, what the flexibility that you have with a headless CMS is that you can manage the content in the way that you prefer, and the visual representation that you need for your project in your front end. So if you want to use a personalized cache layer, you can set that and consume the content from the headless CMS using the API and, well, manage the cache the cache layer if you prefer, or if not, you can use what Storyblock is offering, which is a content delivery API, which is improved to deliver the content in the best way, let's say, or as fast as Storyblock offers.
Okay, sounds great. Okay, so is there a way for a headless CMS like Storyblock to be compatible with server-side rendering, to hydrate server-side components and serve static generated files, or at least pre-rendered web applications or React applications?
Cool. So yes, I think that will depend on what type of project you are building, and not only for Storyblock, but for any headless CMS. I mean, how you consume the content and how often you need to update it. For sure, you can use server-side rendering depending on the type of the project that you are creating. Probably if you are creating something like the example that I displayed, a blog site, probably the best approach would be creating the static assets for the blog, because it is content that we can say that it's static, or is the same content that we are displaying for all the visitors that we are going to have in our website, or all the users that are going to visit our web application. But depending on the project that you are creating, you can use server-side rendering, you can use static site generation, well, depending also on the framework that you are using to create your project.
Okay. So that's really nice. And this one is probably, this one is for me, but because I'm curious about it. I'm using some solutions, especially when I'm doing my slides for my talks. That is named SlideDev, and in this solution specifically, we are using Modernix. So we are playing with a lot of Markdown stuff to power the slides and the application. And there is an embed view that allow you to edit live your different part of your views and your components. So is there a way to have an editable content embedded in our application by using the headless CMS like Storyblock?
So I would say that's how the Storyblock application works. I mean, the visual editor that we saw before is an iframe that is connecting to your web application running where you are setting it. I mean, you can be hosting your application in a server like Vercel or Netlify, for instance, or you can point that to the local host, like I did in the example. But having that inside your React application, probably that sounds like tricky, and we should see. I mean, we should play a little with the tool and see if that's possible. And well, if any of you is testing this experience, please let me know. Contact with us, because it's very interesting.
Cool. So I guess the message is passed. If anybody want to try it, so let's
for
do
sure.
it.
You know how to reach me now.
Awesome. So thank you very much. Thank you for being with us today. It was really great to have you. So enjoy the rest of the
Thank you for the
conference.
invitation.
Thanks a lot. So that's all for this second session, folks. So I was really happy to be with you today. I will pass the mic to another MC for the rest of the day. It was really cool to be with you. But the fact is, we will see together tomorrow, because I will be here this time as a speaker for 2 talks. So it will be really cool. So I'm Matt. I'm working at DevRiot, and I would like to really thanks all the Geekle team, Anna, Nick, for their awesome work on the conference, and for having me as a MC today, because it was really fun to be with you and really cool to handle all this stuff with you. So, Nick, I give you the mic for the next session.
Thank you so much. Thank you so much. Like we couldn't have found better moderator for this first 2 blocks. So yeah, thank you.
Thanks.
Okay, and see you tomorrow.
Yeah, see you tomorrow. Enjoy the rest of the day. Bye-bye.
Bye. All right, so now it's just us here. So yeah, as was announced before, we have some special activity by one of our sponsors. But before that, I just want to announce the winners. So yeah, we had another giveaway that we announced an hour ago that was for our annual subscriptions. So let me just display. So we picked three posts from our social media, and I'm just going to show them very quickly. So we have this post, which is like with a cat, obviously, which are the best ones. So yeah, please DM us on Instagram or write me an email at nick@geekle.us with a screenshot that's your post, and I will give you the annual subscription. Also this one, which has some grain of sarcasm, but yeah, we got that about not React projects. And also this one that also is really cool, nice post. Thank you for that. And also this one, but yeah, that's just us sitting here and maintaining this broadcast for you. Oh yeah, we still have 2 more annual subscriptions to give. So if you're interested, share a post with you watching. We still will have this broadcast going for like 6 hours or 7 hours. And yeah, we'll pick 2 more winners later. We'll send you a message, a DM or something. And yeah, I sent the link earlier to the Geekle library. So check that out. It's accessible from our main website. It gives access to our all conferences and all previous conference recordings. So yeah, check this out. And okay, so we are going to start our special activity, which is going to be a quiz about React. It should be pretty simple if you are familiar with React, as far as I know. And yeah, Anna, with her amazing speakers, prepared this quiz for you all. And I'm just going to present it for you. So let me just do this. And yeah, so here's our quiz which gives you a chance to win Apple Watch by our amazing sponsor, Intellias. And it's going to be an 8-question quiz. So I'm going to switch this. So here's the QR code or direct link, which is also going to be in the chat. I'm going to give you some time to join and enter your email, country, name, just as a basic information. And then we'll start with these questions. For each questions, you will have 20 seconds. And so we'll go through them together. And then after we're finished, I will just announce the just final seconds, and then we'll close and watch and look at the results together. All right, so I'm just giving you like 10 more seconds, 10, 15 more seconds to open this link. So we are all together there. And I'm just going to check that everything is in order, that the link is working. I also can display it on screen like this. It's bit.ly React 2021 quiz. All right. So I guess we can start. I'm going to just switch to the next slide. And the first question is, React.js is a free and open source front end. What? We have JavaScript library, Bootstrap library, CSS library, or none of the above. So yeah, you have 10 more seconds for this question before we'll go on to the next one. And okay, next one. React.js was initially released in, we have April, May, June, 29th, 2013, 2014. Well, you have only 5 more seconds to give this answer. And yep, next one. So what is used in React.js to increase performance? Is it virtual DOM, original DOM, both original and virtual DOM, or none of the above? Yeah, just reminding you that you should give these answers by that link we sent in the Google form. Just reminding you. The next one is, what is Babel? Is it a JavaScript transpiler, a JavaScript interpreter, a JavaScript compiler, none of the above? And the next one is, a valid red component can return only how many elements? Is it 1, 2, 3, or 4? So again, go to the Google form we shared and answer there. Like, I see you writing questions here in the chat, but we're not collecting these. I'm sorry for that. So 6 questions. What is the result, the output of this code? Console.log plus true console.log exclamation mark John. Is it 1 and false, 0 and true, false and none, or false and false? Okay, so question 7. In React, what is used to pass data to a component from outside? Is it set state, render and arguments, props, or prop types? Yeah, so last question coming up. And yeah, I see you. All right. And 8th question, estates, and last question, estates in React.js is also known as a permanent storage and internal storage of the component, an external storage of the component, or all of the above. And this was the last question. And I'm giving you 30 more seconds just to finish. I'm just gonna check if we're getting, yeah, we're getting responses here. So yeah, you have 20 more seconds to finish, and then I'm gonna close this. Okay, yeah, I'm just looking at numbers coming right up. I'll be showing statistics soon, but just giving you more time for this. 3, 2, 1. Okay, so I'm closing this form now. And yeah, so then give me just a brief moment to collect this data, take a look for it. And so this is not it. And that's not okay. So I'm just gonna open the spreadsheet with all the answers you gave. And I'll see how many of you gave the 8 out of 8 answers. Yeah, I see many of those. All right. Let me just refresh this so it's like final. Okay, yeah, so this quiz shouldn't work for you anymore now. And I can just go to some statistics, and we're just gonna take a quick look on these questions. So I'm just opening the summary and opening this. Just give me a couple more seconds for that. So share, just gonna share a tab. Is that it? Yeah, that should be it. So yeah, and just one moment just for me to open this. And then, yep, so we have our statistics. So yeah, let's go. The first question, React is free and open source front-end JavaScript library, which was 99% of you answered correctly. That was too easy of a question. And then React.js was initially released and May 29, which most of you got right, 2013. And so the next one is, yeah, by the way, we have 240 responses, which is a pretty cool number for this very, very quick quiz. Yeah, so what's next? The virtual DOM is used in React.js to increase performance, which also 84 of you got correctly. Then we have what is Babel, and Babel is a JavaScript compiler. 45% of you got this right. Then we have a valid React component can only return one element, which most of you already know. Yeah, it's also a pretty simple question. About this code, the output is 1 and false. 80% of you got this right. Okay, and then last two questions. In React, what is used to pass data to a component from outside? 89.6 answered props. And the last one, also most of you got this right. React.js is also known as an internal storage of a component. So what I'm gonna do is I'm just gonna share these correct answers on screen, just so you can take a look. And meanwhile, what I'm gonna do is I'm gonna take all of you who got this 8 out of 8. Wait a minute. And I'm gonna go to random.org, which I forgot to open, but I'm opening it right now. I'm just gonna do a very, very simple list randomizer and pick the first of you who will win Apple Watch. And also, by the way, we'll have 5 more winners, who will win. They will win 5 subscription, 5 promo codes from our partner JetBrains. With that, these promo codes, they will give you an annual free subscription for one of their products. So, as far as I know, which is also a pretty cool price. So yeah, I just give me a moment. I'm just gonna make a filter for this and pick 8 out of 8. So we have some people. Yeah. Let's Yep. 8 out of 8. So I'm not gonna show any emails. Yeah, let me just do a small but very important thing. Yeah, we should have enough time, I guess. But yeah, so let me just, yeah, it should be all right. So let me switch my screen to our just a browser tab. Oh, just gonna show this. So yeah, you see our Google Sheet. So yeah, here's 8 out of 8 winners. I'm not gonna show you any emails here, but here's the list. I just filtered 8 out of 8. Just gonna copy this. So the first one will win Apple Watch, and the other 5 will win codes for the JetBrains products. So I'm just copying this here and just click randomize. All right. So these are 6 winners. So chat someone who win Apple Watch, and like we will contact you about this. We'll write you an email, and all 5 rest of you, like Andrea, Azalea, Rena, Yasser, and Ray, we will write you. Also, I will send you later the PDF files that we got from JetBrains with these promo codes for their products. Okay, then I'm gonna wrap this up, but before that, I guess we will have some more announcement. So I'm gonna stop this. Okay, so what we have here, let me go. Yeah, regarding like I see that you're commenting on the like that question about compiler, and like about Babel, but to be honest, I'm not gonna comment on that because I'm not experienced enough with this. But I hope that it's actually right. But this is what our speaker sent to us. But I'm sorry, I won't be able to elaborate on that further. But I guess if it's an open discussion, we can continue later in the chat during the break. Okay, so what's left? What's left here? We have some like minutes here. Let me just open the agenda. So yeah, we have next moderator and our next speaker, Gabriel Tosta, and starting in 15 minutes. And so let's just go on a 15 minutes break. Yeah, so thank you very much for tuning in, for staying with us. We have good numbers of all of you watching here, and we have lots of talks coming. So thank you very much for staying with us, and enjoy the rest of the conference. I think I need to mention, and I want to mention that we have, like, yeah, I forgot about that. We have 1,000 likes here already. So earlier in the morning, at the beginning of the conference, Anna promised that we will have a MacBook Pro, I don't remember the model, giveaway after we reach this number. And so the next break, after the next 3 talks, we will conduct this giveaway. So what you will need to do, like, as you remember, I'm just gonna do this. So yeah, just go to our Instagram, the React Fellows one, find their post, like it, and comment. And don't forget to subscribe and hit button on YouTube channel. Like, smash that subscribe, smash that like button. I always wanted to say that. And yeah, and we'll pick a winner in, I guess, like hour and a half or something, like more like 2 hours before the next break. So now that we're at it, I'm gonna leave you to your break, and we'll start with the next speaker very soon. Thank you.
As a developer, you need to deliver fast, and you simply don't have the time to constantly think about security. Neuralegion can help. We give you, the developer, comprehensive and fast security testing automation for your entire application on every pull request. With every new pull request, Nexploit will run all the security tests your app needs without false positives. We can integrate directly with your CI/CD pipelines, whatever your environment. So what are you waiting for? Add Nexploit to your project and start doing unit security testing today.
And now we want to say thank you to our amazing sponsors, BetterMe. BetterMe is a leading behavioral healthcare app publisher with over 100 million downloads available in 190 countries. With workouts, nutrition tracking, and mental health coaching, BetterMe is an all in one solution for a fit body and mind. BetterMe has been on the most downloaded health and fitness apps list since 2018. Join today.
Okay, hello everyone again. So it's gonna me moderating this 3 next talks, surprisingly. I'm not gonna elaborate on that further, so yeah, you stick with me. Let's go straight to our first speaker because we are 1 minute late. So Gabriel, are you here? Can you please join us? Yeah, you're here. Hello, hello, nice to meet you.
Yeah, hello, how are you?
Yeah, I'm fine. Let's continue our React Global Summit. So what are you gonna talk to us
Uh,
about?
yeah, yeah. In this talk, we're gonna talk about Next.js. Have you already heard of it?
Probably. Yeah, of course I did. So yeah, the stage is yours. Good luck.
Okay, awesome. I'll share my screen.
Yeah, okay. Let me just edit. Here you go.
Yeah, can you see my screen?
Yeah, I
Okay.
do. I do.
Yeah, okay. So, hey guys, how are you doing? Today, gonna talk about stopping using Next.js the wrong way. And before we move on, I would like to tell you the motivation of this talk. When I started using Next.js, I thought at the beginning it was just like create React application. So I thought it was some bunch of features, but not something, not that much. How can I say? Not that much specific. And when I started working on it, when I started building my applications in the middle of the way, I realized that there were a lot of things that I was missing because I didn't pay attention enough in the documentation, and I didn't understand what Next.js is. So this is the topic of the talk today because this is all about my personal experiences, and I don't want you to face the same issues. Okay. Um, well, so before we get started, let me introduce myself very quick. My name is Gabriel Tosta. I'm Brazilian software engineer. I work as a software engineer since 2015, mainly on the front end and mobile applications using React. Okay, so well, the first thing that I would like to tell you is about the docs. Next.js has a strong documentation. They have a lot of features and a lot of stuff that is very worth to take a look on it. I know it could be a bit cumbersome to see all the documentations of all the libraries and the features we have in the day-by-day situations because we have a lot of things to build front-end applications. But if you are going to start an application using Next.js, I recommend you to take a look at docs and go further on it because it has real nice stuff that you're going to implement that will solve your life. And when I say about the docs, I mean we have a lot of concepts that we have to take a look. So Next.js introduces a different word, a different perspective from what React is. And saying that, I mean the Next.js is a React framework actually, and you probably heard that React is not a framework; it's a library. It's different from Angular, but not with Next.js. Next.js is highly opinionated. And it means that we have some things that has to do the way they developed. So I can use an example as the file system routes. We have a folder called pages, and everything that you have inside this pages folder will become a route in your application. And this is the only way you have to actually create a route in your application. And another example would be the APIs. Next.js provides you with some way to create backend stuff. in your next and in your React application. So you can create backend code, you can put everything together, and you can merge both things in order to get the backend code and pre-render your application with this backend data. And that's something very, very interesting. We can talk about it later. But besides that, we have a lot of words, a lot of concepts that we have to make sure we understand. We don't need to understand by heart all of them, but we have to know that they exist. So we have SSG, SSR, CEO, SPA, SG, ESL, ESR, SWR. So there are a lot of concepts that we have to understand that they are there. We use it knowing about them, or even though sometimes we use them, we are working with these concepts, even though we don't know about them. And we have actually the underscore app, underscore document, the error pages. We have some built-in components, and we have some other stuff as well. So we have a lot of concepts in Next.js that we have to make sure we have a good understanding about them, so that we will not use the 100% of the power of the framework. Okay. Well, so let's go to some of these concepts and try to understand them better. Let's get started by the pages. How routes in the React Next.js works. Okay, let's see this example. I have inside my pages folder a login route, and inside this login route, I have the login container and login form components that I'm using in order to split my application and have a lot of components. And I wanted to make all this both login container and login form summarized in the index.tsx file, which is the component that renders my login page. Okay, so basically this is the result of the index.tsx from the login page. I am just using the login container and login form here, and also I have a helpers.ts, which is just a helper file that has a lot of functions that will help me to compose my component. Okay, so what's the problem with this approach? If I try to build my app, I can see that we're gonna fail. If I try to run yarn build or npm run build, we will see this problem in the console. That is, build optimization failed, found page without a React component as default export in pages login helpers. And what this means? This means that our helper component, actually our helper file, doesn't have a React component. So that, let me show you, a good workaround would be exporting an empty component. So that way I could export the file an empty component, and that would be okay. The build would work. And then if I try to run yarn build again, I can see that, okay, the build worked, but I have a problem here. And the problems is I have now slash login slash helpers page, and it means that I have a new route on my application. Actually, I have not just the helpers, but I have login container and login form as well. And it means that everything that is inside the pages in the in the Next.js will become a route, and I don't want that, because I just want to have the slash login. That's the only thing that I care about. Okay, so in order to fix this issue, we can go to two different approaches. The first one of them is changing the nextconfig.js, the page extension property, so that I can say that the next will have to will look for files that ends with page.tsx or api.ts in order to understand them as components or API calls, and that way I can continue using my structure as the way we did before, but this time I have to change the only component that I want to export as a page, put in a .page.tsx in the end of the name of the file, and that way I can keep working uh, as the login container on the form and the helpers uh, would not exist in the pages component, okay, in the pages folder, sorry, and that's okay. And another approach would be changing the structure a little bit in order to put everything related to the composition of our page in a modules folder, or a folder, whatever you want to call. And in the login inside the pages folder, we have just to export the component in the modules folder, just like that. So that way we have only in the pages folder, we have only the components that actually are HALTs. So personally, I've already worked with both approaches, and the both works very well. It's much more up to you to decide what's more interesting for you and for your necessities. Okay, so these are very very good concepts that you can try, and in the future you can let me know what you think. Okay, and next topic is the link component. Let me tell you something very interesting. When we are working with links, generally we use two approaches. The first one is have an anchor tag here, and we have a href tag property, and this property we can put the next route we want to redirect the user, or we can also using as the same way we do in React router, we can do in the Next.js using the next router with a hook, use the router, and when the user clicks on the div, we can put a on click here, and when the user clicks on the on click, we redirect the user from dot push. Okay, so these are the two most common approaches, but I would like to introduce you a new one, and this new one is using the Next.js link component. What this guy does, let me tell you. It seems to be very, very similar to regular anchor tag, right? The only difference here is that we have an href property linked to the link and not to the a to the anchor tag. But behind the scenes, we have a lot of things going on. So the best way to tell you to show you what happens is to go to a quick demo. So let me show you. This is an application that I developed. It's here from Brazil, and I don't remember if I mentioned that I'm from Brazil, but now you guys know that. And basically, this is it's a e-commerce or something like that. You can build your actually you can buy your fruits and vegetables, and you go to the cart, you go to the payment methods, and you receive in your ROM, and that's okay. And what I want to tell you about this is, if I select some fruits to buy, I can add some of them, and then I have my cart here. If I click on the cart, look what happens. In my network inspector, let me see if I can. Oh, I can't. But here I have this checkout.js. Let me show you. I have this guy, and this guy happens just because I just opened my cart drawer. And what this guy does, this guy actually goes to the backend and sees, oh, okay, the user opened the drawer, and I have a red green button here that goes to another page. So probably if the user opened the drawer, the cart drawer, they will click on the green button to go to the payment methods, and then I will just prefetch the next the next route for the user. So that would be very, very fast to wait for the user to click on the button, to go to the backend, to go to the CDN, to get the data and to load it. So the Next.js link already does it for us automatically. It prefetches the next page, and when the user clicks on the green button to go to the confirm the order, I have straightforward the code in the front end, and it makes the application very, very fast. It decreases a lot the input lag, so it's very interesting. So if you guys when you guys will work with Next.js, take a look on this guy, because it will increase a lot of it will increase a lot your application performance. Okay. Well, okay. The next top that I would like to tell you is about the image component. This one is it's very, very interesting. It's amazing, actually. Let me tell you the fashion way to do that. If we have some component, if we have some posts component, and we would like to show some cards to the user, the regular way to do that is to have a image tag, and we can set the SRC property with the post image that I put just some random image here to illustrate the content of post.image. And also we change the style in order to make sure our image would be shown for the user. Okay, but this is the regular way. So let me tell you the next way to do that. In the next way to do that, we replace the image tag to the image component from next image. And what this guy does is exactly that. The SRC property is the same, the alt and title is the same, but the width and the height, in this situation, when we have the layout as responsive, we have to set it, we have to define a valid number. And that's because this is not a good practice. Setting the width as 100%, 90% of the times is not a good practice. So we have to prevent from the screen to be blinking, because the HTML doesn't know uh, how large would be our image. So if we do that, if we hard coded the width and the height, it will be very better for the browser to understand that we have a reserved size on the page, and there would be rendered an image. And then if we pass the layout as responsive here, we can next actually can automatically optimize our images. So let me show you with another quick demonstration. Okay, here we have a image. It's a regular image, and I have just a small screen. It's 300 for 340 pixels. Okay, it's a very it's a very small device. And then we can see here in our network log that we get an image, and this image, let me close this, has 641 width. Okay, it's 641 pixels in width. Okay, so this image has a size of 7.9 kilobytes, kbytes actually, and it took 90 milliseconds to load. But what if I have a bigger screen? Let me show you, and I'm increasing the screen, and after my screen is bigger than 640 pixels, I will do another API request. So now I have a bigger image. You can see here that the image is bigger because the size is bigger, and it took a bit longer to take the image from the backend. And we can see the quality of the image. Now it's uh, 750. Okay, so here we have a bigger image. And now if I increase even more my if I increase even more my image, I can see that I get from the backend a bigger, even bigger image, and I can continue doing that, and you guys will see that we are going to only get images that are really necessary for the user. If I'm running an application on my cell phone, I don't need to have an image with full resolution, full HD resolution. I don't need to spend uh, 23 kbytes of requests in the API. You know what I mean? So that way, it's very interesting. It helps us a lot in the performance and in the CEO of our applications. If you think about this application, this e-commerce here, where I have a lot of images, it improves a lot the performance. So it's very, very interesting to use Next images and to take a look on it. Okay. Well, the next topic is about the APIs and serverless functions. As I mentioned before, we can actually create backend data in our front end because Next.js provide us a way to create endpoints, and from these endpoints we can reach file systems, files from the systems, or we can get another endpoints, and we can do anything that a regular backend does. Okay, so in this kind of situation, let's see what's happening right now. We have two items that we are trying to retrieve. The first one is the post.json that's inside the data folder. So we have this data folder with a post.json that we are trying actually to read this file and to get all the content and put this here in the posts from file. And actually, we are trying to get another backend, which we are trying to reach another backend, get all this data from the response, and actually has the data and the posts from API. After that, we are merging all of it, and we are responding at 200 code with all the content in here. Okay, so when I have a posts um, file inside the API folder, I have a local host 300 API that I can reach the backend, that I can reach this code, and this code goes to the backend and goes to whatever else, goes to whatever you have to do in order to uh, compose the data and respond 200 and the content from the posts, both from file and from API. Okay, and then we can use it inside our get static props. That is a feature from Next.js. Okay, so here we have here we reach the localhost 3000 slash API slash posts. That is exactly this code. Okay, and we get the response, and we pass this response as props for our posts component. Okay, so here we'll have the posts component, and then we will render all the posts we have. But the problem is we are doing things twice. Unnecessarily. So let me tell you what is happening right now. First of all, our users are using the application from the browser, and then they are hitting our cloud functions, the serverless function that is the localhost 3000, and then the localhost 3000 is hitting on our local on our local JSON file, and actually we are also hitting the other backend, the localhost 5000. Okay, and then the localhost 5000 is hitting the database, and it goes all the way back to get the data to the browser. But what's the problem with this approach? We are duplicating the APIs. We get one API here, the get static props, goes to localhost 3000, and after that we goes to localhost 5000. So we are duplicating things here, and it's not good. That hurts performance a lot because have a lot of input lag and latency between um, all those services. So what we can do is, rather than writing code on an API, we can write code directly on the get static props function. That way, I just migrate everything from the API to the get state key props. This way, we remove the API call to localhost 3000, and we do only in one place. I put in the line 35 here the good practice, the documentation of the Next.js, talking about it, and and telling you exactly what I've told. So this is a mistake I commit before, and I think that it's very interesting. It's very helpful to know that before I make the all the mistakes I made. So this way we can just remove one part of the process, and we can make everything simpler. So that way we just hit the localhost 5000 and get our data and make our application even faster. Okay. Well, next topic is generation and render. So let me tell you, Next.js is very well known because it introduced heavier the concept of server-side rendering. But we have currently three ways of building a website: the static site, the server side, and the SPA. That is the last one I will tell you. Let me tell you how the static site works. I will just put in twice as fast here just to let you know. But the thing is, first time the static site works, the server goes to the API and get everything the it needs to build the index.html to build the page, and then with the content, it's the page is processed, and the HTML is stored in somewhere. And after that, it goes to each one of the items, each one of the fruits, and it goes to exactly that slash in the path to get the details of the fruit. And after that, the server keeps all of this information and builds the web application, the HTML, the JavaScript, and put all of it on the CDN. So when the user opens the fruit.com, we go to the CDN, and the index.html is out there, the content is out there, and the user doesn't have to wait anything because we already have done it in the backend before. Okay, so that's a very very interesting way to do things, and Next also allows us to do this kind of behavior. Okay, this is the first one. And the next one is the server side. A lot of people like a lot this one because Next becomes popular because of this one. But I will tell you some drawbacks of this one as well. Let me show you. Here we go to the fruits.com, and the fruits.com's the API goes to the server. The server goes to the REST API. Let me go to twice as fast here. Just a minute. Goes to the REST API, and then the REST API responds all the fruits we have to the server, and the server processes information, and after processing this information, it throws the index.html to the front end, and the front end has almost the same behavior we had in the static site. But the difference here is that the server is running in the runtime, so it can do some validations that in the static server, in the static version, we will not be able to, like okay, I will only show bananas if the user is a super user, or if the user likes banana, because there are some users that don't like it. So this is the pros of server side. But the drawback actually it's that we have to recreate the HTML on the server. We have to reach the server, and after the server we reach the REST API, and after that we build the index HTML, and we after that we send the index.html to the front end, and it can take a while. It can show for the user a blank screen that probably you don't want to. So you have to be careful about this server side. Okay, this approach. But basically that's it. That is the approach, and the same happens when you click on an item, and you guys can go further and deeper on it after the talk, and you can ask me questions. And the last one is the client side. I think this one is the most of you are use it to. First, we go to the CDN, we get the index.html, and let me put it faster. And after we have the index.html, we go to the CDN again, and we get all the JavaScript, and the JavaScript loads the content, and the React it starts calling the API in order to get the fruits, and we show a loading to the user. And after that, when the API is done, we show the content for the user. And this approach is the we are most used to. Okay, and and what I want to tell you about this all these three approaches, it's like a homework in order for you to understand. Should I put server-side code everywhere? Should I can I use static site somewhere? When should I use static the static approach and the server side approach, or the client side approach? There's no how can I say, I don't know the word in English, but there's no silver bullet. That, yeah, that's the right term. You have to understand what you are doing, and where is the right approach to put what you are intending to do, you know. Well, and that's it. And besides all of that, we have a lot of other approaches that it's worth to take a look as well. So Next.js provides a way to handle with CSS, fonts, local storage, and cookies, where when you should use local storage, when you should use cookies. This is a very interesting subject to discuss. How Next.js caches images, how caches links, how caches bundles, and there are a lot of approaches that Next.js does behind the scenes that it's very interesting for us to understand. The static optimization, that it's a very interesting subject as well. How can we deploy your application in the Vercel? That is the company that built Next.js and actually has a service to host your Next.js applications. How the fire usage policy works, I put this one here because um, I extrapolate the fire usage policy these days before, and I was not aware of it. So it's very interesting to understand how it works, and how the serverless functions and the pricing works, because the front end is almost everything is static, but when we are talking about backend, it generally has a price. So it's interesting to understand how it works and how much it can cost for you. And also we have some interesting stuff in the CLI, the difference between start and export, the next start and next export. It's the two different approaches that we can use. So we have some interesting things that we can do here. We can understand about Next.js that I recommend you to take a look before moving on and trying to implement it. Okay, so well, I think that's it. I hope you guys liked the talk. If you have any questions, you can find me on LinkedIn. If you go to this link, you can see some other links I have. So maybe it's easier for you to reach me. Okay. Hope you like it, and that's it.
Thank you so much, Gabriel. And we're gonna have a Q&A session after the next topic, so stay
Yeah.
with us on the backstage. And yeah, people, just go to that link. Also, Gabriel, you can copy and this link, send it to me. I'll just send it to the chat.
Yeah.
Okay. Yeah. So see you soon, and see you in 20 minutes actually.
Okay. Amazing.
Yeah.
Bye bye.
Bye. All right. So without any further ado, I just going to announce the next topic. It's going to be a pre-recorded session by Colby Fayock. And it's called Getting Personal with E-commerce, React, and the Static Web. Enjoy.
Hey everyone, today it's getting personal. We're going to talk about e-commerce, React, and the static web. So who am I? I'm Colby Fayock. I'm the one hugging BB-8 and Kylo Ren over there. I work with the dev community as a developer advocate for Apple tools. You can find me pretty much anywhere on the web by just Googling my name, as I'm the only one in the world. So let's look back to about the end of 2019. It both feels like it was 10 years ago and just last week. We were all able to safely go out to restaurants. We could meet up with family and friends. We could even grab a bite to eat alone. Now we can sort of do some of that stuff, but it's different. And it's still not completely safe. But I don't think any of us expected that 2020 would be the year that we would actually meet a pandemic. I know I expected 2020 to be the best year ever. But that's realistically what happened. Stores and restaurants started shutting down because they couldn't support the decline in business. I lost my favorite restaurant in Virginia, and I was really hoping to hit it up one last time before I went up to Pennsylvania. Luckily, some restaurants were able to sustain themselves. Between apps like Uber Eats and Instacart, we've been able to attempt to have normal lives at home. Restaurants have also attempted to offer curbside pickup for themselves, but this can be really hard for business owners, especially if they're not used to actually fulfilling orders this way. Because we have those options out there like DoorDash and Uber Eats, these restaurants could quickly start accepting orders without dealing with all that technical infrastructure. Unfortunately, these services still tend to cut deep into the restaurant's profits, so this makes it extra challenging for them. But this most certainly helps some of those restaurants actually stay afloat. The reason that some of these restaurants even had the opportunity to save their business is because of e-commerce. Now, small brick and mortar mom and pop shops might have over 50 years of business experience, but when you're in a lockdown, a lot of those in-person advantages start to fade away. So let's talk about e-commerce. The concept of e-commerce probably isn't new to anybody, but it's simply the act of buying and selling online. Whether you're buying a TV shirt for your favorite TV show, or you're buying some food from a local restaurant, or even filling a prescription, e-commerce gives us a way to buy things without ever leaving our home. And it's not slowing down. We saw a huge amount of growth in 2020 because of, well, the obvious, but more and more people are getting comfortable actually buying online. And in the middle of a pandemic, more and more people need to buy online. On top of that, more services are just simply making it even easier to buy online. As developers, we're the backbone of this growth. Every online store has a single developer or huge team that's actually supporting building out that experience. We're the ones that people give the ability for people to actually buy online. So that makes it compelling for us to have a general understanding of how it works. But before we get into the development side of things, let's take a step back and actually talk about e-commerce a bit more broadly. While the concept of an online store might not be new, and you might be pretty familiar with generally how it works, let's break down some of the core characteristics of a store. What are some of the pages that actually make it possible to buy something? Well, to start, we have the product listing page, or PLP for short. These pages come in a wide variety. From a page that includes all products under a single category like apparel, or it could just be a clearance page, which would list all of the products that are currently marked down as clearance. The point though is it's ultimately a page that lists the products that somebody can actually browse through. Next is the product details page, or PDP for short. It's the page that shows a single product, and it also includes the variations like the different colors or the different sizes, but this page, it gives the most comprehensive look at a single product. It's also where somebody can typically actually purchase that product from. Some sites have a nice little quick add-on where you can add the item from the PLP or the product listing page, but you can always be sure that you're going to be able to find the buy button or the add to cart button on the product page. Next, we have the cart page. After you find the product that you want, you add that product to your cart, just like a real life shopping cart. You have each of your products that go into your cart, which we can take them to pay and actually get checked out. Which leads us finally to those checkout pages. Sometimes there's a single page that represents the entire checkout process, but more often you'll find a multi-page process, which will give a little bit better of an experience as somebody's actually trying to work through all those forms. But here you're going to add your shipping information, your billing information, and actually confirm your payment. If successful, you'll have purchased the product and you're usually giving a receipt. As I was walking you through those pages, we essentially step down through what's called e-commerce funnel, which you might be able to figure out why it's called a funnel, but as someone is actually moving down the listing from a listing page all the way down to the details page and all the way through to the checkout page, they're moving through a journey of steps in your online store. That journey kind of looks like a funnel when actually represented by data. Starting from the top, which may or may not include that listing page, is where people are typically entering your site. That could be by browsing through a listing page. Or it could be directly to a product page. Maybe they found it in a Google search, or maybe they found it linked online. Whatever the case, that first page will be the top of the funnel. But through every step of the way, more and more people drop out of that funnel. Maybe they had second thoughts, or maybe once they got to the cart that they realized that they have a bunch of other products in there and it's just a little bit too much for them for that particular time. But either way, most people aren't actually going to hit the checkout page. And even those who do, only a percentage of them will actually proceed to make that purchase, which as people filter out, that's where you kind of get that funnel shape. But ultimately, these are the critical pieces of a typical e-commerce store. We want to be able to optimize this process so that people visiting our stores have a good experience. Each of them come with their own unique challenges. Now, I would bet that most of you have purchased at least growth chart from earlier. E-commerce shouldn't really be new to anybody, but again, I want to take this and talk about it from a developer perspective. What are some of the challenges from the technical side of e-commerce? Back to our product page, beyond the typical layout like the branding and navigation, we have some critical components of our page. The image, the title, the price and variations, the cart, and the button to add it to the cart. When we're actually trying to serve this page, it can't just be a static HTML page. Some of these pieces need to be highly dynamic in an online store. Parts like the image and the title, they shouldn't change that often. They're probably okay being static and waiting for that HTML file to update again. Even the variation selection, we probably know all the variations ahead of time, so that could still be a static list of options too. But the price, the availability of that item and its variations, and even being able to purchase it, they all need to be super accurate when somebody is actually trying to buy it. If the price is wrong, your customers might complain that they're getting overcharged. If someone buys that item and it's sold out, you're stuck not having enough items to actually send out to people, meaning canceled orders and unhappy customers. Now, the good thing is, though, we have a lot of options with how we can solve this. Some solutions are more traditional, but we have some modern techniques that can help give our customers a great experience. Serverful solutions are probably the more traditional. The browser makes a request to the server, that server renders the page, and returns that HTML to the browser, where the customer can actually shop. With a serverful solution, our dynamic content really isn't a problem. Each page request hits the server, so that page can be completely custom tailored to the actual state of that visitor, whether that's reaching out to a database to grab that person's logged in state, or grabbing the real-time price and availability of an item. But there's another option where we can serve our website completely static. Instead of taking that time on the server to actually render that page, we serve the static files straight from storage. That includes the HTML, the CSS, and the JavaScript, and any other files or assets that we actually want to show to our customers. When it's served statically, we don't need to do any of that work on the server. We deliver the website directly to the visitor. In order to make those pages dynamic, we can reach out to APIs from within the browser or at build time. So what would that actually look like in practice? Well, showing some images and text on a page doesn't need to be dynamic. Leveraging the tooling we have, we can completely statically generate the page's HTML and CSS, along with any of the JavaScript, and just simply dump that into object storage. We can even display a bunch of products in a grid. Like we talked about before, this doesn't need to be dynamic. There's nothing necessarily special with how this page needs to be put together. And to be clear, I'm not sure if Space Cadet, the store that I've been showing here, is actually static. I think they're actually on something like Shopify, but beyond a typical content management solution that triggers a new deploy on every update, this doesn't need to be real-time dynamic. But moving back again to our product page, the vast majority of this page can still be static. Our images and the meta information can be served straight from static hosting. We can let that refresh anytime a new deploy actually happens. To provide the dynamic aspects, we can take advantage of client-side requests. We can pull that price directly from our e-com platform like Stripe so that it's always up to date. For our cart, we can store that state in local storage, or we can use a serverless function to actually hit a database with that information. The stock is probably the trickiest thing of all this. Imagine a website like Amazon, where you may literally have 1 million people trying to buy one single product at the same time. On top of that, that product might have very limited stock. You need to be able to support very quick read and writes to actually avoid overselling. Now, content management solutions typically aren't equipped for that kind of thing. Some are, but most aren't. And you'll want to instead have an e-commerce service with inventory management actually built in, or a performant database solution that can actually handle that kind of thing. But either way, we want to be able to avoid those unhappy customers. But as we sort of dissect this page, we can see that realistically, we could serve the underlying page completely static, which will alone give us a bunch of wins, while still maintaining that dynamic nature of an online store. Now, those dynamic pieces are probably the bigger challenges that you'll face specifically with e-commerce. But I mentioned that by serving our page static, we get a bunch of other benefits. So what exactly are those benefits? Once we have those core pages in storage, we can serve them from a CDN like Cloudflare or Netlify or AWS CloudFront, where using a CDN allows those pages to get served from locations all over the world. They'll at least be relatively close to your visitors, which means they're going to get served super fast, which is a good thing because people want their pizza really fast. Like here, Little Caesars used Gatsby for their website and ordering experience. But beyond hungry customers, page speed is important because it directly correlates to conversion rate. If you're not familiar, conversion rate is going to be the percentage of your traffic that actually buys something. There's a ton of studies on this, but eBay, for instance, found that a 0.5% increase in their conversion rate for every 100 millisecond load time improvement. Now, that doesn't really sound like a lot, but eBay is worth over $10 billion. So just as an example, 0.5% of 1 billion is 5 million. So that adds up pretty quickly. And bonus, serving static files from CDN most likely means less downtime. The fact that the page files are static and on top of that, cached at the edge, those pages will infinitely scale. You don't need to really worry about how your website will scale aside from your APIs that you're getting hit on the client. There's less of a chance that you're going to get completely taken down by a Reddit hug of death or by an instant surge of high volume traffic, which can mean lost money if people can't buy your products. It's also going to be cheap. While this might not matter as much for big corporations, for small business owners and individuals, every cent counts. The fact that there are so many services with free tiers, you can literally get up and running with a new store for free, then scale that cost of processing payments as you grow. So now that I've convinced you why this is a good idea in the first place, where do we actually get started? While trying to narrow down ecom into 3 things feels like a little bit of an oversimplification, there are really a couple of core components of an online store. You have your products that you want to sell, you have to be able to take the orders and payments for your orders, and you want to ultimately need to fulfill those orders. These 3 all work together to provide the goal of being able to sell things online and get them to the person who actually purchased them. First off, in order to have a store, you need to sell something. What products do you actually want to sell in your store? Your products are the first thing that your customers will see when they actually visit your store. Where are you going to store that information? Is it going to be a CMS or is it going to be a flat JSON file? How are you going to actually show those products? Maybe you have a few products on one single page, or maybe you have an entire catalog with search capabilities. While most of the heavy lifting of an online store happens in the background, you first need to have an idea of what products you're actually going to be sell and how much they're actually going to cost. That way you can give your customers some kind of option that they can buy and discover. Second, when selling something, you need to be able to take people's money. How are you going to take orders and payments for those products? Once your customer finds what they want, they'll need to pay for it. Are they going to interface directly with a payment processor, or are you going to create a bunch of forms to take that information? Or are you going to use a service that handles all the checkout details for you? Taking payments and dealing with addresses is very complicated, and even more so when you start to deal with international customers. These are sensitive parts of your online store that need to be handled with care. Building this all out yourself is definitely doable, but it's not something that you want to actually take lightly. Regardless though, you'll need to figure out how you can securely take the payments for your store and then relate those payments to an order. And third, after somebody picked out something that they wanted and you took their money, how are you going to actually deliver your product to your customers? Is this a digital product where you can email the person or just let them download it? How is this going to work? There are a bunch of integrations that you can use. I know it's not perfect, but I use a mix of the Stripe API and an email service for my personal ebooks. But not every platform makes it super easy to have some kind of customizable end-to-end workflow. If it's a physical product, you actually need some shipping information. Who's going to actually pack that product up and ship it? Some e-com platforms might handle this for you, but a lot of them won't. Once you actually take somebody's payment, you're on the hook for getting them what they paid for. You need to make sure that that fulfillment process is working pretty smoothly. And while all of these are critical pieces to building an online store, we're really going to focus on the first 2 of these pieces. There's a lot of software and technology that can even handle the fulfillment part of things. There are even options for embedding that software inside of your online store and the emails so that your customers are getting a completely customized and personal experience. But as developers, more often than not, we're concerned about how we get those products up on a page and how we can actually let people buy those products. So we're going to focus on that. So with that said, we need to figure out what our stack is going to look like. What are we going to actually build our store on top of? Well, as we talked a little bit earlier, there are a ton of serverful solutions. You could totally spin up your own with completely custom infrastructure. That's exactly the type of system that I worked with at ThinkGeek years ago, where we had a good old-fashioned Perl code base. But in modern times, there's a lot more powerful e-com platforms that have risen up. Shopify, for instance, is a super powerful solution. It comes with an all-inclusive feature set. This lets you do a lot of stuff with just Shopify out of the box, like complete product management, page creation, and checkout. But if you're a new business or you're just doing this for your portfolio, this is going to come with a really hefty price tag. And this isn't only Shopify, to be clear. Most vendors like Shopify are going to have a similar price tag. Another familiar solution is WordPress, where you can use tools like WooCommerce, which is really popular in the WordPress ecosystem. With it, you can easily sell products on your website. But with WooCommerce or any serverful solution, you'll need to have to maintain servers, which frequently have costs involved. Again, similar to Shopify, these are great, powerful solutions. But I just convinced you that we want to build this out statically, right? And we're not looking to spend a ton of money just to spin up our first store. Which brings me back to the static apps. One of the cool things about the development and Jamstack communities is there's a ton of vendors out there who offer free tiers for devs like us that just want to get started. This applies to whether you're spinning up your own sticker store like me, or you're actually building out your portfolio projects. There's e-commerce services that can handle things like payments. They take a percentage of the transaction rather than a monthly cost. That means you're only going to have to pay money if you make money. So to start off, we need to manage our products somewhere. This is where we can take advantage of a headless CMS, where we would put all those products in at compile time and load the static metadata that we were talking about earlier. In my case, I use WordPress for my spacejelly.dev website and store. I know WordPress isn't the most popular solution in the modern bleeding edge world, but it's working really well in my case, and is a common platform for when you're building this out for somebody else. There's also a ton of other options available. Another cool thing about the Jamstack community is there's a ton of services available, meaning it's more likely that you're going to be able to find one that exactly fits your needs. You'll also be able to need to manage both taking payments, but also being able to have people add products to a cart. One example is Snipcart, which is a drop-in solution that allows you to easily add a shopping cart to pretty much any type of website. Once you add in the Snipcart script from their CDN, you literally just need to add some class names and some data attributes with your product data. And this doesn't apply just to static sites, to be clear. You can really drop in the script on any kind of page. But once you do, you pretty much immediately have a shopping cart on your website backed by their platform. This includes the entire checkout process. It's a really great solution if you don't want to have to deal with a lot of the logic that comes with building a shopping cart. It can be a bear, and this makes it really easy. It's actually what I use for my spacejelly.dev store. It also includes things like inventory management and payment processing. You can actually avoid having to deal with manually keeping track of your stock. Snipcart and other e-com platforms will handle that for you. You also have a lot of other options, like if you want to dig a little deeper and work on a custom solution, you can use your favorite framework like Next.js or Gatsby. Once you create your new app, you have full access to the capabilities of React. With it, you can create your own shopping cart. Since at that point you have the flexibility of React, you have full control over how somebody goes from adding an item to the cart to getting to that cart page. You also have the full capabilities of React's baked-in APIs. You can manage your own shopping cart state with React's use state hook. You can make sure that that state is actually global using a context API. That way you can be able to provide the exact experience that you want for your customers. Or if you want to take that custom experience, but you don't want to have to deal with the tricky cart state, you can even use a pre-built library like Use Shopping Cart, which will give you a cart state system out of the box with a React hook. That will immediately allow you to get productive with cart state inside of your application. With either of those solutions though, you can always store that state in local storage. That way when somebody actually refreshes the page or leaves and comes back after a second, they can still see all their products inside of their shopping cart. You can even persist that cart state to a database, but that doesn't necessarily become critical until you want to persist that between sessions, or if you want to support a shared cart system between multiple devices. But either way, once you have your cart state, you can use something like Stripe Checkout, where you can push your customers into a custom checkout solution. Using Stripe Checkout won't handle all the aspects of an online store, but similar to Snipcart, Stripe will handle the checkout process, which is one of the bigger pain points of actually taking people's money. The cool thing about the static approach, though, is you can even take advantage of APIs of all aspects for the dynamic pieces. We can still use services like Shopify if we want. While you'll still be paying that price tag of Shopify, if you're already there or you still need all those capabilities of Shopify, it makes for a great opportunity to leverage both of the worlds, the benefits of static sites and your Shopify store. But whatever service you need or choose, you'll ultimately need to deploy it somewhere, which is probably the easiest step of this entire thing. Once you have that compiled version, you can serve it really wherever you want, really. At the point, it's object storage. So whether you want to use Netlify, which is a great solution, or one of the other many cloud providers out there, you have a lot of options. So what's stopping you from building a new online store? The cool thing about e-commerce is it's become a fundamental piece of our everyday lives. Millions of people around the world are shopping online. So having the tools in our hands makes it easy for us as developers to spin up new online stores. If you want to learn more about how you can build your own online store, you can check out my new course, E-commerce on the Jamstack on Level Up Tutorials, where I'll walk you through how to build your own store with Snipcart, Next.js, and headless WordPress. I'll include the link in my talk notes, and you can find it over at leveluptutorials.com. And that's it. If you want to learn more and chat about the talk, again, I'm available anywhere at Colby Fayock. You can find the link here at /React Global. And otherwise, I'll tweet out some of the stuff you've seen today. Thanks, everybody.
Oh, all right. Yeah. So we are here. We're back. And I'm saying thank you to Colby. And I'm saying thank you to Colby directly because he's here with us. Hi there.
Hello. How's it going?
Yeah, fine here. Let's have our Q&A session. We are a bit late, but let's start. Gabriel, are you here? Yeah, you're here.
Yeah,
too.
I am.
Welcome back.
Hello.
And yeah, let's get to it. I'm going to start with the question that I just had in the chat. So for Q&A session, please give some tips and tricks when building PWA with Next.js.
Okay. I think this is easiest one to answer. If I'm not wrong, we have a library called Next.pwa, and it's just a plug and play. You have in the next config you put you import the next PWA, and it's easier. It's very easy to put it there, and everything will start working automatically when you start your application. Now the manifests and stuff like that will be generated, and you have everything related to the PWA working.
Thank you. Colby, do you have anything to add? Your own tips and tricks?
I think that's pretty straightforward. Next PWA is the package. I haven't actually worked with it myself, but I know of it and I know people like using it. So
okay, thank you. So let's go straight to the next question. Yeah, we collected some questions through all these talks. So let's have another one for Gabriel. So Gabriel, does the next /link component, I guess, have an A tag within it, or is that just a personal preference? I guess that's what's caught from your code.
Yeah, it has to have a anchor tag inside of it. It's the way it's designed by the Next.js thing, because in the end of the day, if you try to expect your HTML, the link component will be gone in the HTML, and you just have the anchor tag there. So the link is just a mechanism in order to prefetch everything and do the things Next does behind the scenes. But yeah, we have to have the anchor tag.
Thank you for clarifying that. So we have received a question, I guess, for both of you. Any recommendation on architecting React apps? Who wants to go first?
So I've also been really deep into Next.js similarly, and I've kind of enjoyed creating them the Next.js way. And, that's generally with like the file system based routing, which makes it really handy to create different pages. But I also, depending on what kind of things like CSS I use, I structure my CSS a little bit differently, where if I'm using CSS modules like I'm using Next.js, I'll create like a folder per component where I can include things like tests and even storybook files within that folder and import that all when working through my project. But that might not necessarily apply directly to a pure React application, but I really like working in the Next.js environment personally.
Yeah, it may vary depending of what are you doing, what are the libraries you are using. But yeah, the if you go to the best practices, the Next.js team recommends, I think you are good to go.
All right. So we have another question about Next.js. So Next.js doesn't support browser history manipulation. How to tackle it?
I think actually we can do it. Yeah, we can do it. We have maybe I'm wrong, but you mean we have the next halter, and we can go forward and backward and forward and back, and we can do everything regular create React app though. So not sure about this question. I don't know if I understand it right.
I'm wondering if
Well-
it means some kind of like first party support for methods that would automatically manipulate it for the person as an API. But you can use the native browser APIs to manipulate the browser history, which I would imagine would work pretty
Yeah.
well with Next.js.
Yeah, I think we have the next/halter, and there you can use everything a regular React halter does. So it's linked to the browser history, and yeah, I'm not sure.
Okay, thank you. Then let's move on to the next question. Let's go with this. The modules approach seems cleaner. Thoughts?
I personally prefer, actually, to be honest. In the beginning, I started with using the prefix, the .page.tsx, but in my newest projects, I'm using the modules folder because what I have in the pages folder it's only related to the HALTs that I have, so it's cleaner to understand what exactly are the HALTs that I'm working with and that are available in my app.
Thank you. Thank you for giving your experience on that. So okay, we have lots of questions actually. Let's go with this one. Get static props run at the very start while loading the file, right? Also a quick one.
Yeah, actually, this one runs when you build when you are in development mode. If I'm not wrong, it works. It runs every time. Every time you open the browser, you open the page. But when you build it for production, it runs before in the building time. It doesn't run in the when the user the user is actually running your app in the production. It's just in the build time.
Okay, thank you. So let's go like with more quick ones, like more specific ones. Oh no, that's not it. You only upload one image size and next do it all alone. How the browser knows it's has 100% width?
Yeah. Okay. It's because of the resize. There's a proper. I don't remember. I just tell you about that. But
The aspect ratio?
Sorry.
Is it the aspect ratio property?
Yeah. If you put the image width and height, you can set the basis of the image, and you can stretch and shrink it. But it depends of the layout, the property layout you can put on the image. But yeah, if you put an image there, next you will generate a lot of other images with different sizes, and we'll compress it. Actually, we'll convert it to WebP. That is the latest, the most recommended version for images to be used in the web.
All right, thank you. So let's go, I guess, with this more broad one. Or I don't know. Which best work with Next.js Material UI or Chakra UI for performance?
Well, for performance, I think both of them works pretty well. Both of them are very performatic. I think Material UI in the next release, they changed the way you implement the components by setting the CSS and the props as the Chakra does since the beginning. But I think you won't find anything related to performance in both in Material and the Chakra UI. It's just a matter of preference. What are the features you want to have in your app and the look and feel. I think related to performance, you won't find problems with any of them.
Thank you. So let's continue with this one. So, yeah, so a person is confused. Kind of confused with Next.js. How can we create a client-side app? I mean, with the next build and next start, it will be SSR, and with the next export, it will be static.
Actually, when you run next build, it will generate a client-side app. The difference is if you have the /API, it will generate actually a backend side code as well. And if you have server-side props, get server-side props or get static props or something like that, it will create a Lambda that is a serverless function too, and it will the JavaScript will be a different file when you push it to the Vercel, that is the service that runs the Next.js app. It's the most common service that you use to run a Next.js. Then they will see, okay, this is a client side and this is a server side. Let me put this in the lambdas and let me put it is in the CDN so the user can access. So basically everything is a client side, but you have small pieces of code that are server side.
Thank you. I guess we have a question for Colby now. So Colby, I'm sure you're constantly looking for tips and tricks and new findings to making a successful ecom UI. What are your go-to sites and references?
Oh, I wish I had a better answer, but I don't really have like a great answer for that. It used to be Dribbble, because I know like I mean, it still might be a great resource, but there was a lot of design inspiration for if you go there and search e-commerce or online store or something, and kind of be able to see things like what's trending, what's maybe something that catches your particular eye that will inspire you to create your own thing. I think generally speaking, I really follow different random people on Twitter to kind of see what other people are doing. I try to keep an eye on what some of the big players are, because maybe not every website is the most beautiful e-commerce site, but there's a lot of resources put into some of the decisions that places like Amazon and Walmart.com, those kind of websites. There's a lot of decisions put into that, so you can kind of see what they've decided to do and attribute some of those UX decisions to your own UI.
Thank you for sharing. I think we have time for one more question. So, because we'll have next speaker soon. Okay, so this is more of a React question. Do you design a component hierarchy before getting into a project?
Do you want to answer, Colby?
Sure. I don't typically do that unless I have a very focused and like intentional thing that I'm doing. For instance, like the one example of me doing that was a project where I was creating a map system. And what I mean, like Google Maps kind of mapping. And I had to have some really particularly designed components to kind of all fit together like a puzzle to work properly. In that instance, I tried to design the kind of hierarchy of those things, but typically I just kind of work as I'm going through. So that way I'm not over engineering or doing too much work on the upfront work where maybe it wouldn't even be worth the time that I was spending on that, and just kind of doing things as I need it.
Oh, Gabriel, do you have anything to add to that?
It's exactly the same. I don't think that I like to over engineer stuff, and I think I just go as I need. So basically that's it.
Thank you both so much for sharing your valuable experience with us, with our all attendees. And like I saw you active in the chat, so feel free to join and answer like the question we missed, because we should move on to our next sessions. Thank you both so much for joining our conference. And it's not the first time, so I hope we see you both in the future.
Okay.
Yeah, enjoy the rest of the conference.
Yeah, thank you for the opportunity. Thank you, Colby. Thank you, Nick. Thank you, guys. Bye.
Yeah, thank you all so much. Yeah.
Yeah, take care. Bye. Oop. All right. So yeah, before we go with next talk from Josh, I'm just gonna give quick announcement that like Anna wanted to say, but that will be me. So we are actually will be running React Global Summit 2022 next year. Yeah, React Global Summit 2022. It's gonna be in May, around 10, 11th May of 2022. And you actually can register to this event right now. So the link is gonna be in the chat. Where is link? Where is link? So I know someone will put it right here, or I will do that myself. But yeah, without further ado, I will just gonna give a word to Pavel for the introduction, and we'll start the next talk. Stay tuned.
And now we want to say thank you to our amazing sponsors, BetterMe. BetterMe is a leading behavioral healthcare app publisher with over 100 million downloads available in 190 countries. With workouts, nutrition tracking, and mental health coaching, BetterMe is an all-in-one solution for a fit body and mind. BetterMe has been on the most downloaded health and fitness apps list since 2018. Join today.
And without further ado, Josh, how you doing?
Hey, I'm good. How's it going, Nick?
Fine, yeah. So I'm impromptu moderating, if you can say that. And Josh is going to be the next moderator right after his talk.
I'm very excited about it.
We are excited too. So what are you going to talk about today?
Well, for starters, I'm going to express enthusiasm for Next.js. That was a great talk about a great framework. But I'm going to be talking about 7 common hooks mistakes. I've been working with a lot of people who are new to React hooks, both new developers and people who've been using React for a while. And I've noticed a lot of common mishaps and anti-patterns that tend to spring up before people get used to them. So I'd like to share those today.
Okay, the stage is yours.
Awesome. Quick coffee sip. Hello, everyone. Thanks for coming to my talk. I am Josh Goldberg. A little bit about me first. I'm a front-end developer at Codecademy, which is a great site for learning how to code. I work on a web platform team, which means that I touch a lot of stuff across our shared front-end apps, tooling like React and TypeScript and Webpack. I'm very much into static analysis, such as TypeScript on the side. I'm writing an O'Reilly book on it. Hit me up on Twitter if you're interested. You can find me on Twitter at joshuakgoldberg.com, and my website is joshuakgoldberg.com. Sorry, the Twitter isn't at. Anyway, for the talk today, everything that I'm going to reference is on this repository, 7 Common Hooks Mistakes. It and the slides that you are currently looking at are linked on my website, and they link to each other. So you don't have to set this up locally if you don't want. You can just follow along. But if you like a little more hands-on approach, this can work. So I'll just give everyone a quick second to clone this and set it up. If you want, instructions are in the README. All right, that was a quick second. So to start off, let's go over the agenda. We're going to talk about hooks themselves. What are they? A few common mishaps such as overusing use states, missing dependencies or deps, not using the built-in or pre-configured lint rules, not using use callback, overusing use callback, and using outdated state. These are the 7 main mishaps, shenanigans that I have seen people commonly use with hooks. To start, I don't want to say that not knowing hooks is a mistake. That's a little too harsh on people who might not have had the time, but it's a catchy talk title, so we're going with it. Hooks are great. To recap, if you haven't seen them or played with them yet, hooks are functions whose names typically start with use, you can call them for state and or side effects inside your React function components, not class components. To start, within hooks, use state is a very common one. It's my personal favorite hook, I think. It sets up a piece of state akin to a React class component's this.state. Ooh, I'll post a link in the chat. Use states lets you create a piece of states that starts off with an optional initial value and returns two values, your current state and a function that you can use to update it. There's a great new set of React documentation on beta.react.js.org that has some reference for use state. And I actually have the demo starting locally. I npmi'd and then npm started it. Let's zoom in a couple of hot moments. And not using hooks shows off an example of a hook. So just quickly looking at the source code for this button that when you press it, increments a number up to a maximum. Oops. Chrome is hijacking my focus. Using hooks.js, all the demos are in source/demos. Here we go. I apologize. My computer is freezing during this talk. Very annoying. There we go. Cursor of the demo. All right. So here's an example of a component with a hook. You can create this use state here, which returns an array or a tuple of size 2. The first thing returned by the array is the initial value. So that's count here, which starts off at 0. And then a set count function, which you can name whatever we want. I've named set count. That updates the counts. Here we have two examples of hook logic. One is that whenever someone clicks the button, we call this handle click function, which increments the count by 1. Set count, count plus 1. Oh, I would love to win the laptop. And we also have a separate use effect that I will go into soon and talk about some mistakes with. Anyway, going back to the demo, we can see that whenever we click the button, there is a maximum count set to 7. Hooks are great. Use effect is another hook, I think my second favorite. It lets you run a function that causes some kind of side effect, perhaps updating state, perhaps console logging. Here we see the use effect now explaining it from the example, where whenever count or maximum change, we set count to the smaller of the two, count or maximum. The key thing with use effect is that it takes in a deps or dependencies array as the second argument. That's a list of things that whenever they change, the function should be rerun. So if you see in our code here, we rerun this function whenever count or maximum changes. And you might be asking, why would maximum change? Well, it's a prop, so the component might be re-rendered with a different maximum. Yay, hooks! This stuff is great. Back in the day, you used to have class components with functions like component.mount and component.update, but personally, I find this a lot easier to read through. On to our first actual mistake, overusing use state. State is meant for an actual piece of state, a source of truth, not something that you might compute from state or some other logic. Don't use state for things that could be computed, i.e. from your state. Let's take a look on the left. We have a component that does what we were roughly doing in the previous example. We are using an effect to set counts and maximums, minimum to a new piece of state, this capped piece of state, and then rendering capped. But that means we have two pieces of state on the left. We have the original raw count, and we have this computed piece of state. But the component only ever renders one of them. So there's really no need to have two pieces of state here. We can just go with the one. On the right, we have only one piece of state, which is directly set to the smaller of count plus 1 and maximum. It's tempting, especially when you're new to state and still figuring things out, to try to make a piece of state for every possible area in your pipeline, from raw state value to some computed thing. But if you don't need it, if you don't need those duplicate pieces of state, it's just extra code. Looking back at our source, predictably, the demo here under demos is called demos/overusing use state. And I've set up for you the two components from the slides. We have an overused component, which uses an effect, and a fixed component, which doesn't. Looking back at overusing use state, you can see that these components pretty much work the same. There doesn't seem to be too much of a difference here. They both cap the count to 7 if we refresh. And then try them again, they still work. But there is one key flaw. Also, thank you, folks in the chat. Please do ask questions. We can get to them later or now if you have them. The one key difference here that might eventually bite you is that useEffect is an asynchronous call. It doesn't immediately run the effect whenever the two things change. The React hooks runtime, whatever React does on the inside, is not guaranteed to run anything immediately. It's not guaranteed that counts and caps are going to be factored in immediately. It's not guaranteed that this capped piece of state is always going to be kept in sync with count. So in theory, if your React app is running slow, if you have a lot of computations, React might decide to wait a second, which means that your capped piece of state might fall out of sync, and it might say 8 times out of maximum 7 instead of 7 out of 7. And that's a bug. We don't like that. Now, to be fair, this example is very small and self-contained, so you're not likely to see it. But in theory, that could happen with larger examples. So make sure, if you don't need an extra piece of state, don't use a use effect to set it up. Just modify the original state directly. Moving on. Missing depths. You're forgetting something. Spoiler, the next section will talk about how to find these automatically. But let's look at these giant amounts of code on the slide, which I'm sure you've all immediately understood after 2 seconds of looking at. Just kidding. It's a lot of code. That's the point. It can be hard when you're using these new APIs to get them right exactly the first time. If you really want to squint your eyes and read through all these, you can find that there is a single difference. It's around these use effect calls. The one on the left does not pass in count in the array of depths or dependencies, and the one on the right does. What's the difference? Well, dependencies or depths is a list of things that when any of them change, indicate that the function should be rerun. So if you're missing a dep, the function won't be rerun when that dep changes. React will have no way of knowing you're supposed to. Which means on the left, we won't console log that text has count. If count changes, only if text changes. Which I would think, at least in the context of this bug, is a bug. I tried to show my dev tools. There we go. Yeah, I could really use that free laptop. This is killing me over here. All right. Here we go. Ignore my warnings. I might fix them later. I'm attempting to zoom in. There we go. If we update text ASDF, on both of them it works, ASDF. But on the first one, I'm updating count and we don't log. Now we do. We skipped from 0 to 6 because the component doesn't know to rerun the console log effect when count changes, whereas the second component and therefore knows how to rerun when count changes. Bug. You don't want to have bugs. So on the difference point here, if you're missing something in depths, you're not going to rerun the use effect whenever you need. Don't forget, effect hooks need all dependencies of the effect. And as I mentioned, you can use lint rules or static analysis, things that look at your code and complain about it automatically to you. They're there to help. There is a fantastic set of rules called the rules of hooks that have been partially codified in a set of ESLint plugin rules. ESLint is the standard JavaScript linter, which is the tool that complains about your code automatically. And React Hooks is a plugin available for it that adds in React hook rules. And they can enforce your code. For those of you who were running the demo locally, you might have seen at the start that there's some warnings that, oh my God, something is missing. Oh no. It's great. I'm going to breeze by this slide because most pre-built React apps, such as Create React App, have it already, but this is the very quick installation set you need if you're trying to set it up from scratch. Pardon me. Let's look at this file. Use effects. Missing depths.js. Wait for the file to load. And I have my VS Code configured. Someone asked in the chat, don't the rules of linter for hooks flag missing dependencies? Yes, they do. I have my linter configured in VS Code with the ESLint extension to give me the complaint with a little yellow squiggly. I love the yellow squigglies. And the wonderful thing about a lot of ESLint rules, such as the React hooks exhaustive depths rule, is that they come with two awesome pieces of help for you. One is that they have a link to the docs page. So this just opened in the wrong window, of course, but there is there is a React hooks exhaustive depths lint rule. Pardon my typo. So pardon my lovely browser background. So the lint rule can link you to the docs for why you're supposed to do things the way you're supposed to. And there's some mistakes that I haven't gone into here, such as when and how you're allowed to call hooks. This demo is much more snazzy when my computer's running quickly. And another great thing, my favorite part of them, is that they have quick fixes, which have a shortcut on both Mac and Windows. And I'm just using with the mouse to be explicit. Update dependencies array. Voila! My ESLint rule has fixed my code for me, and I no longer have an angry yellow squiggly. Heck yes. I'm going to do that again and again in slow-mo. This time I'll click the light bulb, update the dependencies array. Now I'll note this demo app that I've set up uses Create React App, or CRA. And its package JSON uses the pre-built lint rules for Create React App, which means it comes with these rules of hooks for me. So if you ever see something like ESLint config extends React App, voila, that's all you need. However, just going back to this slide quickly, again, this is linked on my website. You can install it with either of these two commands on the left, and then add it to your ESLint RC on the right. You can also look up ESLint plugin React hooks. They have a great README. Awesome. Another mistake, unrelated to use effect, is use callback, not using it. Fun fact in JavaScript, functions are newly created every time you create them. In other words, you might need to memoize your functions. What does that mean? Why do you need to do that? A hook that called use callback does exist in React that takes in a function and a list of dependencies or depths, and then it returns a function that stays the same until a dependency changes. And let's look at a brief piece of code. I don't want to save. Use callback. Boop, boop, boop. Come on, VS Code. There we go. Here we go. Line 16 through 18, const reset. Every time this skipped function runs, we're going to create a new reset function. That's what we're telling JavaScript. We're saying, make me a new const variable named reset, and the value of that variable is going to be set to this function, which has a single line that calls some other function named setText. That means that every time this skipped component re-renders, which is every time the skipped function runs, we're going to pass a new reset function down to the child. Now, most of the time, that's not an issue. You saw in previous examples that we're always passing in a new onClick handler to buttons. Most of the time, the re-render cost is very low. But once in a while, you get a component that actually cares about what's called referential equality or strict equality, that if it receives a new function as a prop, say this reset prop, then it'll rerun some other logic. This child component is an example of that, where this use effect runs every time the reset function changes. Just collapsing my solution here. So because every time this skipped component creates a new reset and passes it to the child, that use effect is going to, within the child, run the reset function, which seems to me like a bug. If we look at the demo code, not using use callback, and I try to type in, I can't. You can't even see that on my keyboard, I am slamming my fingers onto the keys. Whereas the second fixed version fixes it. And just to recap, the reason why this is buggy is because we are creating a new reset function and passing it to the child every time we render. And then the child is calling that reset function every time it's meant to re-render. A fixed version would use callback to create a new function only when something in the list of deps changes. And in this case, we never want to create a new function because set text is known to never change. So we have an empty deps array, which is why the fixed version doesn't cause child to constantly re-render. Yay, hooks. This is confusing. This is one of the downsides of using hooks, that you get into these weird, not easily understood at first shenanigans with equality checks. And that's why a lot of people use callback a lot. But there is a danger with use callback in that you don't need it most of the time. It's a nice idea and sometimes it's useful, but if you use it too much, if you're constantly using it, it gets a little annoying. Personally, I think that people overuse use callback far more often than they underuse it, just from my observation of the people who happen to be around me. My general rule of thumb is, unless I think something is probably going to be useful, or even more strictly, unless I know it matters, I'm not going to use callback. Because it's extra code, it's extra work. I'm telling React something more complex, and oftentimes we don't need to. It's a waste of time. Let's look at this code. Much simpler. On the left, we have an onChange that uses use callback, and on the right, we have the same thing without the use callback. This is an unnecessary use callback. We're directly passing onChange to the input. There is no functional difference between these two pieces of code, other than maybe a very slight performance change that, honestly, I would be shocked if a user could ever detect. And it's not even clear whether the performance impact is positive or negative in this change. Maybe it's good that we're not re-rendering the input, or maybe it's good on the right side that we're not using use callback and setting up a cache for this function. So time versus memory, who knows which one would be more important here. At this level of change, it's so minuscule, so unimportant that it really doesn't matter. So when you're using use callback, ask yourself, but why? One last piece of advice I'd like to give before we move into Q&A is using outdated state. Remember that hooks are not magic. There's no such thing as magic in computing or React. React works with regular JavaScript. So whenever you're, say, calling a hook and getting some result back, it's just variables. It might be confusing and hard for you to use, but it's still just on the inside JavaScript variables. Oh, pardon me. My slide didn't update. Anyway, let's look at the last demo of the day. Here we go. Using outdated state. This component here has a bug. Lines 17 and 18. And I will, just in case you want to sleuth out yourself, wait for a little bit to drink more coffee and let you try to spot the bug. Do you see it? Let's look at the demo. Sorry if you've already seen it and I'm pandering to you. This component logs an outdated state member to the console. Click, count is now 0. That is incorrect. Count is actually 1. Now it's 2, but it's still logging the old value. There is a bug. The real issue, I'm going to use the dev tools to show the console at the same time. Outdated state.js. Look at that source map working. The real bug is that this increments count by calling set count plus 1 and then logs count. But that's a bug. That's not right. Count is just a variable. It's not some magic value that React hooks into your browser or runtime environment to change. It's just a variable. When you call set count, similar to passing a function to use effect, you're not telling React this variable is updated now immediately as soon as possible. You're telling React, hey, when you get around to it, could you change this variable, please? It's async, as Lucas says in the chat. Asynchronous. So this variable on line 18 points to the old value of count. Whereas a fixed version would do something like setting the new variable to an updated, setting the new value to an updated variable. I haven't clicked. Now works when we get the new value to console.log. Yay. Cool. So let's recap. What have we learned today? We've seen that not knowing hooks is unfortunate because they're awesome and they're great new docs for them. We've seen a few common mistakes such as overusing use states and missing deps that have to do with effects. We've seen that not using the lint rules is a real pain in the butt and it's a good idea to use the lint rules. We've seen that not using use callback can cause you some issues with referential equality. And overusing use callback, which I have found to be a much more common mistake, kind of tends to be a pain in the butt. And lastly, we've reinforced that hooks are not magic. It's just variables on the inside. And a lot of them are async, not sync updates. So I have links in the slide for this. I highly recommend reading the React docs. And these are Google expressions. If you type them into Google, you should get the results you want. The new React docs are coming and very exciting, and I link them earlier in the slide. Thanks, everyone. This has been a blast. Again, I'm on Twitter. Use Joshua K. Goldberg as the handle, or visit joshuakgoldberg.com. Thanks.
Yeah, and thanks to you. Let's go on to our Q&A session, right?
Let's do it.
Yeah, we have lots of questions here, so let me just scroll through some of them and let me pick one. There's a comment / question. This exhaustive depth rule can become a pain when we explicitly don't want to add a variable to run the use effect. We have to bypass this ES-lint rule each time. Any thoughts?
I do have thoughts. For starters, the vast majority, but not all, of the times I have wanted to bypass the rule, I was wrong. And I'm not saying you're wrong. I'm not trying to be insulting here, but I'm saying that the vast majority of the time, I have found that even though I first thought I wanted to bypass the rule, what I was actually doing was going against the way hooks are supposed to work. So although I will give you a more useful answer, I do want to caution everyone reading or watching this that most of the time you shouldn't be doing this. Which is why bypassing the ESLint rule is kind of intentionally a little bit of a pain. Would you mind if I shared screen back onto the...
Sure, I'm getting it back. Sure. Let me just...
Thanks. I love code snippets. So let's say that you're looking at missing deps. I didn't show this because I didn't want to encourage bad behavior. No. Again, you're right that sometimes you have to do this. But there is a quick fix where you can disable it for the line. And yes, this is what the question is about. This is kind of a pain. But again, it's good that this is a pain. This is something you should very rarely do. And if you really want, you can quick fix to add the comment. Oops. That, there we go, disables the rule for the entire file. But lastly, again, highly recommend not doing this.
All right. So thanks for sharing your experience. It was a good answer. Thank you. So there's also a small question here. Can we use previous state?
Ooh, yes. One of the big draws of hooks, one of the things that I really like them for, is that they're very composable, unlike class components. which means you can create a hook and export it from your npm package or file or local whatever as a function, and other components can take in that hook. There's a really fantastic set of hooks called React-use. React-use is React-USE, which provides a whole bunch of common helpers that I personally have ended up using in basically every hooks project, more than a dozen files. And one of them is a really great previous states hook, which gives you the previous state from a piece of state. So that every time the state updates, this hook will give you the previous value of it, which I find to be really useful. But yes, I would highly recommend, if you need some piece of React logic, whether it's previous state or listening to window scroll or something, look up React hook and then whatever that is on Google or DuckDuckGo, and you'll get some useful hooks for it.
Thank you. Yeah, there's so many information about React hooks. I also Googled it a couple of times for some content production reasons. Yep. There is the question on our platform with lots of code. So I'm just gonna show it to you instead of just reading. So yeah, here's the question.
I'm changing my video because it seems to be crashing. If there are multiple things going in states, that was great. Now you see my very haphazard towel background because my black shower curtain hasn't arrived.
Yeah, what do you think about the question?
Yeah. If there are multiple things we're storing in state, is it better to declare them separately or create a single state? This is, you've triggered my TypeScript response. This is such a good question. And the thing you have to ask yourself, I believe here, is whether those two things are related or unrelated. If they are able to be updated separately, let's say that it's person name and then some age, and they're both separate pieces of state, like the count and text we saw in my examples, then yeah, totally reasonable to store them separately. But if they would only ever be updated at the same time, if it's, say, a person object that you're receiving from somewhere and it would only ever update both, then I would say put them in the same thing. For the TypeScript users out there, shout out. If you would store that as a discriminated union or as an object literal type or as an interface, then I would say put it as a single piece in state. If it's two different types that don't have to do with each other, then you can keep them separate. General rule of thumb.
Thank you. So we have lots of questions. So let's go to the next one. Can you pass a func as deep as use effect? If yes, is it a good practice?
Yes, you can. In fact, my last or second to last, the not using use callback one does show it as passing a func in there. It's not, I would say, good or bad practice. I have rarely found a need to pass functions into use effects, but it does happen. Like if you're passing a logger function and you want to call that logger function whenever something changes, it's totally reasonable. So yes and yes.
Thank you. Okay, next question is how to manage multiple separate set state calls.
One of the nice things about React making all this stuff asynchronous on the inside is that they have the ability, and I believe have recently talked about starting batching them in the latest React versions. I forget where they landed on that. But yeah, if you want to update multiple pieces of states, call set state 2 or 3 or more times in a row, totally fine. This calls back to the earlier question of if you're constantly updating two pieces of state at the same time and you're only ever updating them together, you might consider storing them as an object in states, a single piece. But yeah, it's totally fine to call set state multiple times. I'm curious if I'm misunderstanding the question.
Well, we'll see. We'll see on the reaction. So there's I don't know if it's similar, but the question is, how many states it's too much? When is good practice to switch to use reducer, for example?
Ooh, in order to answer that question, we'd have to answer what is use reducer. For many years, Redux was the most popular state container for new JavaScript React apps. It's a container that stores your entire application state as a huge object and then allows you to define actions that could be called and changes to the object as a result. For example, you might have a name count and then the action would be increment, and the results, the reducer function would be that the count increments by 1. React now has a built-in, I believe, use reducer hook that does the same thing. It allows you to update your state in that, it's called functional manner. I can't give you advice on whether you want to move to use reducer specifically, but just when is a good practice to switch to more complex or integrated pieces of state management? I would say when it gets hard to figure out how your state works. Most of the time, I start off with just using React hooks now for state. And then once I get past maybe 10 or 15 stateful components, if I'm having a hard time keeping track of the state, then I'll add in something like Redux or MobX or whatnot. But really, it's up to you per application, and I find it's a good thing to call as a gut check of like whether it feels wrong, too complex.
Thank you. Let's move on to questions from our platform. We got some pretty long ones. So, for example, this one. If I call a fetch function from custom hook on use effect, it tells me to add it to the dependency array, but adding the function triggers an infinite loop. Is there a common approach to solve this?
Use callback. If your fetch function is being recreated every time you declare it and then pass it to the use effect, you probably want to use callback. I would love to have you tweet or email or whatnot me a more integrated example if you want me to really take a look. But my gut instinct is either that you should use callback or find one of those really nice pre-made hooks from React to use or similar that would allow you to set something up like a use fetch or some such.
And to continue from that, is it okay to use callback inside a custom hook?
Yes. Though I would love to know more context. It's very, when I say composable about hooks, it's what I mean is it's very common to use hooks within hooks. And you don't want to get too complex with them. You don't want to have a hook calling a hook 20 times. That just anything that has 20 dependencies is complicated. But yeah, it's totally reasonable that you might define a hook that itself defines some callbacks with use callback and then returns them. That's a pretty good time when you'd want to use callback in case your custom hook gets reused a bunch.
Okay, let's move on. So two-part question. Hey, Josh, what's your opinion on storing a component state inside, let's say, Redux state? Example, input component, or would you store less, say, login email inside state of login component, or would you propagate the types in value into whole app state? Thanks.
I'm amused that Redux is getting brought up so much. I'll answer this agnostic to whether you're using Redux or context or whatever else, recoil for your state. I'd say most applications that use an external state container tend to have two areas of state. There's the area of state that's local to components, things like use state. And then there's the area of state that's separated from components, stored in, say, Redux. And in general, what I try to do is put only the pieces of state that really should be separate from components in that separate state. So diving into your example, let's say that you have a login email inside your login component. Unless your entire application or things outside of that component really need to know about the user's current login email, it's probably not necessary to put it into Redux. But if you want to, say, store the currently logged in user, because that's used across your application, once the login component is successful, then I think that makes a little more sense. And please let me know if that explanation is nonsense.
Well, like I said, also like feel free to, or I even invite you to join the chat after like the platform. You will have 10 minutes of break before you start. So if you want, I invite you to join the chat and ask him some more questions, because I don't think we don't have enough time to answer all of them. We still need some time of break. But let's go with this one. Did I ask this? In React, like, how can I re-render the component if we're changing the object values? It does not re-render the components besides cloning the object. What is the solution for that? Hope that.
I'm sorry, I don't understand the question.
Oh, sorry for I hope person will elaborate on it in the chat further. I found myself sometimes using the state like you show in the last example, but did not encounter bugs. In my case, I should still do it the way you show in fixed version just for good practice, right?
Yeah, I'd say so. Every application has bugs in it, and there's only so much effort you can put into fixing bugs. So if you want to make the perfect piece of code, then yes, do it the way I did, in theory, hopefully. If you want to get a pretty good application, probably do it the way I did. But if you're in a total rush and it doesn't seem to be buggy, it's probably fine to just let it work however it works. But in general, yes.
Okay, let's just go with the last question. But doesn't the rules of the lender 4 of hooks flag missing dependencies? Well, if also that's good question to end with.
Yes. I will note sometimes people don't use the rules. Sometimes they ignore them. So definitely recommend using the rules and treating them as errors. Fix them if you see them.
Okay, thank you so much. So I guess we should go for a short break and also have very important task to do right now. And you will be moderating like I brought up before. So I'll see you on stage very, very soon. I'll just be leaving the stage to you. So thank you very much for coming, and talk to you soon.
Bye. Thanks for having me.
Bye. So yeah, very important task I have for now is our MacBook giveaway that we had. So we were collecting likes and comments on our Instagram posts that Anna prepared for you. So let's just go straight to it then. It's like pretty simple, but very, very important task I have here. So let me just show very quickly. This is the post that we were showing. Let me do this. So yeah, here's the post we got. Let me just refresh it in case. Yeah, so here's the post we were talking about. We're sending it to the chat. And I just go straight to the giveaway. I'm just gonna share another tab with an application we decided to use, and just let's pick a winner. So yeah, we are logged in as React Follows right here. And just gonna go to Instagram, just pick this post that I just showed you. So one participant, one ID number, it will create like a random array, just one winner. I'm gonna click in launch and let it load. I think I forgot what's the most important thing. Yeah, so let me do it again. Yep, let me just refresh the whole thing because that's what's wrong with me. So yeah, once again, this is the app. I'm clicking Instagram, I'm clicking these posts that I just showed you. And yeah, we're collecting likes and subscription. One participant, one ID number. We have only one winners for this. And let's launch. We have so many comments, so many likes here. Let it process for a bit. Well, takes longer than I expected. Okay, and I tested this a couple times, so it's like assigns every attendee a random number each time a new one. So I'm just gonna write down one number, like it's completely random, but because today is the 3rd of November, I just write the number 3 right here, and I'm gonna pick a winner. So yeah, who's that? Let's just comment, yay, and like, and here's it, and subscription. Subscription is also verified. So I guess congrats. We have a winner with the Instagram tag Bombik, and we'll contact you, I guess, after the conference ends. So congratulations to to the winner, and we'll go for a short break now. Yeah, like I said, we'll contact you after the conference finishes. And I guess if it was or wasn't mentioned before, so the giveaway is for MacBook Pro 2020 or amount of money that covers the cost of this MacBook. All right, so I'm gonna leave it for a 5-minute break, and then we'll start with Josh.
Hi everybody, let me introduce our sponsor Andela. Andela has been placing software engineers with global tech companies since 2014. Their engineers are solving the most challenging problems in software today and working with the world's leading companies like Coursera, GitHub, Goldman Sachs to build products that are used by millions of people. Their engineers have access to mentorship and support to ensure they keep growing professionally. 89% of developers placed an engagement report and improved quality of life. Andela connects brilliance to a world of opportunities. Visit the website at andela.com and join today.
All right, getting back. Josh, I see you were reconnecting a couple times. Are you ready?
I think we're ready to go.
Yeah, I'll leave you to it. So we have a speaker ready here. So yeah, good luck.
Oh, so sorry, folks. I'm having some tech issues. I'll be right back. Give me 20 seconds.
Okay, yeah, I wasn't expecting that, but yeah, that happens sometimes. I think I'm just gonna read. So the next speakers, we have two speakers presenting the next topic. It's Anisha Swain and Ramakrishna Patnaik. I hope that pronounced it correctly. And they're gonna be presenting their talk about micro frontends in a nutshell. And they are here, right? Yeah, so I'll leave Josh to it. So Josh, just get back when you fix your issues. Don't worry about, oh yeah, is everything working out?
I believe so. Awesome.
Okay,
Hello
yeah,
again, everyone.
I'm just gonna add the speakers here, yeah.
Hey, you two, how's it going?
Hello, all good. How about you?
I'm great. I'm excited to hear your talk. You ready to present?
Yeah. Ramo is going to share the screen, so please go ahead, Ramo.
Awesome. Well, while that's happening, do you want to give us a quick summary of what you're going to be telling us about?
Sure. Today we are gonna talk about micro frontend. It's a front-end architecture that is being adopted for splitting up front-end work between front-end teams, like we do in microservices for backend. And we'll go in depth in the slides itself. And really excited to present.
Awesome. Well, I will hide myself. Take it away. Very excited to see you present.
Thank you.
Is my screen visible?
Yes, thank you, Ramo. Okay, can you make it full screen, Ramo?
Yep.
Great. Thank you so much. Hello everyone, I'm Anisha and I'm a former software engineer at Red Hat's Performance and Scale Engineering team, currently in between jobs. And this is my colleague Ramakrishna, who is also a software engineer at Red Hat with the MediaPipe team. And this is the first time Ramakrishna is presenting in a conference, so give him a huge shout out. Today, as I mentioned, the topic that we are going to present is micro frontend, and the name of our talk is micro frontend in a nutshell. So without any further ado, let's get into the talk. And before that, I would switch off my video to save some bandwidth. My internet provider goes crazy at night. All right. Okay. So as I mentioned, we are going to be talking about micro frontend, and we will know about what are micro frontend, what is the micro frontend architecture, how micro frontend, from where it got originated, and how it all started. Some advantages of micro frontend and the problems that it solves or that monolith couldn't. And we will also talk about some popular micro frontend frameworks that are currently being used. And at the end, Ramakrishna will walk us through model federation and with Webpack, which is a feature to achieve micro frontend. And we will also talk about React and model federation. Now, before getting into micro frontend itself, let's talk a bit about microservices. Microservices architecture or microservices are a specific method for designing software systems to structure a single application as a collection of services, loosely coupled services. And instead of a monolith architecture, each component of microservices has its own, essentially has its own CPU and own runtime environment. Next. Yeah, so from where micro frontend came to the picture, right? In 2011, 2011, microservices themselves premiered at an event for software architect, where the term was used to describe a style of architecture that many attendees were experimenting with at that time. And in 2016, ThoughtWorks added to the term micro frontend to the technology radar as a front-end architecture similar to microservices for front-end development. Uh, the term micro frontend itself first came up at the end of 2016, and it extends the concept of microservices to the front-end world. The current trend is to build this feature-rich and powerful browser application, or as we call them, SPA, single-page application, which sits on top of microservices architecture. And over time, the front-end layer, often developed by a separate team, grows and gets more difficult to maintain. And that's what we call a front-end monolith. And that's the problem that micro front-end resolves. Next. Yeah. The idea behind micro frontend is to think about a website or a web app as a composition of features which are owned by independent teams, and each team can have their own distinct area of business or mission that it primarily focuses on or cares for, and it basically an area where it specializes in. And the team can be cross-functional, and it develops its feature, like end-to-end feature, from a database to user interface. And this idea, however, is not new. Was something called self-contained system, which has lot in common with this concept, but micro frontend is more user-friendly and less bulky term to say. Next. Thank you. Okay, so long time ago, when websites were built, if you can see in the first part of the visualization, yes, this is the one. Like the shop team, right? Where the websites were built in a fashion that the front end, back end, and the database team were all tightly coupled. And it was difficult to make changes to any of these parts without affecting the other part. And in the middle part, which you can see, gradually the front end and the back end part were split and they were decoupled. And this is what most companies still do use today. And there are separate repo for each, essentially separate teams working on them. And any changes to code of front end doesn't affect back end. And now the next thing that came up is microservices, where the backend team will be split based on the business subdomain and functionality, and they will communicate back to the front end as a whole team with API, etc. Next. Now the next comes micro frontend, where the front end team is split up in so that they can work on features or business goals more independently. Basically, the same way backend microservices does without affecting the other parts. So this idea makes sure that the team are not blocked by each other, by any technologies that they are using. Next. We can define micro frontend in two ways. Basically, it's one is horizontal, and which allows multiple micro frontends per page, uh, and vertical, which allows one micro frontend per business domain. So if you can see in the horizontal split, the header and the footer of the page belongs to a particular team, team C, and then the product details belongs to another team, which is team A, and then the product carousel that belongs to another team, which is team B. So that is horizontal split. And then we have vertical split, where the whole separate pages belong to different team. Now, opting for horizontal design means that you will split a view into multiple parts, which may or may not be owned by the same team. And the challenge is to like ensure that these parts have pretty much similar look and feel, because it's essentially a part of same application. And we need to bear in mind that like we are kind of breaking the first principle, where we say that no, the model we have to separate micro frontends according to the business domain. uh, and opting for vertical splitting means like we will look at the same problem from a business domain rather than technical point of view. And we will assign each business domain, such as, like, for example, if there is an authentication UI, or then there is a catalog UI, like we will assign those to different teams. And this enables like each team to become domain experts. uh, so basically each like despite of how many views the domain is composed of, this still can operate with full autonomy. Next. So here is a screenshot of Netflix UI, which uses horizontal split. You can see the carousel element is being owned by is a different micro front end, and then the preview of the movies are a different micro front end. This is just an example to show how how micro front ends are implemented. Next. This is another site. I'm not sure essentially if Tesco uses micro front end or a vertical split, but just for an example, if we consider the landing page and then maybe the catalog page or groceries page, these can be handled by two different teams. So we can split it in uh, uh, as vertical split according to the business subdomain. Next. Talking about composing microfrontends, there are three ways to compose microfrontend architecture: client-side composition, edge-side composition, and server-side composition. We'll not go into very much detail. We'll just explain what those are. So, various different approaches have emerged to compose microfrontend. Uh, so basically, the first one is client-side composition, which is also called runtime integration. In this architecture pattern, an application loads multiple microfrontends directly from the CDN or from the origin itself, uh, uh, when it's not cached on the CDN level. And often and this way the application can dynamically append the DOM nodes or initialize JavaScript application, which is basically the entry file. It is also possible to use a combination of iframes to load different microfrontends, and this client-side composition works pretty well for both vertical and horizontal split. Now coming to edge-side composition, edge-side composition assembles the view at the CDN level, retrieving your micro frontend from origin and delivering the final result to the client. And many CDN providers allow us to use edge-side includes an XML-based markup languages, and this edge-side includes was introduced to support the possibility of scaling of web infrastructure. Uh, Now, coming to server side composition, which I believe is the most popular one right now, as per my research. With server side composition, micro frontends are composed inside a view cached at CDN level, and finally it's served to the client at runtime. And in the example in the diagram, uh, in the example in the diagram, the origin server composes the view, retrieves the micro frontends, and assembles the final page. Uh, so also, like, server side composition is mostly used when we want full control of the application. Next. So we can also split our application on based of routing. So each routes will essentially be a different project, and we can uh, use HTTP server routed to multiple apps, and it's easy to implement and have it can have like independent deployments. If you can see, for example, if in the application there are different routes like menu 1, menu 2, menu 3, and they can be of they can use different technologies as well, like React, Angular, and Vue, and we can split it. We can use different microfunctions according to the routes that are assigned to them. Next. Now coming to iframe are HTML documents that can be embedded inside another HTML document. By nature, iframe make it easy to build a page out of independent subpages. They also offer a good degree of isolation in terms of styling and global variable, uh, while not interfering with each other. I think Spotify uses iframe microfrontend for their application. Next. Okay, so talking about advantages, there are multiple advantages. We can be technology agnostic, as you saw in the last slide. Each team will be able to choose and upgrade their tech stack without having to coordinate with other team. Custom elements are a great way to hide details while providing a neutral interface to others. Multiple teams can work independently, like on their subsystems with separate responsibilities, and it will enhance the reusability of the components and across multiple web apps. And we can also isolate team code. We won't share a runtime even if all teams will be using same framework, and we can build independent apps that are self-contained and not rely on shared state or global variables. And this enhances the reusability, making it easier to test features. And as I mentioned, we can reuse the component across multiple web applications. Next. Then now other things are obviously independent deployments, and that makes independent updates and bug fixes. And as already mentioned, we can split the application by business subdomains and allow the teams to use any framework that they want to. Like they can consist of independent React or Vue application. Next. Now, talking about some micro front-end frameworks, Single SPA is a popular micro front-end framework with a great community support. It is used for bringing together multiple JavaScript micro front-ends together in a front-end application. And it also, I think, comes up with a CLI, and it helps in using multiple frameworks on the same page. It helps in having independent deployment, and uh, makes us it helps us writing code using a new framework without rewriting our existing app. And we can also lazy load our code for improved in load time. Another tool is Bit, which is setup tools that let us compose and manage frontend from independent components. And it includes a cloud platform to host and reuse components. And to know more, can visit to the official site, which is bit.dev. And then there is one app by American Express, which consists of a Node.js server that serves of a single page application built using React component. And now the most popular one, Model Federation, which comes with Webpack 5 as a feature. And Ramo will take from here to explain more about Model Federation using Webpack and with React. So Ramo, over to you.
Thanks, Anissa. Hello, everyone. So, Webpack is one of the most popular static module bundlers for JavaScript. And a module bundler is something that takes pieces of JavaScript code and their dependencies and bundles them into a single file for use in a browser. Some other popular module bundlers are Rollup, ESVille, etc. But Webpack is the most widely used one. And Webpack not only deals with static bundling, it also carries out a bunch of transformations and conversions so that browser can understand the code. Now, we as developers tend to use TypeScript and AS6, which is alien to browser that understands only JavaScript. Also, some features that aren't supported in some JavaScript features that aren't supported in older browsers. So Webpack takes care of all of that. And if you're interested to learn more about Webpack, you can check the official docs. You can go through what loaders are, plugins are. But the one feature that we are going to discuss at length here is the module federation. So module federation can be explained with a simple idea. So let's suppose your farm has three websites, website 1, website 2, and website 3, and each of them have separate footers. But what you eventually realize is that all these three footers have exactly the same code. They look the same. They only have some text variations and code is almost the same. So what you can do is you can probably make this footer a reusable component and reuse them. So what will be the approach way? So the traditional approach will be to extract the code from the footer and host it as a library in either npm or through cdn, and each of these websites can have that common footer as a dependency and can be installed in their node modules or whatever, and that can use it. But what module federation allows us to do is, like, you just need to have the footer in one website. You need to add some configurations to make it federated, and yeah, from that, in the runtime itself, the other websites can dynamically input that footer inside them. Yeah, so as you can see here, website 2 is hosting the federated footer. So, and a more appropriate word will be it is exposing the federated footer, and website 1 and website 3 are consuming it. So yeah, not only that, I mean, a website doesn't need to be a sole consumer or like or solely expose the federated components. It can do both the things at once. For example, here you see website 1 has a federated navbar and website 2 has a federated footer, but website 1 is also consuming the federated footer from website 2. So website 1 is both a host as well as a consumer. So yeah, coming to React and module federation. So as you know that module federation works with dynamic imports, while static imports create bindings into the local scope via pre-runtime linking process. Dynamic imports, or popularly known as lazy loading, fetches required modules as and when required. This should be accompanied with a fallback or a placeholder component like a spinner that should be displayed till the component loads. And one another useful component we have with React is suspense. So suspense was shipped with 16.6 that allows us to wait for something before it can be rendered and lets us use spinners as fallback. So this something can refer to both components and data. So like in case you are fetching data asynchronously from a server or something, the suspense component can make its child component wait till you get the data, and once the data is available, the child components get rendered. So keeping these React features in mind, we'll proceed to our short demo of using module federation with React. So let me share my code. Is my screen visible?
It is, yeah.
Okay, so this is a quick demo that we have. We have three different React apps and we'll be federating components between them. So we have an host UI, which is a sole consumer, and a CSS components and material components. So in material components, I have used the material UI as a dependency to create generic material components. Yeah, so let's start with it. So each of this React app has been bootstrapped using create React app. So though we won't be necessarily using them for serving them and all, but that was used just for simplicity. So for each of these projects, we have set up a separate file for Webpack configuration. So as you can see, we have a webpack.config.js in each of those React projects. We have a port. So this port is where this app is going to be hosted, like localhost 8082. And we are using this module federation plugin from Webpack. And yeah, this is how the module federation plugin looks like. We have this name is the name of this app and file name remoteentry.js. So it's basically the name of the output bundle. I'll show it in the browser in some time. And remotes is basically the endpoints from where we'll be consuming the federated components. So this host UI has two remotes. One is material components and another one is CSS components. And after that, we have this property called shared. So since material components uses this material UI as dependency, and also CSS components use React and React DOM, so we need to specify them here. So like if this current app doesn't have these dependencies, then Webpack will download them for us.
Hey, sorry to interrupt. Could you zoom in a couple times? Having font size
Okay.
issues. Thank you so much.
Is it better now?
Maybe just one. Oh, that's beautiful. Thank you.
Okay. Yeah. So this is the host. Now let's see a federated component. So we'll be going to CSS components. So this is federating a component called the footer. So we have the footer defined here, and it has been exported as a default export, not a named export. So yep, this also has its own Webpack configuration. This exposes is the part that where we need to specify which components are to be federated. So here we are federating the component footer, and we need to pass the path of the file. So here it's src/footer. So yeah, using this, like when we are going to run it, we can access the footer from localhost 8084 slash entry.js. Now let's see how the host is consuming these federated components. Yeah, we have app.js here. See, this is where we're doing the dynamic imports. And we are using suspense to like render them when they're available. So let's run some code. So the three terminals that you are able to see is basically I have like before this talk, I have just opened this repository and changed directly to the three different React apps. Let me start. Yeah, and one more thing, Yarn federated is not a default behavior. So basically I wanted to use Webpack to serve these apps. So what I've done is I've added an additional script, which is called federated, which translates to Yarn Webpack serve. Now let's go to the browser. So where we have this, so we need to see the host UI. Yeah, so this is the host UI. We have it in localhost 8082, and we're getting this navbar and this footer as a federated component. And if we check the network here, then yeah, we should be able to see remote entry.js, the output bundle from material component and CSS component projects, 8083/remote entry. And similarly, this should be 8084 remote entry.js. So yeah, that's basically how it works. And one more thing I would like to show you is the example where an app could federate components as well as consume the federated components. So I've done this in this app. So yeah, if you see its Webpack configuration, it has both exposes and remotes. So yeah, it's as simple as that. So yeah, I think this is the end of the demo. We have hosted this repository in GitHub. You can always refer to it if you like. Let me get back to the slide. Is my screen visible?
You're good to go.
Yeah, so now we'll discuss the disadvantages and challenges faced during working with micro frontends. So as you have probably gotten the idea, micro frontend architecture approach has potential to make the system very much complicated. Since micro frontends can differ a lot from each other with different frameworks and all, it can become very difficult to monitor and debug the individual component micro frontend. And using multiple frameworks come with its own set of problems, like using React, Vue, and Angular together will result into having a very large bundle size. And another difficulty will be to maintain the consistency in UX. So like suppose in React you are using a particular framework for components, you need to have something similar for Angular with the exact same look and all, and you also need to maintain it. So that can get really time consuming. And yep, and also we have the shared dependencies between the individual components, which can make testing and CI/CD really difficult, and also add to the complexity of the overall system. Yeah, so that's basically the end of our presentation. These are some of the references that we found really useful, and you can always refer to these if you want. So yeah, that's it, I guess.
Well, super. Thank you so much. Let's dive right into the Q&A because we have a lot of great questions from the chat. This was answered by someone else in the chat, but I'd love to hear your perspective on this. What kind of application would be needed to apply this micro front-end methodology?
So yeah, that's a very good question, because first we need to determine if the system really needs the micro frontends architecture. And basically it is needed when we have multiple frontends with multiple front-end teams, and then they can be all developed independently with proper isolation. So yep, for use cases like that, micro frontends are great.
Super. And if you want to share face, you could if you wanted to. Another question that was partially answered in the chat: how do you handle cookies in micro front-end projects?
Yeah, so actually I have not really stepped in. I mean, I have not really needed using cookies in micro frontend projects. So yeah, that's a good question. I'll have a look at it.
Super. Yeah, in my experience, the browser, as Alexandro mentioned, does tend to handle them quite nicely. Let's see here. If you have a non-React application shell, how could you import a micro frontend in the application shell?
Yeah, I'm not very much clear about this non-React application cell.
To be honest, me neither. So let's skip it. If anyone wants
Okay.
to clarify in the chat, they are welcome to. How something a little more concrete? How would you share something between different micro frontends, such as like a JSON web token, perhaps other auth tokens?
Yeah, so that basically varies from implementation to implementation. For example, in our current demo with module federation, since they are since we are using the concept of dynamic imports and suspense, it will be really easy to share stuffs just like we do it in any normal React app.
Super. And you might have just answered these two similar questions, but I'll ask just in case. How are we going to implement Redux, or I'm guessing general state containers outside in micro frontends? And is it possible to share states between federated components? Do you have any tips and tricks for us?
Yeah, so that's actually a very gray area because it can be really difficult to share states, and like we don't want to make those isolated micro frontends very much coupled in between them, because if we do that, we'll just end up with another a distributed monolith, and we'll just lose all the advantages that micro frontends have to offer. So yep, we should avoid that, and if we need it, like we can always go to the pub sub architecture, and yeah, just the minimal stuffs.
Do love a good pub sub. We've got a two-part question from the chat. I'll narrate the whole thing. What is part one, the composer of micro frontends? There was a slide showing each micro frontend may be in a different tech, like React, Angular, Vue. And more specifically, what orchestrates it? What's on the top level of the page? Is it static HTML, or is there a common solution?
Yeah, so let me just tell you how the single SPA works. So what we have there is like we can have those apps from different frameworks hosted in different ports, and we have an embedded JavaScript file. There we can just specify the route, the port and the route, and we can get things accordingly. So yeah, it basically varies from implementation to implementation.
That makes it fun. Last couple of questions here, 2 to 3. What problem does having visual microservices with different design frameworks solve?
So I'm not really a very much backend guy, so I don't have the answer to this.
No problem. We can skip. Just so a curiosity question on stability here. If the website that exposes, say, the footer is down, then do all the other websites have no footer? What happens there?
Yeah, so it's a good question. Yep, that will be the case. If that website is down, we'll be basically showing the fallback component. Yep, that can be an issue.
It's nice that only the footer is down then instead of the entire app.
Yeah.
Well, thank you so much. We have a bajillion more questions, and unfortunately not enough time to go over them. But at this point in time, we'll have to go to a quick announcement before our next talk. But thank you, both of you. I hear your partner in crime has a connection issue. So just to you, Ramakrishna, thank you, and congrats on your first talk. That was great.
Okay, thanks a lot, Josh. Thanks, everyone. Thanks for being a great audience. Thanks for the questions. See you. Bye.
Super.
Hi, it's time for short announcement. This time, I'll tell you more about MediaGems.com. This is an educational platform. You can learn how media works in their web apps by different use cases, different texts. There are code sandbox tutorials like how to create lazy loading videos in React, how to build e-commerce app with React, etc. Please share your feedback here via this form.
Well, alrighty. Our next speaker is an excellent developer named Silvana. And there's Silvana. Hello, how's it going?
Hi, Josh. It's going well. About to do my first conference talk, so yeah, see how it goes.
Well, I'm sure it'll be excellent. Silvana, the title of your talk is The Beauty of Design Systems. Do you want to give us a brief heads up on what that is before you dive in?
Yeah, sure. So I will give a definition during the talk, but essentially a design system is a way for designers and developers to collaborate more effectively. So I'll be talking about why it's not only useful from a design perspective, but to you as a React developer.
Well, that sounds wonderful. I'll let you take it away. Have fun.
Cool, thanks. Yeah, so hi everyone. As Josh said, my name is Silvana, and I will be talking to you all about the beauty of design systems. So a little bit about me. I'm a former teacher that decided to do a coding bootcamp. I am now working as a software engineer at Codecademy, where Josh also works. We primarily use React, Redux, and TypeScript for our front end. And some of the projects that I've been involved with have helped our learners to set goals for their learning journey and also to collaborate with one another. So a quick run through of what we'll be talking about today. First, I'll talk about what a design system is. Then I'll talk about why a design system might be useful to you as a React developer. Then we'll walk through how you can actually use a design system in your applications. And then we'll end with some key takeaways and further learning resources for all of you. So what is a design system? There are a lot of different definitions out there, and it can get pretty confusing, but this is the definition that makes sense to me. It's a set of tools that help designers and developers align on the brand identity. So you might be thinking, that's still pretty vague. I still don't really know what a design system is. And I think the best way to figure out what a design system is to actually look at some. So one that you might be familiar with or have heard of is material design, which was developed by Google. And if you visit their documentation, which is a very important aspect of a design system, you can get a sense of what this system provides you with. So it has some design guidelines, it has components and icons that you can use in your applications, accessibility guidelines, et cetera, et cetera. So if you were to jump into the design guidelines portion of their documentation, you would see principles and guidelines around different aspects of an application. So for example, when it comes to color, Google has defined 3 different principles. Color should be hierarchical, legible, and expressive. And of course, in their documentation, they go into detail about what each of these things means. And then in order to abide by these principles, they also have guidelines. So for one example, as you can see on the right, when it comes to selected text, it should be highlighted with a lighter variant of your secondary color of your palette. And of course, they also have tools to help you pick your color palette. Another design system is Polaris, which is developed by Shopify. And again, if you look at their documentation, you can see that they offer similar things to material design. They have their Shopify experience values, guidelines around content, language, and design, and of course, components. So if you look at one of their components, this one's called autocomplete, and it's just an input field that provides you with suggestions as you're typing. So you can see what it looks like on the bottom right corner there. And this is really great because it's already built out for you and you can immediately use it in your applications. So now that we've looked at a couple design systems, I think we can get a better sense of what we mean when we say design system. It's a collection of guidelines, utilities, and components that help developers adhere to the design principles of their team or company. Cool. So why should you care about this as a React developer? Well, there are 3 main advantages of using a design system. First is consistency. As we said, it ensures that you follow the brand identity. But second is efficiency. It makes development a lot faster and helps to keep your code dry. And then lastly is accessibility. A good design system should equip you with accessible components that make your website usable by users with disabilities or different restrictions. So to really illustrate why a design system is so useful, let's take a look at a hypothetical situation. So let's say engineer 1 gets tasked with creating this dashboard that you see on the left, which includes my courses, my goals, my workspaces, and on the bottom there where I'm covering the recommended for you section. And then engineer 2 gets tasked with creating what we call a hub page. So you have a subject, for example, game development. You have a description of what that subject is. You have recommended courses for that subject and some featured resources. And just looking at it right now, you can see that there's a lot of similarities between the UI of each of these pages. But I want to focus in on these two sections here, the recommended for you on the dashboard and the intermediate courses. Oh, thank you, Josh. And the intermediate courses section on the hub page. So you can see that these two sections look pretty much identical. So let's take a look at what the code might look like for each of these sections. And as a warning, I am using TypeScript throughout this presentation. I will do my best to give a rundown and explain it as I'm going through. But if you have experience with it, it'll make it a lot easier to understand this. But yes, so for both cases, we're going to assume that the course or path for each of the cards is represented as an object that has a type, which can be a string that's course, career path, or skill path. It also will have a property named title, which is a string, and then a property named lessons, which should be a number. And so we are defining the shape of this object with a TypeScript interface in both of these cases. So for each of these sections, we're going to assume that they are going to receive an array of content items. So on the left there, you can see what a list of recommended courses might look like. And then on the right, you see what a list of intermediate courses might look like. Great, so let's look at the actual components for each of these. So let's focus in on the left side for now, the recommendation section. So yeah, you guys can see my mouse. So the recommendation section is a React functional component, and it takes in props that follow the shape of recommended section props. And if I go up here, it's just an object that has a recommendations property on it, and that is a list of content items. So this component is taking in a list of content items, essentially. And then if we go down here to the return statement, engineer 1 decided that for the recommendation section, they were going to use an h1 tag for the title. Then they are mapping through the recommendations, and for each recommendation, they are rendering a recommendation card component. And then they're wrapping that list in this grid component. Cool, so that's the recommendation section. Now, if we move over to the left-hand side for the intermediate courses section, it looks pretty similar. The only difference is they used a different name for the prop rather than recommendations. They named it courses. And then they decided to use an h2 tag instead of an h1 tag for the title. And rather than rendering a recommendation card for each course, they are rendering a content card. And then they're wrapping that list in a component named container. So let's actually take a look at the difference between grid and container in each of these cases. Again, throwing in a little extra thing here, both engineers in this case decided to use emotion so that they can apply CSS in their JavaScript files. So I'll try my best to explain that as well. So engineer 1 decided that for their grid, they were going to use a div, and they were going to make the display grid. You can see this line here is just saying that we want 2 columns in that grid. They added 1 rem of padding and for the gap between the rows and the columns. And they also added a media query down here so that for any screen that's 840 pixels or less, they actually change it to be just 1 column. Cool, so that's engineer 1. Engineer 2, however, for their list, for the div that wraps the list of cards, they just made it a div that has display flex. And they didn't really take into account any breakpoints or smaller width screens. Cool. So jumping back into the main component here, as we said, for the recommendation section, engineer 1 renders a recommendation card, whereas engineer 2 is rendering a content card. So let's take a look at the difference between those two. So once again, they're functional components. For recommendation card, it's taking in a recommendation prop, which is just a content item. It's taking the title, the type, and the lessons from each recommendation or from the recommendation. It's rendering them in H2 and H4 tags, and then it's wrapping that in this card container component. If we move over to the right-hand side, for content card, looks pretty similar. Again, the prop is named differently. They used different tags for the content of the card. So they used H3, H4, and H5 tags. And then they again wrapped it in this card container component. But let's take a look at what the card container component actually looks like in each case. So for engineer 1, they used a div. They again used display grid. For their font family, they use Courier. They added a or a border of 1 pixel, 1 rem of padding on all sides, and a bit of margin, on the headers. If we move to the work that engineer 2 did, they decided to use a button rather than a div. They set display to flex. They used Arial for the font family. They added 2 pixels of border. They have different padding, horizontally versus vertically. They also explicitly set the width on the card. Oops. Well, came back. They have slightly different margins for the headers. And they actually added a focus state so that when you are tabbing through the cards, it actually adds a 2-pixel border around the card. Cool. So with all that code, we would get something that looks like this. Immediately, you can see that they don't look the same. There's a lot of differences between the UI of each of them. And I'm actually gonna switch over to localhost where I have these running so we can actually see what the responsiveness and accessibility of each of these looks like. So if I go ahead and open the Chrome DevTools and I start making the width smaller, you'll see that neither one of these components handles the smaller width sizes very well. But once we hit our breakpoint, you'll see that this section switches to 1 column, whereas this one stays as 2 columns. So that's not great, not very consistent. And then, as we discussed earlier, if I try using my keyboard to tab, you can see that a border gets added around this card here. And if I keep tabbing, I can never tab through the recommended section because the engineer did not account for that. Whereas we do have a focus state for our intermediate courses. So again, a bit of inconsistency. Cool. So at this point, you might be thinking, well, this is an incredibly exaggerated and contrived example. Hopefully in the real world, a designer or engineer who's reviewing this code would catch all these things before it hits production. And while that is very much true, this is still a very common situation that engineers find themselves in. And it does lead to, albeit more subtle, but still leads to consequences. So many times engineers will find themselves missing opportunities to increase reusability and keep things dry across teams. They will be repeating work unnecessarily. There will be slight disjointed styling, inconsistent adherence to accessibility standards, and mismatched responsiveness across the board. So these are things that we as engineers will come across in different levels of severity. And the main point is that a good design system can help alleviate a lot of these issues. So how can we use a design system to help us with this situation? Well, let's go ahead and jump into a demo to see how it will help. So I do have a repo for you guys to follow along. Let me pull up the link and try to drop it in the chat. Give me a second. Too many screens open. Okay. I think that should be in the chat now. So hopefully if you want to follow along, you can clone that repo and follow along with me. But I'm going to move over to VS Code to give you a quick run through of what the repo looks like. So let me go ahead and close this. I created this repo using create React app, and index.tsx is the root file for this application, and it essentially just renders our app component. And if we go into that file, currently it is rendering the two sections that I showed earlier that the two engineers created. But what we're going to want to do is we're going to replace those two sections with a new component that relies on Codecademy's design system. So I'm going to go ahead, or I am going to go ahead and switch these out. So now we should not be rendering the old section. We're going to be rendering this new curriculum card grid component. And if I go over to localhost, you can see that there's essentially nothing there. We have to build it out, and that's what we're going to be doing for the rest of this talk. Cool. So let's go ahead and jump into the curriculum card grid component. So right now it's just a div that renders some text telling us to build it out. So let's go ahead and build it out. So the first thing that we're going to want to do is we're going to want, because we want to reuse this for both the recommended section and for the intermediate courses section, we're going to want to have the section title come in as a prop, and that's just going to be a string. So I'm going to add that to our curriculum card grid props, and then I'm going to go ahead and destructure it over here. Cool. And let's get rid of this. And I'm actually just going to make this, for the time being, an empty div. Cool. So now I want to actually render, oops, did not notice this stupid autocorrect. Okay, there we go. So now we want to actually render our section title, but how are we going to render it? So that is where our design system comes in. Codecademy's design system is called Gamut, and if you go to gamut.codecademy.com, you are greeted by this lovely overview page that tells you a little bit about what our design system offers. So we have atoms, which are the basic building block components for our applications. We also have molecules, which are made up of atoms. We have components that help with layout and typography, and we also have a nice installation guide. And I've actually already run through the installation for this repo, so you don't have to worry about that at all. And these are the components that we're going to be using throughout this demo. So the first one you see is text. So let's actually switch over to my browser, and I'm going to look up this text component. So the nice thing about it is that you have the search bar to search all of the available components in this library. So if I go in here and I get taken to, oops, I don't know why it scrolled me there. I get taken to the docs for this text component. One thing to note is that our design system is made up of multiple packages. So whenever you're using a component, you'll want to know which package it's coming from. So in this case, it's coming from our /gamut package. So we'll use that in our import later on. And there's a lot of different documentation here, so I'll have to skim through it. I'm actually going to take us down to this section here called style variants. And this tells us a little bit about this variant prop. So our text component takes in a prop called variant. And down here, you can see the different values that variant accepts. And then you can see how it's rendered depending on the value. So if you give it title XL, it's this really large text with bolded. And then if you do P small, it's smaller, not bolded. So I think for our sections, we're going to go ahead and use title XL for the variant. So let's go ahead and jump back to the code and use that here. So as I said, we're going to want to import this from the right package. So import text from not Gamut Labs, from just Gamut. Cool. And then I can go ahead and use that down here. And I want to feed that our section title. And as I said before, this takes in a variant prop. And in our case, we want it to be title XL. I'm going to go ahead and save that. But then I have to jump back in here because we need to feed this a section title. So for this one, I'm just going to do recommended. Oops. for you. And then for this one, our section title will be intermediate courses. All right, let's go ahead and save that and jump to localhost to see what it looks like. Okay, cool. So this is really great. Like with little to no effort, we added the right styling, the right sizing, and it's consistent between our two sections. Cool, we're on our way. Now let's jump back in here. The next thing we'll want to do is that we'll want to bring in our card items. So I'm going to add a new prop called card items, and that is going to accept an array of content items. Cool. And then once again, I can deconstruct it here, card items. And I'm going to start mapping through it here. So we have our card items. I'm going to map through them just like the engineers did in the other section. And then for each card, I'm going to want to render something. So let's see. What should we render for each of these? So in each of the other cases, the engineers had to build out a whole separate card component for it. But for us, thankfully, Gamut has exactly what we need. So if we go here and look up curriculum card, that should take us to the documentation. And if I scroll down just a bit, you can see here, this looks just like, you know, the design file that was given. It's got everything that we need. So if we scroll down, you can see here, we document all of the props that this component can take in. Any mandatory components are labeled with this red asterisk. So we're gonna have to make sure that we feed it those. And if we scroll to the top, you can see that this one is coming from a different package in our design system. So we'll need to import it correctly there. So let's jump back into code. So go up here, we're gonna wanna import our curriculum card. From the labs. Cool. And then for each of these card items, we'll want to render that card. Cool. And now we have to make sure that we give it all the right props here. So I'm actually going to quickly deconstruct the card. So I'm going to grab the title, the type, and the lessons from the card so that I can feed that to this curriculum card component. So if I go back here to the documentation, I can see that it takes a title. In this case, it's Learn JavaScript, and it's rendering it here. It also takes in text, which in this case is course, and that's rendering it here. So if I go back here, I know that I already have those values. So title, I'm going to feed that title. And then for text, in our case, we named that type. Cool. Now I need to figure out what to do with this lessons number. So let's go back here. So this is a little bit different because it's expecting a very specific format. So it's got this scope prop, and you can see this shape. It's an object with a lesson property on it, and the value is the number. So I'm going to have to do a bit of formatting there. So let's create a new variable called scope. Oops. It's going to be an object. It's got a lesson property on it, and the value is going to be lessons from the card. Cool. So now I should be able to feed that to the scope prop. Okay. It looks like I'm still getting an error here. Property difficulty is missing. So if I go back to the documentation, I can see, yep, it looks like this is a mandatory prop, and it has to be either 0 or 1. Well, in my example, I didn't really care about difficulty. So for now, I'm just going to hard code it and say that all of these are intermediate courses. So I'm going to give it 1. Cool. So that should be ready to go. But I, once again, need to pop over here so that I can feed it the card items. So I'm going to go here. For this one, it's going to be recommended courses. This is just a hard-coded list that I made in another file. And then for this one, it's intermediate courses, which again is just hard-coded. Cool. So that should be set. Let me go over to localhost. Nice. So with not too much effort, I have my cards rendering. It looks consistent between the two sections, but obviously this really long card is not great to look at, but I do have a lovely hover state. But let's go ahead and fix the width of these. So the way that I can do that is actually with another gamut component called, I'm suddenly blanking, layout grid. So let's go ahead and look for that. So according to the documentation, this is just a 12-column grid system. And I find these little code snippets really helpful here so you can see what it looks like. And in the description here, it tells us that each cell or each item in our layout grid should be a column, which is a component also provided by Gamut. So if I go here to show code, it might make a little more sense. So we have our layout grid, and that contains a bunch of columns in it. And each column has a size. So for example, this one has size 12. So that corresponds to this here. It's taking up 12 columns. Whereas the next one has a size 6 over here. And so that one's only taking up 6 columns, so half of the width. Cool, so we can use that to our advantage. Let's jump back into the code. Go back here. If I wrap this with layout grid, move this here. Cool. And then I'll have to wrap my curriculum card in a column since layout grid expects a column for each item. So let's move this around. All right. And I'm going to say that I want each of these cards to take up half the width of the screen, meaning that I have to set the size to 6 so that it takes up half the columns. Let's go ahead and do that. Save and come over here. All right, cool. So it changed it to 2 columns. Doesn't look great. We can go ahead and add a column gap here. So this is great because you can actually add CSS through the prop. So column gap is normally something you would have to add CSS for, but I can do it right here. And I'm going to just add 16 pixels there. So now I have a bit of a gap between my 2 columns there. Awesome. So now if I go here, though, once I get to smaller screen sizes, I think it's starting to look a little too jumbled up. So I'm going to want to change it to 1 column. And Gamut makes that super easy. If I go back to this column, I can actually feed it rather than a number. I can give it an object that corresponds to breakpoints. So I'll type it out and it'll probably make more sense. So I'm going to say that for smaller screen sizes, I want this to actually take up 12 columns. But then for medium-sized screen sizes and above, I want it to take up 6. If I go ahead and click that, come over here. So because this is a screen size of medium or above, it's taking up, each card is taking up 6 columns. But if I go down to hit my breakpoint, now each card is taking up 12 columns. So really easy to make this responsive. And again, I could add a little row gap here so that that looks a little bit better. Let's do 16 again. Cool. And if I go here, we've got a row gap now. All right, so let's get out of there. My only concern now is that when I click tab, I can't actually tab through these cards with my keyboard. So in order to do that, we can use a Gamut component called Anchor. And just because of time, I'm not going to jump into the docs for this. But essentially, Anchor is like a button. But again, it's got the right styling that Codecademy uses. And it's also got a focus state that we can take advantage of. So let's go ahead and import that. And we're going to wrap our curriculum card in an anchor so that curriculum card is essentially a button. And Anchor takes in a prop called variant, which just determines the look of the button. So I'm just going to say interface because it doesn't really affect the UI. And then it also expects either an onClick or an href. I'm just going to give it an empty string for href for now. Cool, so now I've wrapped my card in this anchor component provided by Gamut. And if I go back here, now when I tab, you can see that I can actually tab through the cards. So we've covered our accessibility concerns there. Great. So let's jump back into slides. I know I'm running on time, almost done, Josh, don't worry. Cool. So hopefully with that demo, you were able to see how a good design system, a well thought out design system can make your life a lot easier. So let's go ahead and recap our key takeaways. Yes, as I said, a well thought out design system not only enforces the brand identity, but it also makes development a lot faster and it increases your code quality a lot. So hopefully this was a good intro into design systems and hopefully a bit of advertisement for our great Gamut design system. Thank you to Josh and the other engineers at Codecademy who work on it. But if you're interested in creating your own design system or learning more about what makes a good design system, I've included some links here to some resources that I found really useful so that you can use them in your own learning journey. But that is all from me. If you have any questions or want to follow up with me, you can contact me at silvana@codecademy.com. Thank you.
Well, thank you, Silvana. That was fantastic. Love to see a good design system. We have a few questions for you from the chat. Definitely recommend folks asking if they have them. What is the best and most compatible CSS framework I should use with React in general?
Oh, I don't know if I'm equipped to answer that. I really enjoyed, I mean, now with this design system that we have, we do most of our CSS through props, as you saw, like, you know, the column gaps, I was able to do that through props. So a lot of it now, I don't even really have to do CSS. It's more so CSS through props, which I love. But if that's not an option, I really enjoyed using Emotion so that you have your CSS styling in your JavaScript or TypeScript files. So you have it all in one place. It can maybe get a little messy, but it's very convenient. But that's just my opinion.
Sounds good. A few of these are general, so we'll start with those. Are there any particular common mistakes made in the designing process for design systems you'd like to call out?
I think, I don't know if maybe I'm misinterpreting the question, but I think one thing that we've started to do more within our product team or my product team that I've found very useful is to bring in engineers earlier on in the design process. So designers may be like, you know, trying to decide between different implementations, different designs, or trying to create like a new component. And they bring us in pretty early on so that we can catch these things early, because we've definitely found ourselves in situations where, you know, designers wanted like an animation and it ended up taking a really long time for engineers to implement that. So that's been really valuable in decreasing the amount of time we spent, waste time.
Great to hear. We have two flash questions from the chat. Do you have a preference on emotion or styled components?
I think I already spoke to this, but I really liked Emotion. I just think it's like easier to read and well, yeah, I don't know. I like actually seeing the CSS and having like a little bit more flexibility. But I think both are better alternatives to having a actual like CSS or SAS file. So I'm happy with either.
Excellent. Me too. How do I choose a design system?
I mean, I guess it like the biggest thing is like if you're with a company, hopefully your company has a design system. But I guess in terms of like if you're just working on your own passion projects and you want to like use a design system, definitely do plenty like, you know, poke around and see what is available. I think the biggest thing for me is like finding a design system that has good documentation, because it can be a nightmare trying to even just like install a design, like an npm package, and add it to your project. So definitely like a design system with good documentation is probably like my number one thing that I suss out for. And then besides that, it obviously depends on like what you're trying to build and maybe what components are important to you, like what styling you want. It's really like a case-by-case thing.
Excellent. Slightly longer question. How many pages are there in Codecademy? And I'm interpreting the real question to be, this seems like a huge effort. At what point do you go for a design system?
You might actually be better equipped to answer this, Josh, because you were more involved in it. But I think that we decided to, we had a design system for a while, but we really like put a lot of effort into rethinking it when we decided to change like our brand identity. Like the company created a new visual identity. So we had a lot of, if anyone here is a Codecademy user, we used to have pages that were like purple and white, and we had like a bunch of different colors, and it wasn't as cohesive as what we have now, and was probably just more dated as well. So that seemed like a good time, right? Like we have, like you said, so many pages, and we want to convert them all to this new visual identity. It took upfront work to create these components, and luckily we have a great team that did that upfront work. But it saves you a lot of time in, porting over all these pages if you have a design system. So that for us was the point where we decided to really put a lot of effort into it, although we did have one before.
Super. Yeah, that was a good visual identity change. Is it a not good idea to mix too many design systems together?
Ooh, I don't know if I'm like equipped to say this, but I feel like I would want to stick to one design system unless like, I don't know, it just seems like there would be like a stark difference between the two. I feel like most really good design systems have a very distinct style. So if you try to bring two together, I feel like they'll clash and it'll be kind of obvious when you're using one versus the other. But I also don't know all the design systems out there. Some are really flexible. So maybe there is a way where you can bring in more than one. And because they're so flexible, you can, kind of bring them together in a coherent way. But I feel like in general, one design system should be able to supply you with all of the tools that you need.
That makes a ton of sense. Got one or two more questions before I run out of time. Bringing all the conference talks together, how do design systems work with micro frontends?
Oh, I guess it could get very messy, but I think I'm also not like a huge expert on micro front ends, but hopefully your design system can work across all of your different micro front ends so that, once again, you not only have consistency across pages, but like if your pages are broken up into different micro front ends, like they should also, all work together. So like, for example, at Codecademy, we have some of our pages in what we call the monolith, but we've recently started moving some pages into Next.js, which we call the portal app. And so we use Gamut on both of those repos so that there's no visual, like the user shouldn't be able to tell like, oh, this page is in portal app, whereas this page is in the monolith. So yeah, hopefully design system makes it easier for your micro front ends to be consistent across the board.
Shout out Next.js, keeps getting brought up positively. A performance question, summarizing a few we've had. Can design systems slow down your system?
Oh, I wish I knew more about performance. I am inclined to say that it would help your performance because you have less files like in your actual repo that, you're having to build out. It's all coming in through an NPM package. But I will not pretend like I have a solid answer to that question.
No worries. I have the same answer. Last question. When does one begin to start using a design system in their career?
Yeah. One of the reasons that I gave this talk is because I didn't really understand what a design system was and did not understand the value of it until I started working as a full-time engineer or as an engineer at Codecademy. I think if you're like at a small startup, maybe your company is not at a point where, you know, brand identity is the main priority. They're trying to ship out things as quickly as possible because design systems do, like I said, take up upfront work, and it does take work to maintain them and continue to build them out as your website grows. So maybe at a smaller company you won't, but I would say that most larger companies should have some sort of design system to enforce consistency in all the areas that I've talked about.
Well, super. That makes a lot of sense. And thank you so much for answering these questions. This was fantastic.
Thank you. Thank you, everyone.
Bye, Silvana. Next up, we have Anna Carey. How's it going?
Hi, how's it going?
I'm good. I'm excited to see you again at a conference. And we're going to talk about, do you have some kind of pre-presentation or a little quick quote you'd like to give us about TypeScript?
Sure, yeah, I'll give a quick overview. I'll be talking about learning TypeScript in my first year as a developer. So we'll be talking a bit about my experience becoming a developer and some strategies I learned along the way of learning TypeScript to sort of help anyone learn any new technology or a new language. So yeah, really excited to be here and talk to you all. Oh, you know, I can't hear you, Josh.
Oh, sorry. I was asking, do you have some kind of slides to share? I'm seeing.
Yeah. Should I kick us off? Should I start?
Let's do it. I'm
all right.
ready to
Thanks,
go.
Josh. Okay. All right. Can you see my slide?
Can
Great.
do.
Okay. All right. I'll kick us off then. So yes, as I shared, I'll be talking a bit about my experience learning TypeScript in my first year as a developer. So to introduce myself, I'm Anna. I'm new to TypeScript. And now it can be kind of scary admitting that you're new to something. And this has pretty much been the theme of my last 18 months. About a year and a half ago, I changed careers and decided to become a software engineer, really to start as a beginner in a completely new field. So, and here I find myself speaking to you guys as a beginner. I'm still really on my journey to being a comfortable engineer, but my experience the last, let's say, 6 months or a year or so with TypeScript has been a really important part of my journey to being a proud beginner with any new technology. A bit about what I'll be talking about. As I shared, I'll give an introduction to kind of my path to engineering. I'll talk about my first experience working with TypeScript, what I came into TypeScript knowing, and how I really misunderstood TypeScript at first. I assume that most of this crew is pretty familiar with React, and it looks like from the last presentation, might be somewhat familiar with TypeScript, but hopefully we'll do a little bit of a shallow dive into the language. I'll talk about how overcoming roadblocks in TypeScript helped me develop this framework for sort of overcoming any real technical roadblock that we find ourselves in as beginner developers. And I'll share that framework with you all. And I'll talk about how that framework actually helped me turn TypeScript from something that was like scary and intimidating into my most helpful pairing buddy as I really came to understand the power of the language. So my goal for you today is to come away with really 5 key steps for moving through roadblocks in TypeScript. I'll also want to talk about, again, why TypeScript is so powerful, and not just why, you know, others say it's powerful, but why it was really powerful for me. And I'll talk pretty openly about facing challenges early in your career, and especially for me as an engineer coming from a non-traditional background, and how really overcoming setbacks and tackling something new, whatever that is, are really some of the key skills to develop for any software engineer, no matter what level you are. So my path to programming. So I'll take us back here. It's kind of where my fear of starting as a beginner really began, and how kind of some of these earlier setbacks really primed me to feel like I didn't know what I was doing. And again, a feeling that would be easy to come back to early on in my time as an engineer. So humans like to plan. We like predictability. We like to know what's going on. We like a clear path ahead of us. But obviously, if this year has taught us anything, it's that you can't really do that. Life's really hard to plan. There's always sort of roadblocks coming in the way. And something I've learned in my first year as a developer is that one of the very, very core experiences of being an engineer is to feel blocked. And what is a roadblock in programming? When you hit a point in your code that you're not sure how to proceed, a bug you can't figure out, a concept you don't understand. And something that I kind of came to is that programming is really all about hitting these roadblocks. So building skills to overcome and move through these roadblocks is really critical to your growth as an engineer. And for me, encountering these hurdles really fueled my fear of being a beginner, and it became kind of like this vicious cycle, hitting a roadblock, which felt uncomfortable, fostering fear of starting as a beginner, and hitting more roadblocks, and so on. So here's how that cycle kind of started for me. This is about 10 years ago. I moved from New York to California to study on a campus of people who would go on to build some of the biggest technology companies that we use every single day. I think if I remember, Uber was kind of just starting across the Bay Area in San Francisco. The movie The Social Network had just come out, and it kind of sounds cheesy, but I wanted in. Programming seemed like this really cool mix of problem solving and creative building, and it seemed like a skill that would open up a lot of doors for me. But this is what my computer science class looked like, sort of long before I ever got exposed to React. This is my class, thousands of students, primarily male identifying, and as I would later learn along my way, many of whom had some prior experience programming, whether in a high school course or sort of just on their own before finding themselves in this class. So they were not beginners. And I really struggled a lot in these classes. And I had a lot of other interests on campus. I was taking, more sort of humanities types of classes. I worked for the newspaper. I was in a bunch of student clubs. And I really couldn't see myself spending all night in the computer lab, which is kind of what I felt like I needed. So after my third computer science class, one idea was kind of bashing me over the head. Computer science isn't for me. I don't look like these people. I don't share their same interests. And at the time, I felt like I really wasn't as smart as them. So ultimately, I decided to drop the computer science major, really dive into my humanities interests. And at this point, sort of getting knocked down and not believing in myself really sort of primed me to veer away from computer science and software engineering. And only by chance did I end up finding my way back. So after I graduated from school, I moved back to New York and joined a company called Artsy, which is a startup in the art world and has a really strong engineering team. At Artsy, a lot of the coolest people that I got to meet were coming from the software engineering team. They were really talented technologists, but also, loved art and music like I did. And they really loved sharing their knowledge with others. They even ran this elective JavaScript course for non-technical folks at the company. And that was really my first entry point to JavaScript, which is kind of crazy to think about now that we're going to talk a bit today about React. And a big part of my job on the communications team, which is the first team that I joined when I first joined Artsy, was to helping share some of these software products with the world, and got to collaborate with them on that type of work. And really any chance I had to collaborate with them, even when it didn't have a lot to do with my actual job, I jumped at it. So clearly something inside me was telling me, you're pretty into what these people are doing. And I really felt like I was close to the magic of engineering, but at the same time, pretty far away. Now, for those of you who work at companies, I have sort of this sort of idea of framework of thinking about what different people do at your company. So you have people who sell the thing, like sales folks, marketers, communications people, like what I was doing. You have people building the thing. So you have product folk, engineers, designers, people who are probably in this audience today, and then people supporting the people building and selling this thing. So things like finance and HR. So now I had found myself selling the thing, but what I really wanted to do was build the thing. I was so interested in building the thing that I asked to see if I could transfer over to the product team. And shortly after that, there was a big restructuring, a leadership change, and I actually got laid off. And now getting laid off for my first job was hard, but it was kind of exactly what I needed to make a big change in my career. So a little while later, I enrolled in a boot camp in New York and was back on the path I started on my freshman year. And somewhat to my surprise, I actually really, really fell in love with coding. Met people sort of from all different kinds of backgrounds, non-traditional backgrounds like me, transitioning careers. And I discovered that writing code was really creative, it was structured, it was a lot of fun, it was really frustrating. And most importantly, it seemed like I would never hit the ceiling for the amount that I could learn. And that's something that I really love about this career path. But it was not without its challenges, of course, and hitting a roadblock, whether, not making it through university computer science or getting laid off, really sort of familiarized me with this feeling that was really easy to sort of come back to later on, this feeling of, holy shit, I have no idea what I'm doing. If there was, a bug in my code I couldn't grasp, or a new concept I couldn't understand, I would really come back to kind of these feelings of inadequacy. I wasn't smart enough, I wasn't good enough. And this would later come up when I was learning TypeScript in React. So after boot camp, I actually ended up getting hired back at Artsy, that first company that I talked about, as an engineer almost exactly 1 year ago. And in my first few weeks on the job, I encountered a lot of new technologies. At Artsy, we're a React and Ruby on Rails shop, which is what I learned in my boot camp. But there's parts of our stack like GraphQL or TypeScript, which we'll talk more about a bit later. These were totally new to me. And I was always asking a million questions and felt like, yep, I had no idea what I was doing. So here we are, Anna meets TypeScript. A little context on the history of Artsy and TypeScript. We've been using TypeScript in most of our front-end React and React Native code for the last 6 years or so. In my first few days back on the team as an engineer, I read a blog post by a former colleague of mine who has later joined the TypeScript team at Microsoft. And the post talks about kind of some of the basics of TypeScript and why we use it at Artsy. To talk about one of the points that the blog post makes, I'll sort of bring us back to that giant lecture hall in college. And one of the concepts that later proved useful, that especially sort of as a JavaScript React developer would have been new to me other than having had some of this experience back in college, was learning the difference between a statically and dynamically typed language. So one of these introductory courses was taught in Java. So I knew that declaring a variable as an integer and then setting it to 50 were good. But then if you set it to a string, you get a compilation error. So the blog post does a very similar comparison to Java with TypeScript, sort of similar idea here. And the post also talks about how TypeScript really gave developers on the team, and at the time, especially those working on our iOS app in React Native, a lot of assurance that some of the changes that we're making in one part of their code wouldn't have negative consequences elsewhere in their code. And this really brought a lot of value to the team. The point reflected a conversation I heard happening at a company that I worked for in between my bootcamp and when I joined Artsy. And this company at the time was just pure JavaScript React, and they were debating converting their front end over to TypeScript. And their debate really boiled down to, one, the time and effort that would take to do such a conversion. I know we've talked a bit about today about sort of how much bandwidth is required to do any types of conversion like this, and I'm sure most of us know how that can really weigh on a team. And they were sort of debating this against, as I said, kind of this safety that TypeScript creates in a code base. Really reducing the risk of introducing bugs into your code. Now, I'm sure a lot of companies are having this debate or have had this debate about whether or not to do this TypeScript conversion. But this is really kind of the primer I had when I opened my first TypeScript file. I'm going to sort of walk us through a pretty basic example in code that's inspired by a task I had in my first few weeks on the job and my very early days working with TypeScript. Now, the example is pared down for simplicity, but I hope the idea is to give a bit of a sense of sort of the thought process and some of sort of the basic building blocks of a TypeScript file in React. And yeah, share my experience as I worked through my first TypeScript file. To ground us in the UI, the interface we'll be talking about, this is one of the core pages on Artsy. As I mentioned at the beginning, Artsy is a marketplace for buying and selling fine art. We sell millions of artworks, and each has a page that looks just like this, the artwork on the left and a bunch of information about it on the right. We'll be talking kind of about this section on the right of the artwork page that includes information you'll see about the artist, the title, the price, but we'll be zooming into this section that includes information about the dimensions of the artwork. So say you have, this is a sort of like magazine cover, so the width, the height, and the length of the piece. So here's the component that we will be looking at. I'll give a quick tour of this TypeScript React component, artworks sidebar metadata. So we have this interface at the top of the file that defines the types for the artwork metadata that we're rendering, meaning what is the shape of the data that's going to be passed in through props from the parent component into this component. We have the component definition, and the component definition says that we are going to return a React functional component, and that we'll be taking in something the shape of these prop types, as I talked about in the previous slide. And this component does a few different things, but what we'll be sort of diving into is rendering this sort of box, like a text box, that renders the dimensions. Now, for the purposes of this kind of walkthrough, I will be doing a little refactor, moving the dimensions into their own component. So again, we'll be taking this highlighted area and creating its own component. So, like any good beginner, I start with what I know. So I start by pulling that like box component into its own component using just regular JavaScript React. Again, if you have familiarity with React, this should hopefully look pretty comfortable to you. So we have our props coming in, we're destructuring the dimensions, we're doing a little bit of formatting to create a string that includes all three of these dimensions attributes, and then rendering it in a text box on the page. All right, seems pretty straightforward. But here our yellow squiggly line appears. okay, some light annoyance, and maybe I start to feel like, okay, maybe my regular React skills are sort of missing a piece here. This is actually coming from my linter, so not too much panic yet. So to try to get rid of that, I sort of hastily go into the parent React component, do some pattern matching, and copy and paste the function definition, as I showed us before, that says we're returning a React functional component. And looks like we're taking in something, the shape that maybe we'll call dimensions props, right? But yes, we have our red squiggly line because, of course, this is not a regular React file. It's a TypeScript file, and it has no idea what dimensions props is. Now, to pause here for a second, when I saw these red and yellow squiggly lines, I'd often hear this voice in my head, you did something wrong, you broke something, you messed something up. It was like this TypeScript monster was waving its hands in my face saying, ha, you're bad at this. So moving forward, I did, again, some pattern matching, realized that I have to define my interface at the top of the file that, again, defines the shape of the props of the data that's going to be passed in from that parent component. So I typed out the props coming in, feeling pretty good about that to get rid of the error. But now, what if I wanted to add another attribute here in addition to height, depth, and width that was something like frame width. So say an artwork has like a little, couple inch frame. We want to include that on our client to tell our users how wide that frame might be. So now, again, in regular React land, I know I should be able to add a text box with the frame width coming from dimensions, because I know that me and my team did the backend work to add frame width to the dimensions model. I know dimensions has frame width, but another red squiggly line pops up. Okay, so I sort of take a little guess and I add the new dimension to the interface definition at the top of the file, feeling pretty good about myself. But nope, if I go up the component tree into the parent, I see when we pass in the dimensions prop into this parent that we sort of looked at the start of the demo, as we're rendering the dimensions component, I see this error pop up as I'm passing in that dimensions prop. And maybe if I sort of add frame width to the dimensions interface at the top of the file, I might be able to get rid of this, but I see the error kind of pop up again and again as I go up the component tree. So as I was fixing these errors, I would create more errors and in components I might have not even been working in. I was starting to feel like this poor guy whack-a-moling all of these errors. I fix one and another one pops up. And this isn't even where TypeScript is the most challenging. Now, what if instead I wanted to allow the dimensions prop to be either a string that we could directly render on the page, wouldn't even need to be formatted, but just have the height, depth, and width in that string already, or it could be the shape that we have here that it takes in the height, depth, and the width, and then we would then format it inside of our component. So dealing with more advanced concepts like union types is sort of where things get a little bit more challenging. So you see here, I'm defining a type at the top of the file for dimensions. That's going to represent the case when we do want to pass in all three attributes. And then you'll see here, we can use this union type operator that says that it could either be of that shape dimensions or it can be a string. Now, of course, that breaks the formatted dimensions calculation to get that formatted string. I get these red squiggly lines. And my first attempt at fixing this is maybe check to see if height exists. And then I want to do the formatting, otherwise render dimensions, which at this point would be the formatted string if it didn't have height on it. But nope. And this is kind of where the TypeScript monster starts to reveal his darker side. He was no longer just an annoying pest, but actually making me a little scared that I was never going to squash all of these errors, and potentially worse. And I don't know if others who, have started learning TypeScript as React developers, but it was kind of making me feel like I didn't know how to write React. So at best, it was sort of something to check off my to-do list, adding maybe an extra 20 to 30% of extra dev time. But really at its worst, TypeScript was making me feel like I was a bad developer, like I was a bad React developer. So at this point, between sort of this time argument and safety argument, I was pretty squarely on team anti-TypeScript. It was really just taking a lot more time and effort, and I wasn't really experiencing the upside and kind of yearned to go back to regular React developing. And the roadblocks were really getting to me, and I knew at this point I needed to kind of find a better way to work through these errors if I actually was going to continue succeeding as a developer with React and TypeScript. So here's how I really learned how to overcome these TypeScript roadblocks and become a little more comfortable as a beginner in TypeScript. So when I encountered our friend, the TypeScript monster, or I guess maybe not our friend yet, our foe, the TypeScript monster, one of my first instincts was often to ask for help. And I think a lot of early career engineers can really struggle with asking for help. And maybe this is true for more experienced engineers as well. So maybe to pause here and think about, why is it so hard to ask for help? One thing that I see, again, with a lot of beginner developers is that we ask for help too soon, or we are afraid to ask for help at all. And I've definitely fallen in both camps. Asking for help can kind of feel like you're admitting defeat, like it's the easy way out. And then also asking for help can be sort of bring up all these fears of wasting other people's time or exposing yourself as less smart or skilled than my team might have originally thought. And now creating a culture that really encourages engineers, again, of all levels, to ask for help is really important to building an engineering culture. And pairing is definitely a big part of my everyday. But something I really got wrong at the beginning is thinking about when actually to ask for help. And TypeScript really taught me this beneficial framework for working through these roadblocks that helped me sort of actually work through these errors, but also to prime me to ask for help at the exact right moment, not too soon and not too late. So before jumping to ask for help right away or struggling for hours or days, I've been there. Here are sort of my 5 steps for overcoming roadblocks in TypeScript. I'm going to kind of rewind and take us back to those components that we were looking at earlier and use this framework to walk through these problems to see how that shifts the experience of working with TypeScript. And maybe we'll be able to solve these problems a little more quickly. It's really when the TypeScript monster kind of starts to become a little bit more friendly. So, number 1, this might seem obvious, but take a breath. It's really easy, I think, especially with TypeScript writing in React, to enter panic mode when these errors pop up and just do a bunch of sort of pattern matching and just copying and pasting from other files. But this is not really the best way to learn something most effectively or sort of solve errors most effectively. So definitely, I always make sure to slow down and take a breath. Number 2, this, again, might seem obvious, but you'd be surprised at least how many times I have failed to do this. Actually, hover over the error and read it. Read it slowly, read it a few times. TypeScript errors, like a lot of things, feel as a beginner developer can feel intimidating at first, but as you sort of slow down, read them closely, and get used to these errors, you realize how much information they actually tell you, telling you exactly what you're getting wrong, and sometimes even what you need to do to fix it. Now, once you have read the error, using sort of these clues, the next step would be to open the documentation. TypeScript has a lot of really helpful docs that sort of walk through common issues and topics that actually explain why the language is structured the way that it is. And they have docs that are specific to TypeScript and React. So this is the documentation that explains a bit about union types, that topic that we briefly mentioned earlier, that provides some really helpful examples and even like a sandbox to work with to learn a bit more about union types. And I even found this paragraph that really helped validate my fear of being a beginner. And yeah, it says, facing weird type errors, you aren't alone. This is the hardest part of using TypeScript with React. Be patient. You are learning something. You are learning a new language after all. However, the more you get good at this, the less time you'll be working against the compiler, and the more the compiler will be working for you. Really key point here. How do I get TypeScript to work for me? So the documentation had a pretty similar example to mine with regard to union types, and led me to the solution of using the type of operator here to check if the type of dimensions is a string. If it is, just use that to just render the whole dimensions prop. Otherwise, we'll need to do that formatting as I brought up earlier. And no squiggly lines. Now, the power of these 3 steps definitely cannot be overstated. And I know that they can seem kind of obvious, but I think it's really common for developers, again, especially for beginners who want to really rush through a problem. And even if it takes a little bit of extra time to read the error, read the documentation, ultimately the extra time spent kind of learning the ins and outs of a language, TypeScript, whatever it is, will really pay dividends sort of later on. And it also has helped me to teach others. So as we've sort of onboarded new members of our team, even those who aren't even, beginner developers who might be more advanced in React but don't have experience in TypeScript, I'm able to more deeply explain some of the intricacies of TypeScript to my colleagues and kind of scale knowledge that way. And now spending all this time like reading the error, reading the documentation, kind of got me thinking about how much time I'm reading as an engineer. And it even felt a little bit self-conscious, like I'm reading more than I'm writing, which sort of feels like not what you're supposed to do as an engineer. But sort of this aha moment that came to me was that coding is really as much about reading as it is about writing code. But it's not just reading documentation and errors. It's actually about being in your editor and reading the code itself. So this is really where TypeScript becomes my really, really helpful pairing buddy, a really key turning point in my journey with TypeScript and React. So a couple months later, I found myself back in this dimensions component that we talked about because I needed to reuse it in another part of the code. And reading through the TypeScript component, I could really grasp what was happening inside. In just a few seconds, I had this really clear understanding of what the component's purpose was, what its functionality was, what data was being passed in, the shape of that data. It was kind of like my own personal treasure map key to see the interface at the top of the file. And the component definition was like a blueprint for building more things with it. And also, because of the way, if you configure your editor with TypeScript properly with React, you'll be able to surface a bunch of really helpful tools like autocomplete and IntelliSense that literally tell you the options for you when you're writing your code, as you can see here. It really felt like magic. So that leads us to number 4, which is read the code. I really could see how much rich information the editor was providing me because we're using TypeScript. And for me, as a developer who's new, the more I'm able to really absorb from reading through the code, the more I can learn from reading the code, the better I am at my job, the more efficient I am. And TypeScript really taught me to be a better code reader. And here we're kind of getting this idea from the documentation that's about letting the TypeScript compiler work for me, not against me. And this is when the TypeScript monster becomes my friend, my helpful pairing buddy, silently guiding me through my work. And that leads us to our final step, number 5, ask for help. So at this point, having the TypeScript monster by my side, I really feel empowered to make it through some of these more challenging TypeScript errors. But in cases when the TypeScript monster can't quite get me through, he made me a lot better at asking questions, sort of by reading the error, the documentation, reading the code really closely. I had a lot of context and knowledge that I could use to bring to my colleagues. And because my questions were a lot more informed and thoughtful, my team members were able to unblock me much more quickly. So to recap, these 5 steps really completely shifted my experience with TypeScript. Take a breath, read the error, read the documentation, read the code, ask for help. And when I sort of thought back to this original time for safety debate, I realized that something was missing for me in what makes TypeScript valuable. So yes, of course, TypeScript has definitely saved me from committing errors into my code base, but the value prop that really resonated with me was that TypeScript helped me read code better. It helped me navigate a really large code base, and it accelerated my learning as a beginner developer. And a key realization for me here was, when learning a new technology, really understanding the value prop that most resonated with me was extremely important. So not just what I heard, on Twitter or from blog posts or even from other engineers on my team, but really understanding and experiencing firsthand how TypeScript helped me read code better. That's what really got me excited about TypeScript and really had me bought in to using TypeScript in our React code base. And realizing how TypeScript really helped me day to day, made me a much more confident engineer, and definitely made me a much more proud beginner. Now, I've definitely come kind of a long way from some of the shakiness I first experienced with TypeScript. And, definitely those feelings of inadequacy still come up for me. But walking through sort of these 5 steps of overcoming roadblocks in TypeScript really helped me find success on my journey learning TypeScript in React. And now I feel much more empowered to take on this next step of learning, because I've really only just scratched the surface, and to tackle these roadblocks head on, and to really own being a beginner with TypeScript, React, or any new technology I'm learning. I want to thank all of you so much. Please feel free to get in touch with me. I love talking about, transitioning careers, coming from non-traditional backgrounds, TypeScript. It was great to get to know all of you today.
Well, fantastic. Thank you so much. That was a wonderful talk. We got a few interesting conversations happening in the chat. So if you don't mind, I'd like to surface a question for you. When is the right time to ask for help? How do you know it's the right time?
That is a great question. I would say asking for help, timing that is kind of a bit more of an art than a science, but a couple of tools that I use when I'm sort of working through a problem. One is time box. So, giving myself enough time, whether that's a couple hours or whatever sort of feels reasonable, and even working with my manager or a more senior engineer on picking how much time that is to work through a problem independently before asking for help. And then, I think that a lot of us who've sort of worked as engineers might have experience with, working through a problem and hitting, like I said, kind of that roadblock. I think when things feel easy and then things feel a bit challenging, but when you're actually blocked and, can't feel like you can't move forward and have tried a few different things, keeping track of kind of that documentation, what you've tried, and maybe that third try on something might be a good time to kind of reach out for help. And again, armed with kind of that information of what you've tried and so on.
That makes a ton of sense. Thank you. Another separate question, please suggest resources for advanced TypeScript.
Ooh, I think that the TypeScript docs would definitely be the place that I would recommend starting. There's a ton in there specific to React, not specific to React. I believe our team actually was doing this really fun exercise that was, I think it's actually in the TypeScript docs. And I can share this actually once we hop off in the chat, that runs through a series of sort of TypeScript exercises that progressively get harder and harder. And we did an exercise in the team where we were all split into, about 3-person groups on Zoom. And we all were kind of together working through these TypeScript exercises as a way to kind of like take a break from just like, product work during the day and actually developing our TypeScript skills. So yeah, happy to share that in the chat afterwards. It definitely helped me a lot get some of the basics.
That sounds like such a fun idea.
It was really fun.
I think this should be our last question or so. Do you have any suggested channels, sites, etc., to help with problem solving?
To help, I'm not sure if anything pops to mind as channels for just general problem solving, but definitely as I've kind of employed like these 5 steps, not just with TypeScript, but with sort of other new technologies, and it's sort of helped me finesse my process for learning. And I mean, everyone's so different here. So having kind of a framework to start with can be really helpful. And then kind of adjusting that based on sort of your own preferences or even like how your team works can be really helpful. But I'll think about that. That is a very good question.
That is a good question. And apologies to the rest of the questions in the chat, but we're out of time. So thank you so much for hopping on and sharing your wisdom with us. Much appreciated.
Thank you so much. Have a good day, everyone.
All right, and now we have a quick 10-minute break before the next talk. So I hope everyone has a good coffee chat. Cheers.
And now we want to say thank you to our sponsors, Neuralegen. Neuralegen's API and security testing scanner enables you to implement security testing across all your development pipelines. And what's so cool about this product? It's built for developers. It produces no false positives. Easy to use and fast to integrate with your CI/CD. Test your application's APIs with SOAP, REST, GraphQL on every build. Also, no manual validation of security findings are necessary. Developers-friendly remediation guidelines. Start fixing security issues early and offer. Start scanning today. Sign up for your free enhanced security testing account and enter Neuralegen's Nintendo Switch giveaway. Register here. There's a link in the chat.
Hi everyone. Are you a developer that works with images or videos in your web app? Did you know there's a global community on Discord to network with other developers that shares knowledge and best practices when it comes to working with media? Come join us and chat. In our Discord, you can find interesting stuff such as developer events others are participating in, resources and tips, career advice, best practices, tools and plugins, paid opportunities, content sharing, or even hanging out and sharing your pet photos and talking about video games while getting to know other developers. We will be raffling out weekly prizes for being an active community member. Join the server by going to this URL. See you there.
And I will want to say thank you to our amazing sponsors, BetterMe. BetterMe is a leading behavioral healthcare app publisher with over 100 million downloads available in 190 countries. With workouts, nutrition tracking, and mental health coaching, BetterMe is an all-in-one solution for a fit body and mind. BetterMe has been on the most downloaded health and fitness apps list since 2018. Join today.
Hello, everyone. I'm Tommy Kay, head of the front-end department, tech lead. But today I'm going to be your moderator for the last 4 presentation. And I would love to ask, how are you? How is it going? How is your evening? How are the presentations? From my perspective, everything is very interesting, and the quality of the topics and of the preparation of the speakers is really, really top. And thank you, Josh, for taking care of last few presentations. You were amazing. And now it's time to speak about another awesome topic led by Hassan El-Mghari. He is a developer advocate at Vercel. And as he said about himself, he's ex-founder and full-stack software engineer in company based in Philadelphia. And currently, he's working for Vercel as a software developer advocate. And he given several talks on podcasts, meetups, and conference talk at SalesConf a few months ago. And he also founded Ultrashock Gaming, which is a game marketing startup with a community of 500,000 members on Steam, and run it for 4 years before selling it. It sounds really incredible. And today he will speak about building full-stack web apps with Next.js and Prisma. And it sounds really amazing. So I cannot wait to hear about this topic. So yeah, I give you the stage, Hassan. Thank you.
Hello, everybody, and thank you so much for coming to my talk about how to build full-stack applications using Next.js and Prisma. My name is Hassan. I'm a developer advocate at Vercel, and I'm so excited to talk to you about this topic today because I think as front-end React developers, we sometimes overestimate how hard it is to do back-end related things and how hard it is to work with databases. And so I want to break it down from scratch. Even if you've never dealt with Next.js or Prisma, I'm going to explain them from the ground up, and then we're going to go into a live demo explaining how to build a sample full stack application. So let's get right into it. So in this outline, I'm going to talk a little bit about Next.js, why you should use it, and some of its main features. We'll cover Prisma pretty briefly, and then we'll dive right into some live coding, which will be the majority of the talk. So why would you use Next.js? Well, Next.js is currently the easiest and most popular way to create React applications. We've been growing at an incredible rate the past few years, and we have many companies from small startups to enterprise level using and loving Next.js. So let's talk about some of the main Next.js features. One cool thing is the amount of different ways that you can do data fetching and rendering in Next.js. You can do things like static site generation. So if you have a landing page with static data, Next.js can export it into a static website at build time. And what that means is it's going to be cached on your CDN and it's going to be extremely performant. Another thing Next.js can help with is do things like server-side rendering, which is very beneficial for SEO purposes, and you can still do client-side rendering, which is what you do in typical React applications as well. That's one of the great things about Next.js is it's a hybrid framework where you don't have to decide, I want my whole app to be server-side rendered. You can kind of do things on a per-page basis, which is really cool. Another great thing is that it just provides file-based routing right out of the box. So all you have to do is go into your pages directory and create an about.js, for example, and then it automatically creates an about route, as opposed to, using a React router and doing all of these switch statements to get that working in a traditional React app. Next.js also supports static assets through the public folder. There is built-in support for CSS and JS libraries and CSS utility libraries like Tailwind and TypeScript support as well. There's support for these things called API routes, which are really exciting because this is essentially serverless functions, or if you want to add any backend functionality to your Next.js applications, instead of creating an entire separate backend, you can just add serverless functions right inside of Next.js. Another cool thing is code splitting and bundling. So you'll see that Next.js comes with some pretty amazing defaults, and it's also very extensible and customizable if you want to go that route. But you just get so many performance optimizations right out of the gate, and this is a prime example. So with code splitting and bundling, Next.js only loads the JavaScript for the page that you're on. And this is great because you ship less JavaScript to the browser and your application is just more performant in general. And also in terms of errors, if you do have an error on one page in your application, but your user is on another page, it won't crash because the JavaScript, is scoped per page, which is great. There's image optimization by default through the image component. And last but not least, with our new release of Next.js 12, we have a brand new Rust compiler that's 3 to 5 times faster in terms of fast refresh and builds. There's also support for edge functions and middleware, and React 18 support with things like suspense and React server components. So a lot of really great things about Next.js. What I want to stress is while this may sound like a lot and it may sound complicated, it's zero config by default. So all you have to do is install it and it just works right out of the box. You can decide what features to use and what features not to use. You can incrementally adopt it. So it's pretty great in that sense. So as I mentioned, I work for Vercel, which is a hosting and deployment company for front-end developers. And we have this mantra called develop, preview, ship that I want to talk about really quickly. We enable developers to develop applications using whatever tools they're most comfortable with, and then enable them to collaborate with others through things like Next.js Live and preview URLs. that you can share with your team and collaborate on until you're happy with the final result. And then you can finally ship it where you just merge to your main branch and it's immediately available on Vercel's Edge global network. And we also just take care of a lot of the hard things for you and the boring things for you, like setting up domains and SSL encryption and caching and validation and DNS. And we're also the creators of Next.js. So now that we've talked about Next.js and Vercel a little bit, let's touch on Prisma real quick before we head into some live coding. So Prisma is a next generation ORM for JavaScript and TypeScript. So before ORMs and Prisma, if you wanted to interact with a SQL database inside of your application, you needed to go and learn SQL and use that to query things. But now with Prisma, you can simply use Prisma's API to interact with your database, and it's extremely easy. It kind of broken down into two main steps. So the first step is creating your schema. So you can see we have a data source on line 5 where we indicate what type of database we want to use, and we indicate the database URL. And this is typically, you can create this anywhere, things like Heroku or Render or Railway. And then on line 10, you can see that's where our actual schema starts. So in here, they're defining a schema called, or a table called user that has a first name, email, and active as fields. And you can see we include their types as well, with whether they're like string or Boolean or integers. And so after you define your schema, you can then query it using Prisma. So the way you do this is you do Prisma dot whatever table you're doing. So in this case, it's users dot create, and then you pass in the information you want. So we want to create a new user with the first name of Alice, with that specific email, and with active is true. And that's it. It just creates that row in your database. And it's really that easy. So now that we know the basics of Next.js and Prisma, let's get right into the code. All right, so this is the app that we're going to be building. It's called Contacts, and essentially you can add a contact by putting in their first name, last name, email address, and avatar, pressing submit. And the idea is that it'll populate this contacts list over here to the right. So we are going to be storing all of these contacts in a Postgres database and querying them through Prisma and then displaying them in our front end. So let us walk through the code. So over here, I have our Next.js application. I'm going to go through the general structure as well. So typically in Next.js applications, we have a components folder that contains our React components, and then we import these into our pages directory because this is what's actually rendered on the screen. So in our pages directory, you can see we have our typical app.js that's in all React applications, and then we have an index.js, which references our homepage. The great thing about our file-based routing system is we can just create, if we want to create an additional route, right? If we want an about page in our application. Typically the way you would do that in a regular React app is that you would add an about component and then you would import it into app and you would use React Router to add all these different switch statements and everything. With Next.js, it's as simple as creating a new file, naming it about.js, and we'll spin up a regular component over here, rename this to just about, capital about, and we'll just render hello from the about page. And that's it. We're going to save. We're going to go to our application. We're going to go to /about, and it's right there. That's it. It's really that easy. So that's our pages directory. Our pages directory has a subdirectory called API. And so this is where our serverless functions or API routes are going to go. And you can see it's empty right now. We're going to be creating 2 for this live demo. Then we have our public folder where you can store all of your static assets. Over here, all we have is the favicon for now. And then we have a styles folder that contains all of the CSS. Next.js ships with CSS modules by default, which if you've never heard of is just a way for you to scope CSS styles to an individual component. So for example, we have home.module.css, and we're only going to be using the CSS folder in our homepage. So you can see we import it, and this is how we import CSS. We do CSS modules. We do import styles from that CSS file, and then we do styles dot whatever class name, like styles.logo or styles.hr. And this is great just because it scopes things to a single component, and there's no need to be worried about, oh, if I change this class name, how many different components is it going to update? So that's the general structure of our Next.js application. Let's dive into the homepage code a little bit to explore that. All right, so let's go through our homepage. So for our homepage, we have 4 pieces of state right here: first name, last name, avatar, and email. And these again correspond to just our form inputs over here in our application. We are going to skip this for now, and we'll get to the to-dos at the end. But let's go down to our JSX. So over here we have a head component that we get from Next.js that allows us to display meta tags. So we're using it specifically for the title here, which is you can see over here in our application. So we got the header down. Then we have a div that has a left side and a right side. So again, this is the left side and this is the right side. So in the left side, we're going to see a form with all of those inputs that we just saw: first name, last name, email address, and avatar. And these inputs update their corresponding state over here. And then we have an onSubmit handler that is going to do some things. For now, it doesn't do anything, but eventually we're going to want to send a post request to an API endpoint that we're going to create a new contact in our database. So we have that left side. Over here on the right, all we have is a contacts H1, and then we're actually displaying 4 users. We're hard coding their information. So it's just actually me and a few of my teammates from Vercel. And this user component we're importing from the components folder. So I'm going to go ahead and open this. So components user, and it's just taking in, those 4 pieces of information as props and displaying them in this card format right here. All right, so let's go back to our index.js and let's go through these to-dos that we want to do. So the first thing we want to do in this application is connect Prisma in our Postgres database. And after that, we're going to configure the submit handler so that when the form over here is submitted, when the user fills out these 4 input fields and submits, we want to send a post request to an API endpoint that we're going to create a new user in our Postgres database, right? And then we're going to be querying another API endpoint to get all of our contacts from this Postgres database and render them on the page. And then to-do number 4 is just going to be actually rendering them on the page, mapping through whatever we get from the database and displaying it dynamically instead of hard coding these user components down here. So let's get right into it by connecting Prisma. All right, let's configure Prisma. We're going to open up our terminal and a new terminal window. And we're going to type npm install Prisma as a dev dependency. So what this does is it just installs the Prisma CLI so we can interact with it. And then we're going to npm install Prisma client. So this is what we're going to use to actually interact with our database and spin up a Prisma instance. So now we're ready to run our first Prisma command. It's going to be Prisma init. And what this does is it generates a folder, as you just saw, called Prisma. And inside of this folder is going to have our schema that we're going to define. So let's get out of our terminal, or click on our schema file, and you can see we're defining our data source here. So it defines whatever provider we have. It gives us Postgres by default, but whatever database you're using, you can replace in here. And speaking of our Postgres database, you're going to want to spin up a Postgres database using Heroku or Render or Railway, and you basically grab a database URL from that. And Prisma imports that as an environment variable. And so you can see we have this .env file, and I already copy pasted my database URL into here, so you're going to want to do that before proceeding. So now that we've defined our data source and have our schema file, we have to actually define the schema for our database. So the way we're going to do that is we're going to start a model called user. So this is going to be a single contact, and they're going to have all of those different attributes that we talked about, right? They're going to have a first name, and that's going to be of type string. They're going to have, and let me just duplicate this because all of them are going to be string. We're going to have last name, which which is also going to be of type string. We have avatar, and we have email. And so the last thing we have to add to this model is, you can see it's not happy because we have to add a unique identifier to it. So let's actually just add an ID, which is going to be an integer. And we're going to tell Prisma that this is our unique identifier, and also that we want to auto increment starting from 1. So we're going to go ahead and save this. Down here, we're actually going to add one more statement called map. And this actually maps our Prisma user to a table in our database with the name of users, let's say. So now that we're done with our schema, we can open our terminal back up and we can run npx Prisma database push. And so this essentially pushes our database schema to Prisma, and it notifies it, and it also pushes it to our Postgres database. So I'm going to go ahead and press enter, and we can see that's it. We generated the Prisma client, and it was updated. So that is that. So now we have a folder called lib, which I didn't really talk about in the beginning, but essentially you do have to create this folder and create a file called prisma.js, and you can just copy paste this code. I got it from their documentation. This essentially just spins up a Prisma client that we can then import in other places and use. So the final thing I want to talk about with Prisma before we go ahead and start adding our API endpoints and interacting with our database is that we can go to our terminal and we can type in npx Prisma Studio. And what this does is it opens a little UI that we have to interact with our Postgres database, which is really cool. So you can see it already opened up a user. We have our ID, first name, last name, avatar, and email. We can add records from inside of here, and there are no rows in the table right now, but when we start adding things, we can see them update here in real time, which is really cool. All right, let's head back to our application in our index.js, and it looks like we've just finished to-do number 1, which is great. So let's actually just get rid of that. Let's move on to sending a post request to an API endpoint to create a new user or create a new contact in our user table. So let's start out by populating this submit handler. So again, we're going to want to send this API request to the endpoint. So we'll populate the submit handler first, and then we'll go ahead and create that API endpoint. So we're going to wrap all of this in a try-catch statement. And we're going to create a variable called body, and we're basically going to be grabbing all of this information that the user submits. So the first name, the last name, the avatar, and their email. And then what we're going to do is just use the fetch API to query this API/create endpoint. We're going to send it a post request with the data in JSON format, and we're just going to stringify this body variable that we created with our 4 pieces of information in there. And then after this, we can just do the catch statement. So catch error, we're just going to want to console.log the error if there are any. So that's our submit handler. Let's go ahead and actually create this API endpoint now. So we're going to navigate to our API folder. We're going to create a new file called create.js. And this new file is where we're going to be dealing with our database. We're going to be querying our database and sending it the information that we got from this post request. We're going to be sending it these 4 things. So the first thing we're going to want to do is import Prisma. So we're going to import it from that lib directory. So we're going to do lib/Prisma, and we're going to export default async this function called handle that's going to have both a request and a response. So we're going to have that. Let's destructure all of that information that we got from index.js. The first name, actually, I'm just going to copy this over here. We're going to destructure all this. And we're grabbing it from the request.body, because that's how we sent it in. And then we're going to create result. And this is where we're finally going to use Prisma. So we're going to do await Prisma, Prisma.user, because that's the name of our table. Remember, if we go back to our schema, that's the name of our model and our table in our database. So we're going to do Prisma.user.create, and we're just going to be creating, we have to use data over here, and then we can pass all of the variables in here. And actually, I forgot to define this over here, or I forgot to this equals. So in here, we can use first name, last name, avatar, and email. So we're sending all of this information to our database, and essentially what we have to do after that is we'll just return it in the response. So we can do res.json of result, and that's about it. This should create the user in our database. So let's go ahead and test if this works. So we'll go to our index.js. Remember, we already have all of this inside of our submit handler, and our submit handler is called when the form is submitted. So let's go to our application. Remember, we still have Prisma Studio here live that has, no rows in this table. So we're going to try to create a contact. So I'm just going to add my own name and emails, and then I'll grab my avatar from GitHub. Fun fact, you can do .png at the end of a GitHub URL, and it'll return the avatar. So we're going to press submit, and let's go back to Prisma Studio and refresh. And we can see that we've added a user here, which is incredible, right? We've just interacted with a Prisma database, and the data is persisted, right? It's not like we put this in React state where, if you reload, everything will go away. This is in an actual Postgres database. All right, let's go back to our code. So now that we've created an API endpoint called create and used it in submit handler to automatically add a user to our Postgres database, we have finished this task over here. So we can move on to our last task, which is to essentially query our database, get all that information, and display it on our page. So let's go ahead and do that. The first thing we want to do is go to our API folder, and we're going to be creating one more API endpoint called posts. So this is to just grab all of the information from our database. So again, we're going to be importing Prisma from lib/Prisma. And then we're going to export default async, our handler function with the request and response. We're going to be storing everything in result, and we're going to do await prisma.user.findMany. So that's the Prisma command to essentially return everything in your database. And then we're going to be sending this result back. That's it. 3 lines of code, and we queried everything in our Postgres database and sent it back. So now we actually have to call that API endpoint from our front end. So to do this, we're actually going to use a React library called SWR. So we're going to import use SWR from SWR, and this is essentially a React hook for data fetching. It gives us a lot of really cool things like revalidation and caching and stuff like that. So highly recommend you use either this or React Query when dealing with API data in your React applications. So in here, we're going to create a fetcher function really quick. And essentially, this just uses the fetch API to query what we need. So we're going to go ahead and return it in JSON format. And now we can use our SWR library to actually grab all of the data from the posts API endpoint that we just created. So we're going to do const data error equals use SWR, and we're going to query /API/posts using our fetcher function. And that's essentially it, right? It grabs all the data and it puts it in here. And if there are any errors, it puts them in this variable right here. So after we grab our data, so now we've essentially triggered this posts API endpoint that talks to our database, grabs all the data, and sends it back to us. All right, so now that we have all of our data in data, we finished to do number 3, and we can move on to our last task, which is to actually display data on the screen. So we have all these users. We're going to get rid of all of them except one, and we're going to map over data and display things. So we're going to do data and data.map, and then for each thing in data, we're going to just destructure the first name, last name, email, and avatar. And what we're going to do, we're going to destructure all of that. We're going to, and then we're going to return, essentially return users in here. So let me move user over here. And we're going to do first name equals first name, last name equals last name. And, this will just map over data and display all of our users in this form. So we have data.map, all of that. I think I forgot an extra parentheses over here. And let's go ahead and test out if this works. So let's go back to our application. Let's go over here, and we can see that we see what we have in the database right here, which is Hassan. Let's actually add something to our database and see if it updates. So I'll go ahead and add Stephen. So Stephen Tay, Versal.com, and then his GitHub, I think, is Stephen Tay.png. So I'm going to grab that, put it in avatar. We're going to press submit. And let's check our database first of all and see if it's there. And it is. It gets added to our database, but you can see it. And then finally, it gets added to our application. And so you can see, we're interacting with a real Postgres database here. We can refresh and we still get the same information. So there's one more small thing we want to add here, because when we add a contact, it doesn't instantly appear in contacts over here because React or Next.js doesn't know whether to refresh. So let's actually demonstrate that again by adding my teammate Delba. Delba.adversal.com, and we'll add her avatar and we'll press submit. And as you can see, nothing really happens on this side. Right? Our contacts don't get updated because React doesn't re-render. So to make sure React re-renders, we can go back to our code and back to SWR specifically, and we can add a parameter called refresh interval. And so this will essentially pull the database at whatever time we want. This is in milliseconds, so at 1 second. So if we go back to our application, we can see that Delba was added. It looks like I made a mistake in the avatar name, but we can demo that again. Hassan at Hassan. This is not a real email, but just to show that it's different. And then I'll actually just grab someone else on GitHub. Let's just grab a random person that I'm following. I'll grab Guillermo and .png, and we can press submit, and you see that it updates because it's pulling the database every second. So thank you so much for coming to my talk and listening to me speak about how to use Next.js and Prisma to build full stack applications. I hope I shed some light on how easy it is to add a database to your application and make it full stack as front-end React developers. And I hope you enjoyed the rest of the conference. Thank you so much.
Thank you, Hassan. Really great presentation. I have really enjoyed the topic of how to utilize the Prisma and Next.js. So now it's time to introduce Hassan and add him to the stream. 1 second, please. Hello there. Can you hear me?
Hey, yes. How's it going, Tommy?
Good. I'm fine. How are you?
I'm doing great. Thank you.
Great. Really great job about the presentation. I really enjoy it. And you make me feel convinced to use Prisma in my next projects. I've never used it before, but I have used Next.js, so I wonder how those two will cooperate. Cool. We've got some questions for you. So let me check. Okay, so the first one, can we link that to Firebase database?
Yeah, great question. Yes, you can absolutely link your Next.js applications to the Firebase database. There are some trade-offs in doing that because Firebase only supports NoSQL databases. So if you do use Firebase, you're going to be doing a NoSQL database. And in that case, you actually don't need Prisma. because you don't, NoSQL databases don't have schemas, and you can just interact with Firebase directly through the API that they give you.
Mm-hmm. Cool.
Great question.
Yeah, thanks for the answer. Another great question, because you were talking about building the full stack web, and what has been your biggest challenge with creating the full stack applications? If you could please tell something about it.
Yeah, good question. I don't feel qualified to answer, honestly, because of my lack of experience. But in general, I think it's just making sure everything works and that you're connecting everything properly. And part of that is maybe using TypeScript in your applications, so to catch those errors like really early on before build time. But yeah, just I guess the biggest challenge is just making sure that your front end can talk to your back end and that your database is synced with your front end and there's no like bugs with the communication between them.
Mm-hmm. Yep, great answer. Yeah, I managed to build full stack apps too, and it's really hard, to take care over everything. You need to put a lot of attention to the details, to the communication and stuff like that. Great. Yeah, let me take a look at new comments. So we have a lot of thanks to you for the great presentation. So attendees are very, very happy about the topic you have presented. I see we have no more question. So maybe I would like to ask you, have you used Prisma with any other tools except Next.js? So did you integrate Prisma with other frameworks?
I personally haven't, but I'm sure you can. You can integrate it in like a Gatsby application or a Create React app or whatever it is. And I think the general process is pretty much the same. You install it, you define a schema, and then you can just use the Prisma API.
Yeah, it was looking so simple when you have presented how to handle the Prisma connection. So yeah, let me try to utilize in in other apps. Cool. One more question I saw on channels. So if you have an API common across apps, you can have API in a separate repo. So basically, I saw you put the answer on the chat, but if you could please explain us a little bit more about it.
Of course. So yeah, first off, shout out to the Prisma team. I mean, they made that process very, very easy to define those schemas and interact with databases so that us as front end developers can do that. So shout out to them. And yeah, this is a great question. The API endpoints that we define in the talk in Next.js, you just go to the API folder, you create a new file, and that's just an API route or a serverless function or whatever you want to call it. But that's global. If you deploy your application, if I deploy my application at Hassan.com and then I'm using /API/hello, for example, like that's a real API endpoint. You can use that in your React application or your Vue application or your Angular application or whatever it is. You can trigger that API endpoint from anywhere and get back the data. So that's pretty cool.
Wow, I didn't imagine how advanced this feature is, but okay, so if we can share the endpoints, so how to take care over security over that communication, because I found a little bit danger if we can, just communicate just like that. So what we can do to take care over security?
That's a great question. So you can set up a bunch of security headings when you're posting things and you're getting things, and you can require like JWT tokens, and basically you can authenticate in a bunch of different ways. I didn't show that in the talk because that was kind of out of scope. But yes, the point is you can secure your endpoints so that only you can query them and they're not public, or you can keep them public if it's like a public API that you want everybody to get access to. You can even, track users that are using your endpoints and kind of like charge them for that, for example, if you want to have an API and charge for it using platforms like Rapid API, for example.
Yes, thank you. I appreciate the answer. And yeah, I appreciate all the answer. on all the answers. Thank you very much for your time. I see we have another question. So can we use Prisma with GraphQL?
Absolutely. Yeah, Prisma supports GraphQL really well.
Okay, cool. Yeah, GraphQL is really a cool tool to use. So it's really nice to hear that we can also use it with Prisma. Another question, does Next.js uses Express under the hood?
Yeah, good question. So I'm assuming you're talking about like the API routes, because that's kind of like a backend functionality. And you're asking, if we spin up an Express server in the background to serve those. Actually, what Next.js uses under the hood is AWS Lambda functions. So that's how we use our API functions. So we don't actually use Express for API routes.
Okay, got it. So just a quick question from my side: how to deploy and host the whole system? I mean, how to deploy and host the Next.js app with Prisma?
Great question. So essentially, use Vercel. At Vercel, we created Next.js, and so obviously the hosting and deployment, we've kind of perfected that process for Next.js. And so it's as simple as connecting your. So I linked the GitHub repository. I hope people saw that, because some people were asking for it. It's like my GitHub username, netlope/Next.js/Prisma/demo. But essentially, it's you create an account on Vercel, you link your Git repository, and that's it. It's live on a URL, and it works, and you don't have to configure anything.
Wow, it sounds so simple. I would love to check it out on my own. Great. Thank you, Hassan, for the great presentation, for all of the answers. I know that everyone just enjoy the whole presentation, the whole show, and yeah, I cannot to hear the next presentations from your side. So yeah, thank you, man.
Thank you so much, Tommy. I appreciate that, and thanks for this opportunity. It's been great. Thank you, everybody.
Okay, guys, it was a really great presentation. I enjoy a lot. But yeah, let's move things forward. And we have another topic, which is, let me check the great list I have prepared. We have React full stack in production, which sounds really, really awesome. And this topic will be led by Suvik Basu, which he is a software engineer at Microsoft. So yes, let's say hi to Suvik. I think he's ready. Okay. Hello, Suvik.
Hello,
Can
everybody.
you hear me? Yes.
Yeah. Hi, Tommy.
Great. I can see you. I can hear you well. Hello. Nice to hear you. How do you feel today? How are you? How is it going on your side?
It's going pretty good. So it's a lovely morning here in Vancouver. So totally excited for my talk, and it's been going pretty well. Like I've been following this conference since the last, I think, 10 hours now already. So yeah, like since it started at my night time yesterday, and a lot of these talks, they are quite insightful. Like a lot of things I have not thought about before, and I learned quite a lot myself. So yeah, it's going good.
Well, hopefully you don't feel tired and you still have powers to lead your presentation. Would you please tell us a little bit more about yourself before you will start the presentation? So what are you doing at Microsoft? I think it will be interesting.
Sure, yeah. So what I'm working at Microsoft is quite a lot related with my talk also today. So I am a senior dev working with Microsoft, and recently we acquired takelessons.com, and we kind of rewrote that website using React.js, mostly using Next.js. The tech stack is quite similar to what I'm going to talk about today, and a lot of the learnings that I've had with the teams here at Microsoft, and even before that, a lot of React projects that I worked on, especially for the last 1 year. I have been trying out a lot of different tech stacks to create a React ecosystem. And I thought it's a good opportunity for me to share with the community.
Wow, sounds amazing. I'm a huge fan of React. So I cannot wait to hear about all of these stories in your presentation. So just want to ask you if you are ready to start, if you could please share your presentation, and yeah, we can begin.
Sure. Let me just quickly check.
No worries. Okay, so it's pretty nice that yeah, we are living at different places. I'm in Poland, in the center of Poland, here in Vancouver. You have like the beginning of the day. My day is almost end. It's a really great opportunity to meet such awesome people. We have a lot of people watching us, so that's great. We are waiting until Suvik will share his screen. So few seconds more, and I believe we can start.
Sure. So I'm sharing my screen now. Please see if you can get this on stage.
Yes, sure. Sorry. Okay, cool. So the stage is yours. And yeah, good luck.
Great. Yeah. Thanks, Tommy. So hello, everybody. So my name is Souvik Basu, and today's topic is about React full stack in production. So yeah, let's get started. A little bit about myself. As I said, like I work with Microsoft here in Vancouver, Canada. And on the side, I run a community-driven site called Frontend Social, which is a platform for front-end developers and designers. And you will find a lot of good articles, news about front-end and any kind of events which are happening. So if you're a front-end developer, I'll suggest you take a look at this site, and you'll get a lot of updates here on. And if you want to follow me, you can check my Twitter account at Souvik Basu. I post a lot of front-end related tweets whenever I find something interesting. Okay, so starting with today's topic, when we say React full stack, what exactly does it mean? Because React is on the front-end side, right? One problem that I have seen a lot of us as front-end developers that we are facing is that we know how to build the front-end side of things. But as front-end developers, a lot of times we don't really know how the backend is going to work, or how are we going to call the backend APIs, how the deployment is going to work. So React full stack is about getting ourselves ready to be a full stack developer using the React ecosystem. So what it contains is definitely there is this front-end tech stack, which has a bunch of things that we have to look at. The topics that I have listed here are primarily around the concerns that you will have when you are trying to deploy an application into production. And I think a lot of these things, so this is actually like I've custom made this for junior developers, because a lot of you who are seasoned developers would have already deployed a React application into production and would already know a lot of these things. But for somebody who's junior, who's just starting, they don't have much idea around how to get your hello world into production. Like, what are the various things of concern that you have to be mindful of. So this talk will have a lot of pointers around the things that you have to, it's more like a checklist kind of thing that you can take into account while you're putting your app into production. So apart from the front-end tech stack, we'll also look at the backend stack and the things that you have to take decisions on a lot of time as developers. How do you do deployment, and how do you take care of various things like analytics and SEO and production support and things like that. So given the time constraint, I'm not sure how much we'll be able to cover, but we'll try to go a little fast, and then we'll at least try to touch base on each of this. Okay, now when we say the front-end stack, let's start with how exactly are you going to create a React application, the front-end UI of it. so that it is ready to be deployed into production. Now, most of us, when we start working on React, the Create React app is the CLI that we are all familiar with, right? Like that is mostly our getting started tool to create our first React application. But as and when the application kind of grows in size and when we are ready to ship it into production, we see there are a lot of things lagging because Create React app is kind of very basic, although they have added a lot of things now onto it. And like there is good support for testing using the React testing framework, and then there is integration of tailwinds and all. But still, it's more like a small, like a library around React. It's not really a full-fledged framework. So if you want to deploy something into production, I will suggest you take a look at few of the offerings that are there in the market, which creates a framework around React and not just React as a library. So the most popular out of these would be Next.js. Why one would go with Next.js is, first of all, okay, and while we are talking about Next.js, so there is also Gatsby and there is also Eleventy. So all of these sites, they are pretty much on the same lines. Their overall theory is same, like they're all static site generators, and they have few features more or less like they kind of compare with each other. Out of these, Next.js and Gatsby are the most popular ones that people choose. My personal favorite is Next.js. One thing is because I have used that a lot of times in different applications. That doesn't mean Gatsby is not that good. It's just that I've had more chance to work with the Next.js applications, and I kind of know that in and out. So the major advantage that you get by using a framework like this is of SEO. Because when you're creating an application using Create React app, you're mostly thinking about the client-side rendering part. Whereas when you're creating an application using Next.js, there are various modes of rendering. Like you can configure your application to, or your page to be rendered on the server side, which helps a lot with your SEO. Or you can configure it to be rendered client-side, which gives a good user experience for all the pages which are, let's say, beyond the auth gate. Like once you have crossed your authentication, all those pages which are after that are not really useful in SEO, because your SEO web crawlers are not going to go beyond your authentication pages, like your login pages. So there you can have a better user experience by having client-side rendering whenever the user is making any kind of changes on the UI. Like if the user is playing around with the filters, then you can use client-side rendering to change the page on the fly. Now, apart from this, there are other rendering techniques also which Next.js supports. Like there is something called ISR, which is incremental static regeneration, which is kind of in between static generation and client-side rendering. Like static SSR, when we say like server-side rendering, that will only, or SSG rather, like when we are doing static site generation, these files are kind of created on the build time and deployed to the server. So you don't really have any opportunity to change it. So any kind of pages, like for example, blog pages or any kind of content pages which are not going to change frequently, we would like to keep them as SSG pages, like static site generation. But there are cases when the page is fairly static in nature, but a lot of times you would want that page content to keep changing. Like for example, if there is a news website and you want to keep posting updates about the news periodically, so you would want that page to change. In such cases, you use something called as the ISR mode of it, wherein it again deploys it as static page on the build server, but on a periodic basis, which is configurable, it will again redeploy the new version of the page. So these kind of things, when you try to do this hand coded, it's quite a pain. So I'll always suggest you go with one of these frameworks whenever you're creating a React application. And apart from this, there are other advantages also. Like, for example, it will have image optimization, and there will be good handling of routers, and a lot of things around analytics. Like, for example, Next.js has a page dedicated for Web Vitals, which will give you some kind of analytics reporting. Now, the next thing is about another hybrid approach, which is about creating a universal app. Now, this is also something which is getting a lot of popularity recently. A lot of companies, especially startups, when they are tight on budget, they do not want to invest creating a site, creating a website and creating the native apps separately. Although there are advantages of doing this separately, but in general, you would want to have them if there is a possibility of creating a single code base that runs both of them, then it's definitely a big cost saver for startups. So for creating such kind of universal apps, you have a lot of offering. The most popular being Expo. So Expo is, again, it actually started as a framework around React Native. But nowadays, using Expo framework, you can actually create React apps which runs on Android, iOS, and even web. So it's basically the same code base that you are writing, but it kind of deploys everywhere. There are definitely customizations that you can do for native platforms, but overall you get a lot of cost savings in terms of your reusability of the code base. Then there is this Ionic React. Again, Ionic actually started on the Angular side, but lately they included React also as part of their suite of products. So now you can create your native React apps using Ionic, which will again run on the web as well. And then there is an open source library from Microsoft called React Native for Windows, which is hugely popular for creating desktop applications for Windows using React Native. So definitely check these list of items as well whenever you're starting to create a new React application for production. Then apart from these options, there are a few more options which actually comes batteries included. What I mean by that is that these frameworks will not only take care of your server-side rendering and different analytics as such, but it will also take care of storing your data. Like, it will have support for API calls and a lot of other things that Next.js and Gatsby probably don't provide as of now. So a few examples would be Blitz. So for example, Blitz is actually another framework which is created on top of Next.js, and it provides you a lot of support for Zero API framework. Then there is Vulkan, which was initially created for Meteor, but now they have a plugin for Next.js as well. And it has a lot of support for React plus GraphQL framework. So if you are trying to create a React application with GraphQL support, probably you should take a look at this. And also there is this Remix, which is an upcoming framework around React again. And it comes with a lot of promises around handling a lot of cross concerns for you, so that you can just concentrate on the application logic, and anything cross concerning like routing, logging, and all will be taken care of by the framework. So I have put in all these links here in the slide that I'm showing it to you right now. Maybe later on I will share the link. I will tweet I'll tweet the link to these slide share so that you can have these things handy. So you don't have to like write down anything right now. Okay, now when you are thinking about your React application in production, again, another concern that you will generally have that you generally don't think about much in your regular Hello World application is about design systems. Like, for example, if I have to create an application, if it has a button and a checkbox and a progress bar and things like that, the immediate solution that comes to our mind is, why not I just create a button and just start styling it the way I want it. But it's not just as simple as that, because for something even as simple as a button, you would want to have theming support. You would want to make it responsive. You would want to make sure that it is accessible, so it has all the area tags added. And there are various modes available for showing the button, like a large font, a small font, a button with icon, a button which has a progress icon shown. So for these kind of things, and also you have to make sure that it follows a lot of design principles. So again, if you want to do these things by hand, it's a lot of wastage of your time, because these are kind of solved problems within the industry, and you can leverage those what already exists. So depending upon what kind of design system you're looking for, what kind of overall design you have in mind, you can choose one of these, or there are a lot, hundreds of more design systems available in the market. A few of those that I like are the Fluent UI, which is from Microsoft, which has, like most of the Microsoft products are created using Fluent UI. So if you know how the Microsoft site looks and feels like, if you want to create a site something like that, then you can take advantage of this design system. Then there is Ant systems, which are mostly used for enterprise applications. Then there is the Material UI design system, which is mostly based on the Material UI designs from Google. And this has been there in the market for a very long time and very well received and tested. And so all these design systems, they not only have a list of components, they also have a lot of guidelines around what to do, what not to do, like, what kind of spacing you should have, what kind of contrast you should have, what kind of fonts you should go for, what sizes of fonts you should go for. So it's always good to check out this kind of links and get an understanding of it before you jump onto integrating any of the design systems. Then there is React, Bootstrap, Semantic UI, Onsen UI. A lot of these are the popular design system libraries that you can take a look at. Again, something that I will suggest here is that stick to one. Don't have a Fluent UI doing half of the page and Material UI doing the other half of the page, or one page in Fluent, one in Material. Don't do like that, because then your user actually, there is a chance that they'll get confused, right? Because it doesn't look and feel the same all throughout the website. So just make sure that you stick to one and then go ahead with that. And if you are a larger organization, then the chances are that you might actually have a design system of your own within your organization and create your own design templates. And just an extension of that is general styling guidelines. Now, a year back or so, the most general way of styling your React components was using style components, because style components comes with a lot of advantages. It's like a CSS in JS, which looks like you're actually using React components for styling as well. And you could actually use your React props for conditional styling. And there were a lot of different advantages that this library gives you. But recently, Tailwind has actually gained in a lot of popularity, and that's one of my favorites as well. So if you haven't done this before, I will suggest you take a look at how Tailwind works. It's basically a class utility which will allow you to style your components by making changes within the HTML or the JSX itself, and you don't really have to write separate CSS statements. Because writing custom CSS style statements is always error prone, buggy, and it's not a very good experience. And also it kind of increases the payload of your style files. So and the latest version of Tailwind also is it comes with a lot of advantages. Like, first of all, it is industry tested. A lot of products are there in the market which are already using Tailwind. Recently, I saw there was a tweet by the creator that Tailwind has reached more than 1 million downloads in NPM packages, the weekly downloads. And also it has things like just-in-time compilers and things like that, which allows you to speed up your development as well on your React app. And if you don't want to go with any of these, then you always can fall back to your regular Sass styles that we have been using for ages. Just a note, like if you have any questions, I'm not sure if you'll have a chance to go for a Q&A in this conference. If you have, that's good. Otherwise, you can always post me questions on my Twitter ID on any of the points that I mentioned here, and I'll be happy to explain more. Then going further ahead on the styling part is the overall UX of your page. And a lot of times you would want to create good transitions and good animations on your page. Again, this is a concern that you will face a lot of times when you're thinking of an application in production, because you want to create that kind of an experience for your user. And recently I saw a lot of websites which had very subtle transitions. And when I talked to the creators of those websites, like, how did you create such beautiful sites, like, which had natural feeling transitions? Like, for example, I saw one React conference website, which was showing the user's ticket, which was mostly kind of a badge. And just to give it a natural feel, it was kind of swinging a little bit like this, like, like as if there is a little bit of a breeze and it's kind of swinging. That gives a more natural feel to it. And this kind of things is possible to do very easily using Framer motion. If you have to do these things by hand, if you have to hand code these kind of animations, it might take a lot of time and will be error prone. But I'll suggest you take a look at Framer motion for that. Again, if you have a lot of use case for drag and drop, then maybe take a look at React DND. And apart from all these suggestions, I'm sure I would have missed out a lot of other awesome libraries as well. If you know more, please feel free to tweet to me, and then I will retweet that to a larger audience. Then there is again this thing which has been been a bit troublesome area for a lot of React developers, which is the state management of your application. Now we have actually been struggling with managing state throughout the application for a long time, and the React core team also, they just keep coming up with newer ways of doing it, which kind of helps. But I think we are still not there to have a good state management library or technique in place. But from what's available today, you should start looking at mostly these three options. The first thing is the hooks, which was introduced in React 16.8, I guess, which is quite popular these days. Like earlier, all that things that you were using, that you were able to do it using a class-based components using set state. Now you can do the same using function-based components using React hooks. So while we are at it, again, a general recommendation is stick to function components as much as possible if you don't really have to use a class component, not just for using hooks, but it comes with a lot of advantage in terms of tree shaking and transpiler optimizations. So generally, the rule of thumb is whenever you have to maintain a state within a component, you would use the React hooks using use state. Whenever you would want to have any kind of state sharing within two components, let's say if it's just one parent and a child, you would probably just use, you'll just probably just pass the state as props. But if there are multiple levels of parent-child relationship, like for example, the parent has to send that state to its child, then to its child, and to its child before it gets actually used, then it's better to use the React context. And again, you can use the use context hooks for that purpose. And if your application logic is like really complex, like for example, you want to have an application-wide state management in place, or your page is fairly complex, then it's better to use something like use reducer or a Redux library in general. Or if you don't want to use any of this, you can always go for a few of the custom state management libraries. Like one of the popular ones is Mobix. And also there is Rx.js. Now, Rx.js was mostly used in the Angular ecosystem, but a lot of applications like React applications, they have adopted Rx.js as well. The main advantage that it gives you is the reactive management of your states. Like your UI totally becomes reactive to any kind of event that it keeps receiving through the streams. And that's also a very good way of managing your application state, especially if your application has fairly complex business logic. And there is this another library which is quite lightweight and easy to follow, which is called Overmind. Again, Overmind has taken a lot of concepts from something called NGRX, which was again on the Angular side. And if you have worked with NGRX, then you would probably know, you'll find it easier to use Overmind as well. If not, also you can just see how it works. And it gives a very good separation between your presentation and the business logic. And using effects, you can actually keep all your application logic separately, which is very well, it's a very testable piece of code. Which generally we face a lot of problem. Like if you are keeping your application logic within the React components, it's not very easy to test it, right? So yep. So if you're thinking of creating complex applications in productions, then look at these options as well for state management. One rule of thumb is again to not just start with state management right up front, because there is a cost to it, a cost of the payload as well as the cost of development, because you have to set up things, and you have to, once you set up a state management system, all your state actually goes through that. So it's always a good idea to start small, and then when you actually require some kind of a state management within your application, that's when you actually switch to one of these or any other, if you know. Now, again, when you're thinking about your React application in production, there are a few more things that you should be aware about. One is how do you, virtualize your list? Like performance is a major thing that a lot of your clients and customers look forward to. Like you would have seen this in a lot of places. Like if your page is laggy, if it doesn't feel natural, a lot of users would assume that this is not a dependable site. Like, they will not really have that kind of a trust factor for your website. So it's always good that you have good user experience, and to achieve that you have to always target 60 fps, especially if you have animation within your page, or if you have long list of items to be shown. You should make sure that your page is never laggy, like it doesn't get any kind of a lag or jagging. So few of the things that you can that can help you here is one thing is the React virtualized library, which is a very good library for handling hundreds of thousands of items to be shown in a React list. This is especially useful when you're trying to create websites that shows a long list of items, and the user is like fast scrolling, and you want to make sure that there is no lag while they're doing so. And also it's a good option, like to use these two hooks, like the use memo and use callback. Again, go through how these hooks really work. The underlying theory is that if nothing changes within the state of your component, then you can actually keep a copy of your component or the callback method in memory. And instead of trying to recreate or re-render the component again and again, or the recreate the function declaration again and again, your React can actually pick it up from the cache and serve it, which can again speed up things. But like all things performance related, always make sure that you do any kind of performance optimization only when you see that there is a performance lag. Like don't jump onto making performance optimizations from day one, because again there is a lot of cost for performance optimization as well. For example, when you're using use memo, there is a lot of housekeeping work that your library will have to do behind the scene to maintain this cache and do cache invalidation and things like that. So sometimes it might just be easier to just render the component rather than trying to search it in a long list of cache. So if you have like long list of operations, like for example, if you're going through a huge list and doing some kind of calculation, then it's probably good to use a callback. Or if there are long waiting list of tasks, then it's good to go for use memo. But again, use these things only when you profile your page and you see that there is a performance lag, and then you start using these things. And to profile such page, you can use the React developer tools, which are available in most of the browsers. And few more things that can help you out are the Lighthouse and Web Vitals. Okay, sorry for the other two things here. I think I just forgot to remove them from this slide. It was a copy paste mistake. So Semantic and Onsen are not really part of this slide. So Lighthouse and Web Vitals, these are again industry tested tools which can help you analyze how performant your site is. Not just performance related, like Lighthouse has a lot of metrics around accessibility, SEO, performance, best practices and all. And the new set of rules from Google are called Web Vitals. Again, there are a lot of measurable, quantifiable performance metrics that it will create a report for you, and then you can improve those things and check how well you are doing on Web Vitals. Now, one of the reasons I was asking you to go for Next.js, for example, was because it kind of has these things inbuilt. Like it will have inbuilt support to create Web Vitals reports, so you don't have to do these things by hand. Now, you also have to take care of authentication in your application. So now there are various ways of handling authentication. One way would be you use something like an identity as a platform, like Auth0, wherein all your authentication concerns are kind of handled by them, and you just redirect the user to their page. It takes care of allowing or blocking a user, and then once it comes back, then you don't really have to store information about the authentication part of the user. You just store related information related to the profile and your other business logic. And Amazon, and then there are like other options, like Amazon AWS has something called Cognito, or Azure has Active Directory. So they all give you identity as a platform service. So you don't have to think about this by yourselves. And if none of these work for you, then you can always go for custom creating your authentication layer using any of the OAuth protocols, like mostly OAuth 2. But again, keep that as the last option, because creating your own authentication platform is kind of time consuming. You can always take advantage of things which are existing. Now, you also have to, now when you are starting to think of React full stack, you also have to start thinking about the security of your applications. So there are a lot of things that comes under the security banner. We'll not really cover all of those, but the major thing that would concern you a lot of times is scores, especially if you are deploying your application onto production and you have different backends for different, let's say, staging and UAT and production pre-prod environments. There might be coarse settings on those backend APIs, which means that you will not be able to make a call to these API from your local host. And a lot of times, to replicate your production issues on local host, you would want to actually connect to these servers, right? So you can look for a few of the browser extensions that handles codes blocking. Like what it does is basically it just creates a proxy in between, so that all your browser calls go as if they are going from another server, and your backend API servers will actually allow those without blocking them as coarse issues. So that way you can actually connect to any of the staging environments as well from your local host. Then there is these concerns around internationalization. So again, host of these libraries that you can take a look at. If you're using Next.js, it already integrates I18 and Next, which is a fairly straightforward and useful application that you can go for. Even if you're not using Next.js, you can use this library as a separate entity. And then there are other items like React, INTL, which is basically format.js.io, and then Lingui and Rosetta. All of them are pretty much the same thing. Like they just pick up the user's preference from the browser, and then they have support for different local. The way you do it, the API might differ a little bit here and there, but that's pretty much straightforward. One thing that again Next.js supports for us is the international like routing based on internationalization. Like this is something again you would want to be mindful of if you are serving customers around the globe. Like you might want to have separate pages for different regions. Like for example, if I just tell you the difference between Canada and US, we have different metric systems, we have different currencies, and even the language is a little different when it comes to actual spellings and all. So you might actually want to route the user to different pages based upon which region they come from. A lot of regions you might want to provide culture sensitive information based upon the region. So international routing can actually help you with that. Again, this is something that a lot of us miss out, but we should always be mindful of, is to make sure that our site is always accessible. Again, this is something that you don't really think about much when you are creating a small application on the side. But if your application is in production, then this is something that you should definitely be looking at. The React.js documentation has a fairly good list of accessibility. If you want to dig deeper, there are a lot of articles from organizations who deal specifically for making the applications accessible. And this is always a good idea because although the number of users who might need this feature is not as high as the majority of the population, but it's our responsibility as a developer to make sure that our site is usable, like users with any kind of disabilities or any kind of impairment should be able to use the site with as much ease as any other user. And also a lot of SEO will give you a good search engine ranking if your site is accessible. Now, moving on to the backend side of things. Generally, as a full stack developer, you would always want to think, how are you going to create the API server? So the most common option nowadays is basically creating a GraphQL server. If you're creating a GraphQL server, then you have a choice of a lot of different clients that you would want to use. You can go for Apollo client, which is mostly used between communication from a React frontend to the GraphQL backend server. Then there is also Prisma ORM, which basically sits on the backend side. That kind of makes it easier for you to create your backend API. In fact, Next.js has a lot of good support for integrating with Prisma. So if you are using that stack, then again, take a look at this and see how that helps you. A few things which are becoming a lot more popular these days is serverless backend. Like again, even if I create these GraphQL servers and all that by hand, I don't want to be managing these servers. So few of the options that have come up these days is to use serverless backend, for example, by using AWS Lambda or Azure Functions. So you just deploy whatever you need as just functions, and you don't really care about how to manage or deploy this kind of servers in production. So please take a look at how serverless backend works. This is kind of quite upcoming these days, especially if you're a startup or an individual working on projects, you would definitely love it. Now, moving on to the database side of things. Again, you would want to decide what kind of database I would want to have for my application. You have to take a call based on other factors, whether you would want to have a relational database or NoSQL DB. That depends upon a lot of factors of your application. But let's say if you want to go for NoSQL DB, then the most common choices these days are either to go for MongoDB, or if you're using Azure for most of your deployments, then Cosmos DB helps a lot because of seamless integration. If you're using AWS, then go for Dynamo. That also helps a lot if your application is deployed there. But again, the underlying concept is kind of pretty much the same between all these. Now, when it comes to deployment, so this is now one of the major concerns that you'll have to again think about when you are thinking of React application in production as to how do I deploy my servers. The most common things that used to be the case before was in-premise servers. Like every organization would have like huge, rooms filled with network servers where their application would be hosted. But nowadays it doesn't match for the cost of spending on in-premise servers. So most of the organizations and even individuals, they prefer a cloud compute, which are basically called infrastructure as a service. So you can choose between Azure, AWS, Google Cloud, DigitalOcean. You'll find loads of resources online if you are interested to see how infrastructure as a service works. The underlying fundamental is that you'll be given a virtual machine, and then you manage that virtual machine, and then deploy your application and any kind of dependencies that you want on that platform. But if you don't really want to manage these virtual machines, then the next level up is platform as a service, wherein you just have to provide the link to your source control, like GitHub or Bitbucket or any other source control. And these platforms, they will auto-deploy your application. They will manage the servers. They will manage all the downtime, the building part of it, everything, and they'll be taken care of. So there are offers from Heroku, Netlify, Vercel. So Vercel is, if you're using Next.js, it has very good support for that. Then there is OpenShift, and there is Cloud Foundry, and there are lots of more that you can check online. And then there are these serverless backends that we lightly touched upon just in the previous slide. Like you can, if you don't even want to go for platform as a service, you can just create your functions, especially on the backend side, and deploy them as Lambda or functions on Azure. Okay, keeping the time in check, I'll probably go a little fast on my remaining slides. We still have a bunch of those to go for. Okay, so now the next thing that you'll be concerned about is how do I do analytics of my site? Like, okay, my site is deployed onto production. Like, how do I know how the users are working with my site? So the major options that you will have is Google Analytics or application insights from Microsoft. One thing that I like about application insights is that it allows you to do an end-to-end analysis of any request, like starting from when a user clicks on a button, what all logs were created on the front end, when it jumps from front end to the back end, what kind of calls were being made. Let's say if it's a GraphQL query, what kind of a GraphQL query was being made. And then once it reaches the back end side, which server did it hit? Are there any server logs there? Which database did it hit? What kind of data was written from there and back to the user? So you can see a request entirely from end to end, and that can actually help you debug a lot of issues. And then a mixed panel is a very good option. Plausible is a good option, and Datadog is also quite used a lot. Then another aspect of analytics is the UX part of it. Like you would want to see, okay, these are how my request flows, and if there are any errors in the request. But how about the UX of my site? Which buttons are the users mostly clicking? Which features are the users mostly spending time on? To check those, you can see something like mouse flow or Hotjar. So you can integrate this with your application to see the user behavior on your pages. Then there is performance monitoring. For that, you can use something like Sentry or LogRocket. So for example, Sentry is specifically designed to do any kind of analysis around the exceptions which are thrown in your application. So you can do any kind of performance or live monitoring there. Then going on to SEO, SEO is a different ballgame altogether. You have to spend a lot of time to understand how SEO works to make sure that users visit your site, because when you're thinking about your application in production, most users, they will not really type your address on the browser and come. They'll actually search for something, and if they find your site in the list of searches, then they will probably reach you. So Google, in that case, has the largest share in terms of SEO. So you can go through this link on to see how you can make your search, site searchable on Google. Bing also has fairly large market share in terms of SEO, and there are documents around how you can do it. And I suggest you kind of target all of them. Like, don't just target one over the other, because you never know where your users are going to come from. And then if you want a good read about SEO, there is this link called learningseo.io, which has a lot of good insights about SEO. Then there is image caching. You would want to make sure that for your application in production, generally image loading takes away a lot of time. You would want to make sure that you're not loading a bigger image for a smaller viewport kind of thing. So these kind of things are very well handled using some CDN providers like Imagix. Or otherwise, you can go for any of the cloud solutions, for example, AWS S3 and Azure Blobs and all. Then you also need to think about A/B testing in your application. So, for example, whenever you're launching a new feature, you would want to know how is your users' reaction. Like, are they still happy with the old feature, or are they happy with the new features? So for that, it's always a good idea to split your deployment and send half of your pages to one set of users and half of it to other set of users. And most of the cloud offerings, they have support for A/B testing. For example, in Azure, you have experiments that you can do using your app servers. And there are a few specific services like Optimizely that can also help you to do A/B testing. And or otherwise.
I'm sorry, Civic. Yeah, we run out of time a little bit, unfortunately. Yeah. I'm sorry I have to disturb you, because yeah, your presentation is really interesting. So many tooling around, full stack development. That's really, really great. And yeah, you're almost done.
I was actually on the last slide.
So close.
Yeah.
Very sorry for disturbing, but yes, we need to go to the end, unfortunately. So maybe let's fit with just one question, okay? Because we need to move to the other presentation. So yeah, there were a lot of questions from our observers. Thank you for all of them. We unfortunately cannot answer on all of them, but yeah, just catch up Civic after the presentation. I hope he will respond to you. But let's focus on one question. So, do you have an experience with Bootstrap Material Design UI Kit? What do you think of such complex user interface libraries? Do you think it makes sense to use them in the project, or can we just use standard solutions? What's your opinion on that?
Yeah, I'll always go for standard solutions because, first of all, the standard solutions, they have been tested very well in the market. And also, let's say if a new developer is ramping up on the project, for them to know how Fluent UI works or Material UI works is always easier than something, than another system that they have not heard about. Bootstrap, although was good, but like, yeah, for example, Bootstrap MD is not that well heard of, right? So if you're using something like that, unless there is a real advantage that you're getting by using these libraries, like something very custom that they have done, which is useful to your application, I will say stick to the standard design systems and UI libraries.
Great. Thanks for the answer, and thank you for the great presentation. Again, you did a great job, very interesting topic. And thank you for your attention, and yes, see you on the next events. Thank you, Civic.
Sure, yeah, thanks, Tommy. It was absolutely my pleasure to be a part of this event. So if anybody has any more questions, I had shown my Twitter account, like it's at @SovicBasu. You can contact me over Twitter, and I'll get back to you there.
Okay, thank you. Thank you. Have a great day, and let's see you soon. So,
yeah,
guys.
Have a good day. Bye.
Bye-bye. Guys, now it's time to next presentation. Another great speaker, Clement Hong. Let me introduce him and add to the stream. Hello, Clement. How are you?
Hey, how's it going? Can you hear me okay?
Good. Everything's fine on my end. How about you?
Doing well in New York today. So hi from New
York.
Wow.
New York, Vancouver, and Holland Wood. Awesome. I really love the new remote world, we can connect so easily. So do you feel a little bit stressed about the presentation, or?
Oh, I feel stressed every single time I present.
Okay, come on. Stress can be motivating, so yeah, finger crossed. I'm sure everything will go fine. So you have very interesting topic, which is the 10 times per request, and I'm wondering what's inside. So yeah, the stage is yours. Do you have a presentation? Yep, it's here. So yeah, the stage is yours. I'm going to turn off myself now, and yeah, good luck.
Awesome, thank you. All right, so hello everyone. I hope everyone's day is going well. I'm super excited to be here today to talk about what I think makes a good pull request or a code review or whatever you want to call it. So feel free to follow along. My slides are available at climbing.ninja, 10x pull request. And yeah, once you get, I'll give a few seconds if you want to type that in. But let's a bit about me. So who am I? So I've been in the industry for a while now. To be specific, like 9 different tech companies, maybe a bit too many. Some include my own startup, Facebook, which is now Meta, Credit Karma, and now I'm at Airtable. And I'm specialized in JavaScript and specifically React and Node backends. And this is my second time speaking at a conference, also by Geekle. Last time we ended around 20 minutes early, so I'm really hoping that this time I do a little bit better. And let me know if I'm going a little bit too fast, and I'll try to slow down. Yeah, and as a side note, this presentation was made with Git and GIF in mind, so since that's what I'm comfortable with. The concepts should still generally be the same though, despite what code collaboration tool you use. And also, like as a note, this presentation is a little bit less on the technical side, but more like workflow focused. So without any further ado, let's start with what pull requests look like in the wild. They come in many different shapes and sizes. Some with 1 million comments. Some that never make it in. Some with very little description. Some with no description. And some that have essays as a description. So what and why do we write pull requests? And the answer to this is usually it comes in the form of a code diff that's aimed to solve a problem, like something like improving documentation, implementing a feature, writing a bug fix. And like these things all somehow increase the value of your business. And the second reason of it is to get other people's eyes on your code change. So this is really good for catching any bugs you may have missed. Maybe your viewers have like more business context than you. Maybe they have more technical context. They're more specialized in a particular part of the code base. So by getting these different eyes like on your code, then it's good for knowledge sharing as well as improving the quality of your request as a whole. A Chinese proverb that I really like is, one chopstick can easily be broken, while a bundle of chopsticks is hard to break. So pull requests kind of fulfill the same need. There's much higher likelihood of catching bugs in production or like wrong designs in the pull request space if you have a lot of eyes on it compared to if you were just a solo developer and pushing code up yourself. And so I just described like what some of the benefits of pull requests are, but despite this, there's a lot of problems that I see when actually using pull requests like in the industry. So for one, code review is generally seen as a bottleneck. And in here I have a diagram showing like what this flow kind of looks like. The developer generally writes some code, then they will submit it for code review in a PR, and then a reviewer will take some time to look at the code eventually. They may leave some feedback, and after that, the writer will get back to it, review the feedback, and make some changes, and wait for another like loop for the reviewers to look at the code again. And this will kind of like go on and on for a little bit, and sometimes this takes like weeks even. Just imagine like having your code up for like, who knows, like a 20-line change or something, and maybe it taking weeks to merge in. Like that's horrible and that's frustrating. So that's one issue. And the second one is even like with pull requests, sometimes the review quality is still poor. We still have bugs and mistakes that make into production very easily, very regularly. And also the code quality is perhaps still not all that great, especially like when your pull requests are really slow. And this all has a negative business impact. And I think that one of the, like what leads to bad code reviews really is like it really boils down to slowness. the fact that human memory is not all that great, and we only have so many things that we can keep in our head at once. I think the number is like 7 or something objects that we can keep in our head. So to like really elaborate, like when your code, like with slow code reviews, this gets worse because the longer your like branch is in queue, like you're waiting for your branch, your code to get updated, it's just kind of like sitting there being stale, and you have to constantly keep it up to date by merging in whatever's like unstable or like main, and then keeping your branch up to date will require constant work. And then like in addition to above, because you have one branch that's blocked, you might just think, okay, I'll just start some other work while waiting for code review. And then now you'll have a bunch of work in progress branches and lots more context switching throughout all these different branches. And another thing is, context eventually gets forgotten. If you have a branch that you opened up for pull requests maybe a week ago, then a week later, that might not be the freshest thing in your mind anymore. When someone finally gets to it, like 10 days later, and asks the question, is it really in the top of your mind? No, you might have to read your description again, try to remember what that branch was even about before, explaining yourself. And that it's like kind of like RAM and cold storage. Like after you like leave it for a bit, it's not really up here anymore. And, you just want, that just leads to like a compounding effect of slowness. And, because of slower pull requests, your changes get into production slower, and then you just have less of a competitive edge for your company in terms of like what you're putting out. And finally, your code's not getting in. What's the incentive or motivation in working faster? It's just the team morale goes down as a whole. So tons of issues. How can we improve? And so I think the main thing is that we want to decrease the time it takes to get our code reviewed. And we also want it reviewed with greater quality. And changes need to happen at every part of the process, at the pull request writing level, at the reviewer level, and also at the team cultural level. We really want to optimize the process in like such a way that like both writers and reviewers feel like less friction when they're writing and reviewing PRs. So from a writer's perspective, how can we improve? And the high-level themes that I'll be kind of going into are making things readable, referenceable, and automated. So what does readable mean? This is how hard is your pull request to digest? Do you need to be really smart to understand the PR, or can like just anyone read the PR and get like some base level of understanding from it? Does it have all the context needed for readers to understand? Like, is it like, in order to understand the PR, is it someone that you have like needs to work very closely with you, or can they just look at the PR and be able to provide some input? And also, like, is your PR short and focused? Is it very focused on a specific problem? Referenceable. So once you have your PR, you merge it in later, or you might want to refer to it again at some point in time. Is it easy to search later via like keywords? Do you tag it with some specific record or like Jira ticket number? When you're navigating code, like, and you find some weird thing in the code, is it easy to trace back to a specific pull request and like find out, all the reasons for why it was implemented in a certain way? And finally, like, we want this to be as automated as possible. Pull requests, we really don't want to like have a bunch of manual developer processes and like opinions. The less that we leave towards, manual work, the less friction there will be, and it's just less of a pain for everyone. So this is also things like, running builds, linting, tests, deploying previews, stuff like that. So starting with the anatomy of a good pull request from the writer side, there's going to be, keeping your scope focused, having a good title, having a well thought out description, putting some visuals in there if applicable, having tests, your commit history, code quality, CI, selecting the right reviewers, and also how do you respond to feedback. And I'll be going actually into every single one of these today, and I'm really aiming for breadth rather than depth here. I'm very open to like, and go into any more depth in any specific one of these in the questions later. So the first thing I mentioned is, knowing what type your pull request is. Different pull request types have different needs. How much detail you want to give into them, how much time you want to invest into writing the test descriptions, etc. So some different example types would be things like like a feature, like a new feature that you're implementing? Are you fixing a bug? Is this a proof of concept for something? Are you refactoring? Are you just updating the documentation? Is this an emergency hotfix that is fixing like a very bad bug in production? So a rule of thumb that I have is the time that you spend on a PR, like both reviewer and writer side, is proportional to its risk over urgency. So the more risk in a pull request, the more time that you should spend writing it and reviewing it. The more urgency that is needed like for this pull request, then the less time you spend writing it and the less time you spend reviewing it, like by necessity. So for example, an emergency hotfix pull request generally has a pretty low risk, but very high urgency. And so we don't exactly want to spend a day, writing out the description, talking about like all the technical plans we made for it, going through 20 review cycles just to get it in. You probably want to get it in ASAP and explain and justify later when things are a bit more stable. And alternatively, a feature request, like proof of concept, has a bit more of a medium risk level, lower urgency, and we can spend a bit more time in this. As a writer, you can spend a bit more time. As a reviewer, you can take a bit more time to ensure that best practices are followed, the design is correct, and so on and so forth. So tailor your effort and detail spent in each pull request accordingly, and really keep in mind like what type of pull request it is and what kind of like characteristics it has in terms of how you spend your time as we go on for the other parts of the PR. And it's a little funny image I included. As risk goes up, so does the time to review. So next I want to talk about the scope of the PR. What is the smallest meaningful chunk of work that you can put into PR? That should be what the scope of your PR is. Keep your changes focused, as smaller PRs tend to have lower risk and also get reviewed faster. Like just from the reviewer standpoint, it's like pretty easy to review. So some tips for this is splitting big problems into multiple subproblems. Let's say we have like a giant feature. Do we really need one like giant pull request for that? Usually the answer is no. You can split it into subproblems, and this makes each one more individually testable. Your solution is more modular. When you break it down to blocks in your head, it's also like more easy to reason about. And I can tell you for a fact that I hate reviewing 5,000 line pull requests. So yeah, and also with a smaller pull request, you get things in main. You can merge things into main earlier, and if needed, just put things behind the feature flag to prevent any users from seeing them. You diverge less from the main branch, and you won't have to deal with stale branches and like constantly keeping things up to date. So next is punting unnecessary changes. So when a reviewer or even like yourself, when you like start working on some kind of task and the scope creeps up, it's like let's say you're building out like some kind of like comments loading section. Do you want to support pagination, lazy loading? Like any small piece of work can explode like infinitely if you think about it hard enough. So really, like what you want to question is, do you need this in this pull request, or can you punt that work for something for a later time? And yeah, if it doesn't need to be in the PR, put in a different one. And finally, if it really needs to be big for that work to be meaningful, then share your approach early, and this prevents big surprises later on when it might be too late or like too costly to change anything. And the example that I'll be referring to for a lot of this presentation is going to be this very contrived Clemstagram app based on the popular Instagram app for sharing photos. And let's say that in one specific like ticket that I have, I want to build out the details page for Clemstagram, which includes showing photos, some controls like commenting, sharing, a description, and then a comment section. Would I build this all in one go in one giant pull request? Probably not. So my first thought would be, okay, let's break this up into blocks. How can we split it up? And it would be something like, maybe I first create a PR for setting up the routing and scaffolding up the page. And a second PR, I would maybe implement some basic image and description functionality. In a third pull request, I might implement some likes functionality. And then I would implement comments functionality, followed by some more refinements and responsiveness. We can really go infinitely granular. And like, for example, instead of just implementing likes functionality in one PR, I might say one PR might be for, a peer like a renderer, like just the rendering portion of it, followed by one that actually connects it to the backend. Like we can go infinitely granular, but there just comes to a point where it doesn't make any more sense. Like you won't be, the cost benefit analysis will be like, okay, you're spending more time doing all the PR process compared to the benefit it gives you. So find that sweet spot where change is meaningful and limited in scope. And one way to think of it is art is never finished, only abandoned, by Leonardo da Vinci. And similarly, like your software would never be perfect or finished, only released. So break your work into chunks, and that way, you know, when the time comes, you have some cutoff point. Thirdly, we want to choose a very precise title for our pull request. A one-liner about what the PR does, make it explicit and obvious. So a vague title like fixes a bug, this can be left, this has so much space for interpretation, ambiguity. We really want it to be like very obvious what it does. And ticket numbers in a pull request title, and that's okay too. They're good for filtering and finding specific pull requests, but just remember that this adds a little bit to the verbosity of your title, and it could be another piece of process that it adds friction to developers. So like, for example, a place I worked at before had 10 different emojis for different statuses, like, oh, here's a flower for feature request. Here's like a Spark post for cleanup. Like, and then when there's like 10 things that, you know, developer needs to reference to like even know what emoji to put up, maybe that's the piece of process that you shouldn't have, since it's just going to add pain. So here's some example titles. Fix menu bug, kind of ambiguous. What's the bug? What menu are we referring to? And better thing to write might be handle mobile responsiveness issue where the menu is cut off. I also put in a status of fix here with a ticket of like CM123, which, you know, a reviewer can visit on like Jira or some whatever like ticketing platform that they use to, you know, find more context to this issue, maybe find some screenshots or whatnot. Another title that's kind of bad is Feat CM000 refactor comments code. This is convention just for the sake of it. Like, what is CM000? Are we adding any value to a reviewer? Not really. So better one might be just one, like the title could be split up comments component into small components. Now we're describing what the PR is doing instead of just being vague and then putting a like non-existent ticket into it. And third title is Feat CM456, add detailed page route, add feature flag, support basic skeleton, add some Cypress tests connected to the GraphQL backend. I mean, now this is being very, very specific on what the pull request is doing, but it's also very noisy. What's the main point of this PR? Like, can a lot of this example be moved into the description? Technology-specific things, like maybe this is already implicit context that everyone from your company knows. So it's a bit too long. It's probably going to get truncated by GitHub. Yeah, more for the description. So maybe just shorten it to scaffold a detail page behind the feature flag. And that gets you like 80% of what you were trying to say up there, but like in a much more digestible way. So next, we'll go into the description. And this is the first thing that a reviewer is going to look at after reading the title of your PR. And the way I usually like to approach this is using hamburger style. We start off a little bit more broad, go into specific details before ending off a bit broad again. So for example, we start off with a very high-level summary of the pull request, moving into more specific context, in-depth dive into any technological decisions if needed. We link to relevant like product requirements, technical docs, like anything that might be relevant. We can document some of the risks that our PR brings here and a test plan. And then finally, we can end off on a checklist, maybe something like, do you go over a style guide? Do you add tests? Do you add documentation? All this can kind of be encapsulated into a template, but just make sure you don't go too far with it. It's function over form. If you remember that this description is going to be read by humans, and if you're like putting a really, really long, complex description out there, you're just creating more work for a reviewer. You want to provide them with just enough to be able to have the context they need to review your PR with quality. So here's an example I have for more Clemstogram functionality, specifically to add read and write comment support to the details page under the show comments feature flag. So here, that was the high-level one-liner. Then I go into context. So here I link to a specific Jira ticket. I link to a specific PRD. I mentioned that there's a dependent pull request that needs to be merged in for this to work. Before I go into screenshots, I document some of the risks, saying that it's not too bad since there's a feature flag disabling this in production. Here's a test plan on how to enable the feature, and some upcoming work later will be to have real-time loading of comments. So just showing a bit of like how I'm splitting it out as well. So next, we have tests. So tests are a really good place for reviewers to start reviewing the code. Outside of the usual benefits of regressions, it also tends to describe the behavior of the code. So for example, when you're writing UI pieces, you might have things like storybook components and like snapshot tests, unit tests that describe like how the component behaves. If you're writing tests for a specific like module, such as like data fetcher, you'll know like exactly what the capabilities of this module is, like what are the inputs it takes, what are the outputs that gives back. It gives you kind of clues on like when you're actually reading through the actual code diff, what you should be looking for. So some examples of like good tests can be something like it should render the comment section. It should display the comment section when show comments is enabled. It should add comment to comments list after clicking submit. It should allow empty input. So these things, like, for example, when I read something like it should not allow empty input, I know that somewhere in the code diff, there's going to be some code that has validation. So I can it clues me into like, look at that code. When I see something like it should render the comment section, if I dig a bit into the test, I will see exactly what component is being rendered. So again, this provides me like an entry point to be like, okay, what's being imported? Maybe I should start looking at the code here because it's like an entry point to the component. And it gives like a beginning point for reviewers to like start reviewing your code. And just remember, tests aren't free, they take time to run. This can be a whole other talk, but yeah, just write some basic tests and think about that, like it will document where to begin for reviewers, and it can also like regress basic functionality, but don't go too overboard because at some point diminishing returns. So next we have commit history. We really want this to tell a story. What I mean by this is if you read a commit history, we really want like there should be some train of thought that it's following. So in this case, for like, again, writing and reading comments for Clemstagram, my commit history goes something like add some mocks for testing, and then adding a basic working renderer for comments before we go into adding the comment editor and handling invalid input, improving some styling, connecting to the backend, fixing a bug, adding some unit tests. So this kind of like having it broken out this way, as a reviewer reading your code diff, it really lets them like kind of follow your chain of thought. When you add new, like when they after their first iteration of reviewing the code, when you push more comments in, it's very easy. More commits in, it's very easy for them to just kind of follow. What did you change exactly? Like what's addressing what comment? And it's just like having this chain of thought just puts it in units of work that is bigger than like just one big blob. And we can keep it clean using git add patch or git add interactive. This lets you select individual lines at once or like specific hunks of your code that you want to commit, or like just use a GUI like git cracking or source tree. Makes this very easy to do. So yeah, having a really clean commit history is very helpful to the reviewer while the code review is actually in progress. It's like having a bookmark in a book. They will know where to pick up after reviewing the first time and you push more in. But after you have all the approvals you need, feel free to squash it, rebase interactive, clean up your history however you like, do whatever you want after the review is done. So speeding through, next is writing high quality code. That's one of those easier said than done things. But like for real, no one hates clean, understandable code, and to get to writing good code doesn't come naturally, but just really focus on, after you write a PR, if you have a lot of comments, focus on what feedback did you get? When you read this code yourself, what's hard about it? What are some of the differences between your code that you write and maybe like better code that you've read before? Analyze and improve. There's tons of resources on this, YouTube videos, style guides, courses. And one of the classes I like reading is Clean Code by Robert C. Martin. And once you have high quality code, it makes your reviewers' life a lot easier as well. So some tips for this is just, if you have some hacks in your code, if you really must have a hack, add a comment explaining why you have the hack and what's happening in the hack. If you have a very complex piece of code in there, and that can be showcased better by some external documentation, feel free to link it into your code base directly. And just avoid unnecessary complexity. Like, if you have something like this, good luck getting it in. Now, setting up continuous integration isn't exactly a thing for the writers per se, but it's a one-time investment that can help a lot for reviewers. So this would be things like Circle CI, Prettier, running just tests automatically, auto formatting via ESLint, linting. So all these things set up in your Circle CI. It's a one-time investment that you do once, and then it saves a lot of work. So for example, if some test fails or some linting fails, then reviewers, like when they filter through like pull requests that they should review, maybe they'll know that this PR is in an incomplete state. There's a bit more work to be done here before they invest too much time into looking into it. Next, we want to choose the right reviewers. So who should be responsible for reviewing the code? Is it your team? Is it like, do we need a security reviewer? And you can often use git blame or git log to find like git log for a specific file to see like who worked on this file in the past and really find the right like owners to add to review. And something like GitHub code owners or Palantir's policy bot can also help with this. Don't be afraid to add more reviewers than needed. The worst that happens is that they unsubscribe. And finally, proper etiquette. This is something that is often overlooked, but pretty important. So once you receive feedback for your pull requests, one thing to remember is that it takes a lot of time and effort to properly grok a PR and review it. So, just have a positive mindset and be open to the suggested change that they have, respond to all the comments, and consider following up offline if the thread gets too long, instead of having a person versus person comment war. So like one thing I know is that I tend to see, like, especially because you can't see other people's faces in person in a pull request or in comments specifically, sometimes this can like lead to like things appear meaner than they sound, than intended, and can like lead to resentment depending on how you deal with it. So just be mindful of that and assume the best intentions. So an example of this is a reviewer says the design for the system is fundamentally flawed. You should have done X, Y, and Z. Assume, don't get defensive on this, and maybe it is possible to do X, Y, and Z. If it's too complex for you, ask for help. It's a team effort, and follow up offline if you think it's easier that way. So a sample response might be thanking them for the feedback. Unfortunately, we have some constraints here, and just ask them, like, do they have any ideas that work for these constraints? Next, we have the reviewer side. So for the reviewer, we really want to know what your role is when you're reviewing a PR. Are you familiar with the business context? Are you a tech lead responsible for the design? Are you just a peer with general technology like comments? Are you the only person that's going to be capable of a very high quality review? So just understanding where you are can help you understand like how much time you should spend on the PR, time box appropriately. Remember that time spent on the PR is proportional to risk over urgency. And so as a reviewer, we want to first build context. So these are some of the tips that work for me. One is just really first starting with the description and title. Go over the high level things first. You can feel free to like put off some of the deeper dives discussions after you go into the code. Look into some of the tests to describe the behaviors before moving on, and you can kind of reference the deeper parts of the description as well as the code at the same time. Keep focused. So limit the scope of the review to what the PR is addressing. So just because something's in a similar file, like don't go off topic. So for example, someone had a PR to like update the padding somewhere, but you think that like the way that styling is implemented in this file as a whole is like bad. Like maybe you would say something like, oh, can we use emotion instead? Like, this leaves them in an awkward spot because maybe they don't have the bandwidth for that. You don't consider the existing context of the decision to like not use that. There's basically a lot more that goes into this. So maybe a better way to word it would be styling, like writing a comment such as styling in React using style attribute is not recommended. You create a backlog item for them and say this is something that we can look into later. But basically, it gives an opportunity to triage, do some research, instead of pushing the responsibility into the writer to like do something right away in the PR, which leads to like more headaches, bigger friction, and overall like a longer time with this PR being spent in review. Remember, software is never finished. And similarly to earlier when I mentioned receiving feedback, as a reviewer, you also want to provide feedback in a way that is, digestible for the writer. So what you're looking for generally is like functional defects, corner cases, conventions, and best practices. And things tend to sound meaner when written. So without any natural clues such as like your body language or your facial expression or tone, the writer is going to be reading your comments. So for example, if you say something like the variable name is not very readable, your expectation might be the writer goes like, oh, okay, that makes sense. Let me change it. But in reality, they might be offended. So be considerate, thoughtful on what kind of language you use. Avoid saying like you when you're writing your comments. Kind of like target the code instead. Give some guidance on what change you might want to see. Explain the reasons for your feedback, and also feel free to ask questions. So an example is the variable name is not very readable. And instead, you can be a bit more specific with reasons. I find it hard to understand what map it's referring to without reading the rest of the function. What do you think about renaming it to user details? So you're asking a question instead of saying, do this. Another example is the comment, you forgot to clean up the event listeners after the component announce. A better way to phrase this might be, can we remove the event listener after the component announce? It will help to avoid memory leaks. So again, you're asking a question and giving a reason. Finally, give appreciation. If they did something really nice, thank them. Thanks for removing all of that code from the comment section module. It really helps to like balance some of these between some of the more critical feedback. As a reviewer, you might get spammed with notifications. So really, we want it to be manageable and watch the repos that are relevant to you. And finally, pull request is a team effort. So number one, make sure the team is aligned with it. As a single code reviewer and a single coder, there's only so much you can do to really reap the benefits of efficient code reviews. You want to really discuss this culture with everyone on your team and make sure they're all aligned on what the purpose is of the pull request and the fact that you want to speed it up. Accountability. So we call that longer time in queues because more content is forgotten, more bugs, more pain keeping up to date, more blockers on downstream PRs. So what you want to do is keep everyone accountable on how long a pull request should be left in the review queue. Track this. If it's hard to hit your number, then revisit some of the topics in this talk and see if there's something that you can improve on. So measure the time it takes to get a PR in, and analyze what went on and make improvements if necessary. Trust is important as well. So the less trust you have on team, the more guardrails you need. So one thing is just try to build trust on the team, and you can do this by consistent success, having more knowledge shares, setting a high bar for a team, and most importantly, transparency. Transparency is pushing early, pushing often, reviewing early, reviewing often. And if you have a large and risky change, bring it up with the team ASAP. No one likes surprises. And this allows you to be more flexible to pivot before too much time is invested. So that's all I have. Yeah, so closing remarks in summary, we should be aligned on the purpose of a pull request. Everyone is working together to help get a piece of code that solves a problem in the company in a very timely way with the highest quality possible. Remember that a pull request structure is not one size fits all. Like what I discussed in this PR, my personal observations, but really experiment with the things that you feel can be improved and see how it works for you and your team. Finally, educate you and your team on good pull request culture. It might take some time, but I promise it'll be worth it. And that's all I have. Share this presentation with someone who hates code reviews. Thanks for having me, and I'll be open for questions. Yeah.
Wow, thank you, Clement. Yes, such a great presentation. Sorry.
I blasted through that because I was like, oh no, I think I passed the 30-minute mark.
No, that's fine. We had a small glitch, so yeah, that's okay. The presentation was very interesting. You had a lot of experience working for small startups and even big companies. So from small to big companies like, Facebook, Credit Karma, now Airtable. So I believe that your presentation is based on a lot of experience from working with the different teams. So yeah, it was very interesting. I would love to hear more about standards, keeping good pull requests, keeping the good flow, a good process of checking and merging things in our repository. It's all make really great sense. And yes, you have totally right. All these things makes matter. I mean, all of these things has related on how we work in team and how fast we can deliver stuff. So it's really important to keep the good quality of the whole process around creating the pull request and checking it out. We have a few questions. I know that Ivan is, and the next guest is waiting for the presentation. So get us go through that pretty fast. So the first question: how to keep the good convention for naming commits. So how it should look like in the repository history, how to deal with that.
Gotcha. So in the history. So one thing is I don't have a very strong opinion on actually how commits are actually. So a few things. As I mentioned, we want commits to be referenceable, right? Or more specifically, I wanted pull requests to be referenceable, right? And so in that case, what I see some teams doing is they have let's say maybe in the actual pull request prod phase, the commit history gets really long, messy, but it tells a story. Before we merge it in, there's an option to rebase interactively, get rebase-i, or you can squash it all up and just make it one commit. So those are both options to make your Git history cleaner when you want to view it later. But in general, that also has its downsides. For example, in terms of Git workflows, once you squash that commit, sometimes the reconciliation between two different things is not that great. So I'll say this is, for me, it's just see what your team does. Discuss with your team which trade-offs. Do you want a more readable history, or do you value your process in terms of merging in more? What's the workflow exactly, and weigh these. And I think both of them are both a squash and merge workflow and a normal merge workflow is very valid. But the main thing is in your, again, in the commit itself though, just try to describe what it's doing. That's the main thing. Maybe add a ticket in there.
Okay, great. Thanks for the answer. Unfortunately, the rest of the questions need to be asked on your Twitter or LinkedIn because we need to move to the other presentation. Thank you for the valuable information. It was great to hear about all of this interesting stuff, and I wish you a great day or night. What time of the day is in your?
It's afternoon, so
afternoon.
Still have some day left in me. Yeah.
Yes, so I wish you a great evening and see you soon. Thank you.
Thanks for having me. Have a good one.
Take care. Bye-bye. Okay, guys. Now it's time to say hi to the next guest. He is a co-founder of Moralis, and he came with a very, very interesting topic about building Ethereum apps with React. So, ladies and gentlemen, now it's time to introduce our next speaker. And let me click here. Ivan, nice to see you. Hello, how are you?
I'm good. Thanks, Tommy. Thanks for the introduction. Yeah, good to be here. And I see I have approximately 45 minutes or so. I see that it needs to be before 12 hours. So let's start. You can share my screen. And today we're going to discuss cryptocurrency programming, how to build decentralized applications, how to build applications on
Sorry,
Ethereum.
Ivan, you did not
sorry. Let's see. There you go. Yeah, now.
Okay.
Perfect. So today we're going to discuss how to build apps on Ethereum, on Avalanche, on Binance, and really on any cryptocurrency network. And we will start by first talking very briefly what that is. And it's all about this new evolution of the web, which is Web 3. And Web 3, you can think of it in a way as the biggest financial sandbox for developers. What do we mean by that? Well, imagine you want to build something in the finance space. You quickly realize you cannot do anything. You want to build some kind of subscription service. Well, you cannot do it yourself. You need to use Stripe or PayPal or something. You cannot do anything yourself. You want to build some kind of exchange where people can trade things back and forth. You cannot do it. So all the time when we're thinking about Web 2, this version of the internet where we don't have crypto, where we don't have blockchain, you and I, normal developers using normal programming languages, we cannot do anything in finance. And this radically now is changing with Web 3, where we do have blockchain, when we do have tokens, we have assets, we have NFTs, and so on and so forth. And we can now build our own financial applications straight from the bedroom. I mean, literally, you can build exchanges, you can build NFT marketplaces, you can build wallets. I will soon show you some concrete examples. And that's why we're saying that this is the biggest financial sandbox for developers, that you and I, we can have this development sandbox where we can experiment, we can literally program money, because cryptocurrencies is digital money, it's programmable digital money that you and I can go ahead and program. And this was completely impossible before Bitcoin, before Ethereum, and so on and so forth. So now that we have defined Web 3, we know what we're talking about. Let's speak about some examples. Of course, this year, if you've been following tech news, if you've been following this whole crypto industry, you know that we've seen a lot of interest. We do see, for example, NFTs blowing up a lot, and NFTs are these collectibles on the blockchain where you can have a digital token in your cryptocurrency wallet. You can trade it. Other people can trade it. You can create your own tokens and so forth. We're redefining this notion of art as these digital assets, they are selling for a lot of money, some of them. Of course, there are also many garbage ones, but it's not deniable the fact that there is a lot of new interest in this way of doing art. There's also Uniswap doing billions and billions of transactions, and Uniswap is basically an exchange that is decentralized, where you and I, we can trade different tokens back and forth without any central entity, without any central bank or central company or like some kind of PayPal or Stripe in between. We have other protocols like Aave, where you can lend assets and you can lend out assets and you can borrow out assets back and forth. We have OpenSea for trading NFTs and so forth. So there are many different ways, many different use cases, many different niches where you and I, from our bedroom, we can start building and we can start programming money. And this is very, very important. And let's look at history. How did we get here? Well, it all started with Bitcoin. And Bitcoin is very simple because you can only send and receive assets. I mean, that's the whole thing. You can send Bitcoin, you can hold it, you can receive it, you can send it to someone else. That's basically all use case. But then people were thinking, why don't we add more programmability? Maybe I want to program my cryptocurrencies to do something that is completely special to my use case. Maybe I have a use case where I want to lend it out, I want to earn interest. Why can I not program it? So since then, we have other cryptocurrencies like Ethereum, like Binance Chain, Polygon, and so on and so forth, where you can actually program. You use simple programming languages that I will show you how to use in order to program the money flows and tell your money what to do basically through code. All right. And this is the mind-blowing thing. This is where the brain explodes, that you can literally program money now and it is running as an internet protocol. That's why you can do it from your home. Just like you can use HTTP from your home, you don't need anyone's permission. You can use Ethereum from your home, you don't need anyone's permission. You can use Aave, which is this lending market, money market for lending from home, because it's a protocol. So always we're now speaking about money as a protocol. that anyone can build upon, anyone can access, anyone can use. And of course, in this speech, I will be telling you how to program it and how to program it with React, because it's a React conference. I will show you specific libraries, specific boilerplate projects, specific tools, specific utilities, so you can go and you can program this already yourself right this evening. Now, the first thing we have to understand is that when we're speaking about this cryptocurrency blockchain apps, we're speaking about decentralized applications, because just like Bitcoin, no one single entity is running it. The same thing is with all these other use cases. They're all peer-to-peer. It's kind of like email, nobody owns email. It's all peer-to-peer. And in crypto, you can think of it kind of like that as well, that it's kind of like email, but it's money, that you and I, we can send money to each other. We can program money, and we can build apps on top of this. So apps, traditional apps, when you're building your social media, some kind of recipe app you're building, normally when you're using React, normally you have a server. The server has database. The server has an API, and you give the data to your app. Now with crypto, with blockchain, we have dApps, decentralized apps. Also, you may have heard this notion of DeFi. DeFi is decentralized finance. I mean, DeFi is this whole notion that you and I can program our own financial stack using open protocols like Ethereum, like Polygon, like Bitcoin, and so on and so forth. So now that we know dApps, we know what Web3 is, we've seen some use cases, let's speak about more technically how it works. So technically, at the end of the day, we still need a website. Most of these financial applications on the blockchain, they're still a website. They're still websites. They're still served through a browser. So we need to have an interface between the front end, which doesn't go anywhere. And of course, here's where React comes in. You still need to use something like React for the front end. And then we need to have a way to speak to the blockchain. And this is where you have something like MetaMask. So MetaMask plugin, as you can see here, it is a wallet, a cryptocurrency wallet you can install in your browser. And with this wallet, this is your identity. This is like your password. Instead of using password and email, you use MetaMask, which is basically a wallet that holds your private keys, which is your identity when you are interacting with all of these DeFi, decentralized finance, decentralized applications. And through that, then you can speak to the blockchain. This is not a speech about how blockchain works. You don't need to know how blockchain works. Just like you don't need to know how CPU works. You can create websites with React without knowing how the CPU works, okay? So just like that, to create websites, to create dApps, to create user experiences on top of crypto and blockchain, you don't have to worry how it works. We're not here to talk about that. We're here to discuss how we reach the end goal. How can you build something like OpenSea where you can trade NFTs? How can you launch your own digital assets, digital collectibles? This is what we're here to speak about. You don't need to worry about how blockchain works. Instead, you need to worry about the tech stack on top of the blockchain. So this is an important distinction. So now you know that there is still a front end always. In order to use decentralized applications, we have to use a wallet like MetaMask, and this is normally a plugin in your web browser. And this MetaMask wallet can then connect you to the blockchain, and it can give the information to your website, to your front end from the blockchain. For example, users log in with MetaMask, you get their transactions, you get their NFTs, their tokens, their balances, everything that happens on the blockchain. Okay, so far so good. Now, this is a new technology. This is a new field. This is a whole new technological revolution that we're witnessing. And the tooling is something that we as community work a lot on, because at the end of the day, we want to have an experience where it's easy to build great dApps fast, all right? Because we need the dApps to be cross-chain. There are many different blockchains now. I mentioned a few, but ideally we want to be able to create some kind of experience and it works automatically cross-chain. Just like when you create a desktop app, you want it to work cross-chain. You don't want only to build for Linux or Mac OS or Windows. You want to be cross-chain. You create a website. You don't want it to only work on Chrome. You want to work on Firefox. So the same thing is, of course, with blockchains, that there are many different chains. But at the end of the day, we all desire cross-chain. So I'll be speaking about how you can do it easily, and how we can use React for a front end, that it works on all different blockchains, and also how to do it cross-platform. I mean, with all the tools we have now, you can use React, but you can also do it natively on mobile. You can do it in Unity, and so on and so forth. So the most important thing is that we have a goal here, and that is to learn how to build dApps quickly using React, but also you can use other technologies. I will briefly mention that. Now, when you think about use cases in crypto, you may have different ideas. Maybe you want to build, like we mentioned, some kind of NFT marketplace, some kind of wallet, some kind of DeFi dashboard where people can trade, they can see their assets, they can send their assets back and forth, maybe some kind of cross-chain application across different blockchains, and so on and so forth. But whatever idea you may be having in crypto, and if you're new to crypto, you probably have no ideas because this is all new to you, but it's okay. The most important thing is that you get interested, you get into this. But whatever idea you have now, or that you may have in the future when you learn a bit more about crypto, you still need to do the basic things like log in a user. All dApps, all decentralized applications on Ethereum, on other blockchains, they need to log in a user. They need to fetch the balances of the user. So this is basically how many ETH I have, how many Matic I have, how many Binance coins I have. You need to fetch transactions, you need to fetch events, smart contract events. And we haven't yet spoken about smart contracts, but smart contracts are basically small applications that are running on the blockchain. If you want to program money, you have to deploy smart contracts, which is basically a small piece of software. If you normally it is 100 lines of code, 200 lines. It's not more than that normally. It's quite short, and that program defines how money flows. If I deposit funds into this program, what should the program do with it? Should it lend it out, earn interest? Should it send it to that person if that person does something else? So you can program however you want it. But all dApps need to be able to monitor what's happening in these smart contracts. All dApps need to be able to do it in real time, because you need to be able to update the UI in real time when something happens on chain. All dApps need to send transactions, and all dApps also need to index the blockchain. But don't worry about that. It's a bit complex for this intro situation. Now, the problem is you can do this from scratch. And if you do this from scratch, you're going to be reinventing the wheel. To do it from scratch, you normally speak to an RPC node. And RPC node, it's kind of like the CPU of blockchain in the sense that it's very low-level technology. It's not very good at being a database. It's not very good at being something you can query data from. It cannot really do queries. I mean, you cannot do filtering or aggregation. And normally what you end up doing is that you build this huge backend infrastructure around it. So what you should not do is build this yourself, because we do have a solution that we're open sourcing soon that does all of this. And this is what Moralis does. And this is what our project is doing. We're doing a standard solution for all of this that you don't even need to know how blockchains work, because our whole mission here is that even if you come from web, you come from mobile, you don't need to know what a blockchain is, how it works in order to start building. Because right now, without Moralis, the barrier to entry is quite high. So normally, when you have a blockchain application, you have to do things such as, for example, verify signatures of your users, do an API, do a database, sync transactions yourself, all of that. But you don't need to do it with the way I will show you in this presentation, which is that you use the Moralis stack. Because not only do you need to build this, you also need to maintain it, to debug it, and scale it. So of course, we don't want any of that. Instead, I will show you how to do it easily and how to do it in a managed way, where this is already managed for you. And you can host it yourself if you want, or you can use our solution that I will explain soon. But the whole idea here, instead of building this mammoth of backend crypto infrastructure yourself, and to build this, you need to learn how crypto works. You really need to dig deep. What if there was a solution? And what if it was already prepackaged with a nice SDK? And that is exactly what we're here to discuss, which is because Moralis SDK, Moralis server is that solution. The whole point here is that blockchain applications normally need a middleware between the blockchain and the front end. So between the blockchain and your React app, you need the middleware. And here is where you can run a Moralis server that solves a lot of that. In a sense, it's kind of like Firebase of crypto, because but that you can also self-host, because it fetches all the transactions in real time, it fetches all of the events in real time, all of the balances in real time, all of the tokens in real time of the users. It keeps your database up to date. Kind of like when you log in with, you have Firebase application, you can easily add the Google login, Facebook login, and you can easily use their database. So in that sense, you can kind of compare it to that. And to use it, it's very simple. So let's say you want to log in user on any blockchain. So here's where we become a bit more practical. You would be just writing moralis.web3.authenticate, and instantly you get the MetaMask pop-up, which is this wallet, and the user can log in. And as soon as the user logs in, instantly in your Moralis database, you have everything about that user, like the balances, the NFT tokens, the transactions, and so on and so forth. If you are looking for a boilerplate for React, where all of this is already set up, you can just Google Ethereum boilerplate. You will find this this repository, which is very, very good. That is already set up with React, with all the hooks, with all the components, where you get all of this by default, where you can easily log in a user with MetaMask and you get all of their assets. But on a basic level, what happens is that as soon as the user logs in, the Moralis infrastructure fetches all of the transactions, all of the users, all of the NFTs, all of the tokens from the blockchain, and puts it into a Moralis database. And now, via a simple API, you can start querying this database like any other database. Most importantly, this database auto updates in real time. All right. And once again, you can self-host this yourself. And when it updates in real time, it means that as soon as your users move assets on chain, they do trades, they lend out funds, they do anything, you instantly have that in your database. And it all is auto-updating in real time. And the database instantly reflects the changes that are happening on chain. Now, to get transactions very, very easily, in vanilla JavaScript, it is Moralis Web3 account, get transactions to get all transactions, get native balances to get all the balances, token balances to get the ERC20 token balances, NFTs, you just write .get NFTs. And for all of this, we also have React hooks that you can get here. Use native balance, use ERC. So we have the hooks already figured out here in the Ethereum boilerplate as well. So you get both the vanilla approach and the React approach. And of course, this also works with React Native. This is why we're saying that it also works on mobile. That all of this, as soon as you learn just the basics of how to use this in your daily life, you can not only do web, but you can also do mobile crypto applications. And you can build this on this open financial stack yourself. And all in all, we just done 5 lines of code. We logged in user here. We got all of the transactions and everything about the user in the database across all different blockchains that the user is active on. And then we have 4 more lines of code here to get the basic information about their on-chain activity and on-chain balances. And all in all, we've just built a wallet. We've just built the cryptocurrency wallet in 5 lines of code. So blockchain development is not difficult. I mean, you see, anyone can do this. You've gone to JavaScript course for 5 days. You know this already, how to use some simple functions. And of course, if you use React, all of the hooks, all of it is here as well. And to find this, you just Google Ethereum boilerplate, and this is going to be the first result. So that's the first part. The second part that I mentioned is that I want to mention that I already showed you is that you can do any query you want. So you can create any SQL or MongoDB query you want in order to find specific data in your database that is getting synced from the blockchain. So your Moralis database is like a mirror, like a reflection of the blockchain. And you can run any query you want. Let's say you want to find who has spent the most tokens in your application. You can easily do it with some simple filtering, some simple aggregation. Or who has done the most volume, you can easily do that. Or who is the most valuable player for your game according to some different on-chain metrics. You can do that in case you do an NFT game, for example. And most importantly, you can do subscriptions. So Moralis is based on the open source parse framework for all of this database. And that's also why it's so easy to get real-time alerts for on-chain events. So for example, when you have token transactions are called ERC20 transactions. Token transactions, you can easily snap them up in your frontend if you're using React. And we have all the hooks already here as well. Just reminding you all, because this presentation is in vanilla, but all the React hooks are also there. So if you have never used crypto, you've never done anything in crypto, you see, this is not rocket science. And this is also what I want to encourage you to try. I mean, to try to understand how it works, because this will really give you a whole new perspective on programming. You realize that as a developer, you have so much power. It's not only that you can do some front end, you use React, you do some front end, you speak to some database. I mean, if you still are in that world where you just, speak to some database, you've been missing out on this whole Web3 revolution where you can program money, and you should quickly go into that direction as soon as possible. Because, today in the world, there are so many React developers that can speak to database, read from API, nothing special. But you learn crypto development, you learn Ethereum development, it's a whole other dimension. It's a whole other it's like, trying out internet for the first time in the early 90s. I mean, this is the magnitude we're speaking about here. So the first thing you should do if you've never tried crypto is to at least install MetaMask and poke around in the different apps to see the magic. And then next step is to build. Is of course to build, and this is what we're speaking about here. Indexing smart contracts, let's skip that. All in all, the most important thing here is that we have prepared everything for you on a silver plate. If you go to docs.morales.io here, docs.morales.io, we take it from scratch. I mean, we take it really from scratch. We explain to you how to set up your Morales server. We explain to you what it does, that there is on-chain assets, on-chain transactions, on-chain things happening, on-chain events happening. And there is also a need for this off-chain backend. And this is what Morales provides. This is the off-chain library that can read and index all of this data and give you a nice SDK so you can use it from your React or whatever frontend you want. So this is quite important. And then here on the left, you can see, for example, how to log in a user and how easy it is, what we already discussed. We have YouTube videos here for everything. You can see how to send transactions easily back and forth. It's Morales.transfer. You can send any asset to any wallet with one line of code programmatically. You can get all kinds of information about DeFi protocols, the different liquidity pairs, and so on and so forth. All in all, I think it's better that we go into Q&A soon, because it's all about how much, guys, of course, you know about crypto. I can go very deep here, speak about DeFi or IPFS, but I think it's better that you tell me what you want to hear. Finally, before we go to Q&A, let me show you something else, because everything we've been discussing this far, of course, is groundbreaking, especially if you've never tried crypto, but there is more. Okay? There is more. What is more? It's plugins. I mean, in a way, Morales is kind of like WordPress of crypto. WordPress, you can build plugins, you can use different plugins. So in that sense, Morales is similar, that you yourself can build plugins that other developers can use. Maybe you have your own tech, your own infrastructure, your own kind of idea, app, service, and you want other crypto developers to be able to interact with it, to integrate it. You can easily build a plugin, and soon we will open this up for third-party developers to be able to deploy and distribute their plugins also. But in that sense, you can think of Morales also kind of like WordPress, because you know how everyone's dApps are structured, which means that you can now build on top. You can build on top of their infrastructure. If they install your plugin, you can enhance their app. So some plugins we have, for example, now is the Fiat plugin, where you just write one line of code like this, and you can buy tokens and cryptos with your credit card instantly from your app. You just wrote one line of code. This is how easy it is. Or if you want to swap one asset to another, you write oneinch.swap, and you can go and swap whatever you want, any cryptocurrency to any other cryptocurrency. You want to buy or sell different NFTs, you can use the OpenSea plugin. So plugins are a very big thing, and especially in crypto, because it's so much tech, so many projects. And what we're working towards now in crypto, in terms of the industry news, what's changing in the industry, is that we are building up this tooling, like WordPress did for internet, or like Firebase did for the web. I mean, the same thing now is happening with crypto. We need to build up this tooling, and that's what Morales is doing to a big extent. But another, finally, before we go to Q&A, is this. There are many different blockchains, and they all work differently, and they all look differently. Solana is very different from Ethereum, for example. Elrond is very different, but all of them need exactly the same things. You remember, all of them need to log in user, fetch balances, get transactions, all of that. So this means what? This means that you can have a unified cross-chain SDK, and this is what we are working on with Morales. I mean, this is the whole idea, that no matter which chain, no matter if there are new chains tomorrow, Morales is the unified layer on top of all of them. So in that sense, you can also compare Morales to kind of like Windows, Mac OS, in the sense that it's you build something on Windows, you're not worried that tomorrow there's going to be a new CPU and your app doesn't work anymore. Windows will take care of that. The same thing is with Morales. There's a new blockchain tomorrow, your app will still work. And this removes a lot of uncertainty, because many people, they want to build in blockchain, but they don't know which chain. There are 100 different chains. Which one do you pick? So with Morales, you don't have to pick. You build on Morales, it works everywhere. So we've been covering a lot. And look, this is like the tip of the iceberg. You can build in React. You can also build in any other framework. And I think it's good if we go to Q&A. I also encourage you to go to our YouTube channel, by the way, because we show a lot how to build things there in our YouTube channel. And it is Morales Web3. Just YouTube Morales Web3, you'll find it. And join Discord. if you take the step to become a crypto developer, it's join Discord. You go to morales.io/mage, you can join Discord. But all in all, look, I know that this is a lot of info, especially if you've never used crypto, you never did anything in crypto, you just a React developer, but it's okay, because I encourage you to take baby steps. And the first thing, if we go back to the beginning, is that you need to try this. I mean, try Uniswap. Go to Uniswap, Google Uniswap, and try to trade some assets, okay? Go and sell and buy and sell some NFTs. You need to try it, because I can talk about crypto all day long, but if you don't see the magic, it's gonna be it's like me speaking to you about how to ride a bike. You've never ridden a bike. I can be speaking for weeks here about how nice it is to ride the bike. You still need to do it yourself. But I can make a final remark here. It's kind of like, you see, imagine you go to any financial fintech app and they instantly know who you are because you have a wallet connected. You can instantly do transactions. This is what crypto feels like. It's like how the fintech world should work from the beginning. I have my identity. It is in my wallet. I go to any financial app on the internet. They know me already. They know all my assets. They know all my history already. I can use the same identity everywhere. And most importantly, you can build your own financial applications. You can build your own ideas. It's the biggest financial sandbox for developers. And yes, let's do questions, guys. And we can go deeper into something. But I need to have some input from you guys, what you want to hear. So on that note, final call to action. If you are new, try this. And also, if you want to develop, you search Ethereum boilerplate. And you go here and you start tinkering. And if you want help, join Discord. So that's it. Let's go to Q&A.
Oh, whoa, Ivan! It was really exciting to hear about all of this interesting stuff. It's really complicated for me, as this topic about Web 3.0 is something new for me. It's a new concept, but
yes,
I've heard it getting hot and hot day by day. So yeah, I would love to dig deeper into the Web 3.0 world. We have a few questions. Yeah.
Let's take last 20 minutes. Let's go deeper into what you guys want, because it's yeah, I don't know exactly which topics you want. Should we take the basics more? Should we be more towards, like, if you don't know anything about crypto, we shouldn't even be talking about React, because you need to understand like the concepts. But yeah, let's take the questions.
Yeah. So the first question: how secure is your database? So I believe it's all about the security with the approach you have presented.
Yeah, well, we use industry standards to secure the database. And the most important thing is that in the near future, you can host it yourself. So you can secure your database yourself. But at the end of the day, our database is used, number one, mostly for public known info. So it's not like you're storing anything secret there anyway. It's publicly known info from the blockchain. But yes, it is about your users that use your DApp. And we, of course, use industry standards to secure it. And we work with professionals in order to secure it. But at the end, the most important thing to know here is that you can also host it yourself in the near future. And that's our goal, that you can secure your own database. And if you want it hosted, we can also host it. So it is kind of the approach that you see in WordPress is a good example. You can host your own WordPress. You can secure it yourself with your own server and infrastructure, or you can host it in WordPress.com. So it is the same with us. It's up to you how you want to do it.
Yeah, a very flexible solution. So I believe it depends on the use case and business requirements and all the technical decisions from the architectural perspective. But it's good that there is a few options how to achieve the nice level of security. So let's move forward. Another great question. Gathering data from a blockchain is a costly operation by itself, isn't it? How can Morales be real time?
It's a good question. So the difficult thing, it is this, that blockchains, the RPC node, which is your window into the blockchain. RPC node is basically what holds all the blockchain data. As we discussed in the presentation, it's actually very bad at giving you the data. And that's why you need something like Morales, so you don't have to build this infrastructure yourself. Because normally this is how you would be doing yourself on a big level. And with Morales, you don't have to do it. And all in all, it comes down to it's combination. It's combination of big data, because it's terabytes and terabytes of data. There are thousands of transactions each second. So it's a combination of big data and to be able to scale it massively. So it's a big engineering task, and that's where most of our day goes to, how to read from all the blockchains, because remember that we're also cross-chain. So our task here is that we need to read from all the blockchains, we need to index the data, and we need to push it in real time. So it's a big engineering challenge, and that's also what we're doing all day long, but it's completely correct. Reading blockchain data, it's not an easy task, and that's why it's good that we have frameworks like Moralis to be able to do it easily. So because the last thing you want to do as a developer is to do this, to read data from the blockchain and figure out an engineering solution. It's like, you're speaking to the CPU when you want to build a website, and trying to parse the binary instructions. It will never work. Instead, you need abstractions in between, and this is what Moralis provides, so you don't even need to worry about that.
Yep, great. Another question. So do we have to disclose our secret key at any time, and
No.
Is it safe to?
So you should never disclose your private key. So the private key is your identity on the blockchain. So your funds are connected to your private key. So if I have your private key, now I can steal your funds. I can be you on the blockchain. So you should never disclose your private key. And there are different ways of storing your private key, like, for example, hardware wallets, which is this USB-like device which you can connect to your computer, but it holds the private key so that your computer doesn't hold it. Because ideally, you don't want your private key on the computer which is connected to the instrument. You want it on this hardware wallet, we call it, that you can then connect to the computer, and then you sign transactions via the hardware wallet. So you should never disclose your private key, and that's a very important rule of thumb. And with Moralis, you don't have to do that, because users, when they log in with Moralis, when they use your application, for example, and you use Moralis to log them in, they never give out their private key. They just sign. They sign that it is them, and that's enough. So we just get the signature that they confirm that it is them, and no one's private keys are ever disclosed.
Great. Thanks for the answer. Another great question from someone who wants to start the journey with Web 3.0. So my name is Daniel. How can I learn more on this? I'm very interested in this.
Well, the first thing you should do, if you've never used cryptocurrencies, is to use them, because it doesn't matter if you have not used them, you will not understand what we're talking about. So I would say go to MetaMask, set up a wallet. First thing, MetaMask, set up a wallet. You can YouTube. I mean, there are many great YouTube tutorials, like MetaMask tutorial. You can Google MetaMask tutorial, then buy some Ether with your credit card, so you have some cryptocurrency that you can actually use, because you need cryptocurrency to use all of this. So you have some Ether, and then go and trade it towards a other token on Uniswap. I mean, this is like the basics, I would say. Install MetaMask, get some Ether, start trading. So you feel what it is. You've used the blockchain for a different transaction. You can lend out money and earn interest on, for example, Aave, or you can borrow it as well with a collateral. You can trade it. So do all of that. So that's number one. Number two, now that you know what MetaMask is, now you have seen how different apps interact with you, how you interact with different apps with your wallet. You've seen it yourself. You've tried it. Now you can Google Ethereum boilerplate, like this, Ethereum boilerplate. You will find this link right here, and it's just Ethereum boilerplate, Ethereum. Yeah, so you find this, and you see here, it's a boilerplate with all the different like wallet transactions. It's very easy to run. You just write yarn install, yarn run, and you have it in your local host, and then suddenly you kind of have your own version of Uniswap. I mean, and then you can start tinkering. You can see the magic there. But this boilerplate basically gives you a set of features that is very common to all decentralized applications, and you will realize how simple it is, and also how similar it is to all of these big dApps that I show here. So Uniswap is this one with trading, OpenSea for NFTs, Aave for lending. So go and try that, and then of course join our Discord, which is moralis.io/mage. Like, if you want to learn and you want to have a community, go here, and we can teach you, no problem.
Great, thanks for the explanation. Now I know too how to start the whole journey, so it's valuable information also for me. Okay, so another question. What are the costs on the self-hosting option?
So self-hosting, we're going to open source. We hope in November that we can open source it fully. And self-hosting, it all depends on you. I mean, at the end of the day, it's your server, and it depends on how many users you have. When do you run out of RAM, CPU? So you have to scale. So it's very difficult to say. It's kind of like asking, what are the costs to host your website? It all depends what your website is doing. If it's just a blog, it's $10. If it's Google, it's hundreds of millions. So yeah, it's difficult to say because it all depends on what you do. When a transaction happens on chain, what do you do with it? You save it, you do some calculations. So it's very difficult to say. But if you go to Moralis, you can see our pricing for like our own for our own hosted. So you can see it there. But when it comes to yourself, it's up to you really what kind of use case you have and what kind of machine you'll have.
Okay, thanks. So now we have time for the very last question. So someone is wondering, what can you do other than crypto and NFTs?
Yeah, NFTs. Yeah, so at the end
NFTs.
of the day, at the end of the day, it all comes down to building the financial stack, but opening it up. For example, what we're seeing right now, which is very exciting, is tokenized real estate. Basically, that you can take $10, you can buy real estate on the other side of the world with it as a token. I mean, this is coming to Uniswap that you can do it. Somebody living, let's say, in Southeast Asia can now invest in European real estate with just $5, $10. I mean, this is what's opening up so much access to finance. So I think tokenizing the real assets is one thing. Then you have prediction markets where if you think that this person's gonna win election, I think that person's gonna win election, we can have prediction market on chain, basically betting on chain, peer-to-peer. I mean, that's quite mind-blowing as well, because now we have so-called oracles that can provide real-world information. So you can say, hey, if this happens, like if this person wins election, or if it's cold outside, send money here. Otherwise, send money there. I mean, it's very simple things, but it's also very mind-blowing in comparison that this is completely impossible without crypto. So it's some examples. And the most important thing is just the beginning. It's like me here speaking about the internet in the 90s. Look, I don't know what the big use case is going to be. Just like in the 90s, you speak about the internet, you don't know what's going to be in 2010 and 2020. But what we're seeing right now is some examples. And go to moralis.io/mage. You become a Moralis mage, as we call it, part of our community. We can explain you more in the Discords.
Excellent. Really, really great presentation, great answers. If you guys want to know more, just reach Moralis, reach Ivan, and that's what I'm going to do. Thank you a lot, Ivan, and I wish you a great evening.
Thanks, Tommy. Thanks, guys, for watching. Goodbye.
So yes, guys, today's event is almost over. We have still one day in front of us. Tomorrow is the senior track for the React Global Summit. And for tonight, that's it. It was a pleasure to be a host for those 4 presentations. And yes, from my side, I can say that we will see each other tomorrow. I will also lead the senior path, and from my side, I wish you a great day, great evening, and see you tomorrow, guys. Thank you.
Thanks so much to Tommy. We are eager to see him tomorrow. He'll be moderating for first 2 blocks. And I just have a couple last words left. So thank you personally for myself for being with us, especially to those who watched the whole conference. And earlier, Anna mentioned that we will have a giveaway of 10 JetBrains promo codes for their free annual products. So basically, we have 5 left, and I'm just gonna copy them right here in the chat. So for those of you who are still watching, so like it's first come first serve, So let me just no. So I'll just copy the link first to the platform and where to redeem these codes. And now I'm gonna copy 2 of the codes to our platform and 3 to YouTube. I think this should be all right. Okay, and 2 more. Let's go. All right. Yeah, all 5 codes should be in the chat already. So yeah, I hope to see you everyone, or most of you, tomorrow. And we have just a couple last words from Anna. Bye.
Hi again. I want to say you huge thank you for being with us this long day. I hope that you had a lot of fun. I know that you won a lot of amazing prizes. And I would love to see all of you at our next React Global Online Summit, May 2022. See you there!